Hello. Okay. Good morning, my dear students. Yesterday we have completed magnetism and matter. In that again some definitions: magnetic susceptibility, magnetic permeability, magnetization, intensity of magnetization. Those are just related to the pure theory points. So you may go through them. And so today let us start electromagnetic induction. Today and tomorrow both are electromagnetic induction only. And today let us discuss Faraday's laws of electromagnetic induction. Then after let us go some sums. Now, electromagnetic induction we can abbreviate it as EMI. So what is the meaning of electromagnetic induction? Before going to know the principle of electromagnetic induction, first of all let us discuss, so what is the meaning of magnetic flux? That is the symbol pi, I am taking that. So this is the magnetic flux. So what is the magnetic flux? Just like electric flux only. So the number of magnetic field lines passing through a surface normal to it is called as the magnetic flux. For example, let me take, so this is one circular surface, and so the area vector, so the area vector is always perpendicular to the plane of the surface and always can be taken as outward. For example, if you take our board as the surface, and so its length into height gives the area of that magnitude of the area, and its direction is always so perpendicular to the surface of the given plane and always outside, not into. So as our convenience purpose we can take the direction of electric field is the direction of area vector is always so out of the plane of the surface, means like this. Therefore if you consider, so this is the one of the plane of the one of the circular plane, and it is a magnitude of the area is A. Now if you take this is can be taken as what? Area vector. That area vector I am taking that A bar. So in this so number of magnetic field lines are passing like this. So these are the magnetic field lines, all are I am taking the uniform magnetic field lines, and they are coming and they are entering into the surface like this. So magnetic fields are passing like this. Therefore now, so you can take this is the magnetic field direction, and so the direction of magnetic field makes with the area vector, for example theta, I am taking that. So theta is the angle between field vector and area vector. So here what are these all? These are the magnetic field lines, so which are so passing through the surface as I have said. Now, so the magnetic flux can be defined as the number of magnetic field lines passing through a surface perpendicular to it. That is the magnetic field, magnetic flux. But how can you define mathematically? So as per the mathematical definition, the magnetic flux symbol is pi is equal to, you can take the dot product of field vector and area vector. Dot product of so magnetic field vector and area vector of any surface, so gives the, so what, that is the qualitative calculation of a magnetic flux. Therefore magnetic flux in general number of lines passing through the surface, right? No, but so as per the mathematical definition it is equal to dot product of the field vector and area vector you can take. And so if you remove this a dot product, you can say what, that is the, so B A cos theta. Here you have to keep in mind B A cos theta, where B is the magnitude of the magnetic field, A is the area of that particular surface, theta is angle between area vector and the field vector. Sometimes if they will give that, for example if you consider this is a plane surface, sometimes they will give this angle also. If they will give this angle, for example alpha, then what is the theta? Theta is equal to, you can say what, Nana? That is the 90 minus alpha, you can take that. Okay. So sometimes to confuse generally, so theta is the angle between area vector and field vector. So this is the field vector, this is the area vector, theta is the correct. But to confuse you, sometimes the angle made by the field lines with the plane of the coil or plane of the surface, if they will give the alpha, theta is equal to 90 minus alpha is the correct answer. So theta is always in between area vector and field vector. This is not in between field vector and the surface of the given plane. Therefore now theta is equal to B A cos theta, and this is the flux, you can take that. Now in this case what, if the theta is equal to 0, If theta is equal to 0, the flux is becomes maximum and it is the given by what that is equal to plus B into A. I am taking that. So means what? Whenever, so area vector and field vector both are in the same direction, theta is equal to 0. When theta is equal to 0, flux pi is equal to BA. This is called as a outward flux. This flux is called as a outward flux, and outward flux can be always taken as a positive. For example, if the theta is equal to 90 degrees, then if the theta is equal to 90 degrees, there is no flux. Flux is equal to what, Nana? So flux is equal to 0 only, because so theta is equal to 90 means cos 90 means area vector is this side and this is the magnetic field, and when two vectors are perpendicular to each other, in that case you can say what? So flux pi is equal to 0 means what? There is no passing of the lines of force through the given surface. Next what? If the theta is equal to 180. If theta is equal to 180 means that area vector is this side, but the field lines are coming into the surface means what? So both are in opposite direction. When both are in the opposite direction, theta is equal to 180. If the theta is equal to 180, now the flux pi is equal to can be taken as minus B into A. Why? Because cos 180 value minus 1, therefore flux is equal to minus BA. This can be taken as a inward flux. And inward flux always can be taken as what? Negative, and outward flux can be always taken as what? So positive. Therefore, whenever in the question inward flux or outward flux can be taken as negative, outward flux can be taken as what? So positive. Therefore, this is the magnetic flux case. And for the for example, if you take, so this is the one of the coil. Means what? One circular coil if you take. So now what? If there are the number of turns n, in that case the flux is given by flux is equal to pi is equal to n into B A cos theta. I am taking that, where n is the number of the turns of the given circular coil or any coil. So coil nothing but a closed loop with a multiple number of turns is called as a coil. Therefore, now if instead of your circular surface, if you take this is a coil or circular coil or any other coil or any square or rectangular or any other shape, therefore now for n number of the turns, the flux is given by pi is equal to nba cos theta. This is only for the single turn, and this is the multiple number of the turns n I have taken. Now, now what I am taking here? So next what here? So next, for example, what is the SI unit of the flux? Now flux formula, so pi is equal to what you can say? B into A. Of course, cos theta does not having any unit. Theta having the unit, but cos theta does not having any unit. Therefore, flux pi is equal to B into A. You can take and flux pi is equal to, so B unit what? That is so B SI unit is what? Tesla, and this is the area meter square. Tesla meter square is nothing but what? That is a Weber. So the SI unit of the magnetic flux is equal to Weber. So 1 Weber is equal to how much now? 1 Weber is equal to 1 Tesla meter square. And the CGS unit is the Maxwell. Maxwell is the CGS unit, and you know 1 Weber is always equal to 1 Weber is always equal to 10 power 8 Maxwells. Therefore, now sometimes if they will give the magnetic field, magnetic flux in terms of the Maxwell, we can convert into Weber first. Therefore, 1 Weber is equal to 10 power 8 Maxwell. 1 Maxwell is equal to 10 power minus 8 Weber. Therefore, this is the small introduction of the magnetic flux concept. Next. So, what is the change in magnetic flux? Generally, so what is the flux formula we have taken? Flux is equal to NBA cos theta. So, this is the flux formula already we have given. Now, in general, number of turns we have to keep the constant. In almost all problems, we can keep the n value constant. When n value constant, to change the flux, what we have to change? To change pi value, there are the 3 chances are there. So, we can change the B. By using the magnetic field, we can change the flux, and so we can change the flux by using the A, and we can change the flux by using the theta also. Therefore, by changing the magnetic field and area or theta, any one of them at a time, Any one of them at a time, if they are changing, then what? So flux is equal, flux also changes, and that change in flux is equal to given by, so delta pi is equal to n into, so delta of so B A cos theta. So delta B A cos theta. For example, now if only B changes, if only B changes, then what we can say, now the flux pi is equal to N A cos theta into, we can take what, that is the, so delta of B nana, that is equal to N A cos theta into delta B, nothing but what? Final magnetic field minus initial magnetic field. Means what? So when the magnetic field is changing from initial value B1 to final value B2, in that case, so the change in magnetic flux is given by pi is equal to Na cos theta. And here what? So in the same way, if only area changes, Nb cos theta, A2 minus A1 will come. If the theta changes, so N, so B, Nab, so cos theta 2 minus cos theta 1. So this is called as average change actually. So this is we can use for the average values change. Therefore, if it is the instantaneous changes, means what? We have to take the differentiation. Means what? So the d pi is equal to, so n is the common, so differentiation of B A cos theta. So these are called as the instantaneous change, and the first one is called as the average change. So delta d pi is equal to n into differentiation of B A cos theta. Means what? A very small infinitesimal change is called as the, so differentiational change, that is equal to, so d into B A cos theta. Here d is not any term, that is the differentiation of B A cos theta. Therefore, this is the flux one. Next, now if the magnetic field is given by B bar is equal to, for example, now I am taking that is a, so B1 I cap plus B2 J cap plus B3 K cap. This is the magnetic field I have taken. So next what I am taking that, so that is the area vector is given by area vector, for example, A1 I cap plus A2 J cap plus A3 K cap. Therefore, this is the area vector of any surface. Then what we can say, the flux formula, what flux formula as a given but, so B bar dot A bar. Therefore, so the dot product of means always x1 x2 plus y1 y2 plus z1 z2. So that is equal to the dot product means what? B1 A1, that is given by B1 A1 plus B2 A2 plus what? B3, so A3. Therefore, now B1 A1 plus B2 A2 plus B3 A3, this is the magnitude of the magnetic flux, so in the given concept. But in this case, if the surface is, if surface is in xy plane, if the surface is in xy plane, so to the x plane, who is the perpendicular? So now what is the area vector? Then area vector can be taken as only A3 nana. Means what? In that case, the magnetic flux is given by, so magnetic flux in the xy plane is equal to, just you can say what? B3 A3. Why? Because when the surface is in the xy plane, so the area vector is acting, so along the perpendicular the xy plane, means what? Along the z axis. Along the z axis means what? Only z components we have to take so B3 A3. And if the surface is in the yz plane, means instead of the xy, if they will give the yz plane, then yz plane is perpendicular to x-axis. Therefore, now area vector is acts only along the x-axis. Therefore, now that is given by, so in the yz plane, that is given by, so what? That is the yz means what? You can take a B1 A1, only x component will come. Next, if the surface is in the zx plane or xz plane, therefore now that is the, so flux through the zx plane is given by, that is equal what? That is equal to, so B2 A2. That's it. Therefore, now here, so xy, z is missing, take the z component only. And here what? Yz, x is missing, take only x component. Therefore, now what? So these are the magnetic flux when the surface is in the xy plane, zx plane or yz plane, like that. Therefore, now this is the simple case only. So formulas for this what? So pi is equal to B bar dot A bar. Now let us solve some sums better. Let us solve some sums. Now here a square plate of side length. They have given a square plate of side length how much now? That is equal to, they have given 4 centimeter, nothing but 4 into 10 power minus 2 meter. And so in a magnetic field of induction, magnetic field is given B is equal to 20 milli Tesla, and that is equal to 20 into 10 power, so minus 3 Tesla I am taking that. That is equal to, you can say, 2 into 10 power minus 2 Tesla. So in a direction making an angle 30 degrees with the plane of the coil, they have given alpha. Alpha is equal to 30 degrees, then you know that theta is equal to how much? 90 minus alpha, that is equal to 60 degrees. Now they are asking that, so what is the magnetic flux linked with the coil? I hope you may understand. Therefore, there is a one plane surface which is in the form of a sphere of side length how much now? 4 into 10 power minus 2 meter means what? 4 centimeter they have given. So this circular means, let us take that. Now imagine, for example, this is the square plane I am taking that. This length is given L nana, and of course it is the length L. Now this is if you take the area vector. Now what is that? That area vector I am taking that how much they have given A. So now what? So this is the magnetic field if you take. Magnetic field direction B bar, and but this angle given, so means what? Angle made by the plane of the coil, that is alpha, is equal to what? 30 degrees. But what we require? We require magnetic field makes an angle with what? That is the area vector, and that is a theta is equal to how much? It is a 90 minus alpha, means 90 minus 30 is equal to what? It is equal to 60 degrees. Therefore, as usual you substitute, you can get the answer. First of all, so what is the area vector now? Area is equal to L square, and that is equal to L means what? So 16 into 10 power minus 4 meter square, that is the area vector. Now, so A is equal to L square, 16 into 10 power minus 4 meter square. Next, what is the formula for it? Now, pi is equal to, so what here number of turns is equal to only 1. They didn't mention anything about the number of turns. Therefore, you can take only 1. Pi is equal to, you can take B A cos theta, that is equal to B. So, what is the B value they have given? So, B is equal to, so 2 into 10 power minus 2, B is equal to 2 into 10 power minus 2, and area how much you got? 16 into, so 10 power minus 4, and cos 60 value how much? That is equal to 1 by 2. Now 2 get cancelled, so is equal to what? 16 into, so 10 power minus 6 Weber. Therefore, this you can take 16 milli Weber is the answer. That is the 10 power micro, 10 power minus 6. Therefore, now what you can say, this is a 10 power, so micro Weber. This is 10 power micro Weber. Therefore, that is the answer for that. Next, one more question is now, for example, they have given, so B bar is equal to 2I cap plus 3J cap plus K cap, and A bar is equal to, so 3I cap minus 2J cap plus CK cap. So CK cap, C value they have not given, means what? Area vector A bar is equal to 3I minus 2J plus CK cap. So what is the value of C? What is the C value? C is equal to how much? If flux pi is equal to 0. To get the flux through the given surface is equal to 0, what is the value of the C they are asking? So now tell me, so what is the meaning of flux is equal to 0? When the flux is equal to 0, flux becomes 0. When? So when the angle is 90 degrees. Therefore now area vector and field vector both are perpendicular to each other. When both are perpendicular to each other, then the dot product of any two vectors is always equal to 0. Therefore now flux formula what I have given? Flux formula pi is equal to, so what? That is a B1 A1 plus B2 A2 plus B3 A3. Therefore to get flux pi is equal to 0, they only said no. Flux pi is equal to 0, then what? B1 A1. So 2 3s are, so that is 6 I am taking that. Next what? So B plus minus 6 plus B3 value is 2. So B3 is equal to how much? That is so B3 is equal to that is so 1 into, so A3 value is to C. Therefore now, so here what you can take, 0 is equal to, so 6 minus 0 plus C. Therefore C is equal to C is equal to 0. Whenever you substitute C is equal to 0, so what we can get now that flux is equal to 0, correct? So 3 2s are 6, so B1 A1, so B2 A2, so minus 3 2s are 6 plus, so 1 into C, therefore C is equal to 0. If you substitute, therefore now what? The flux so becomes what? That is equal to 0 only. Therefore, when you substitute C is equal to 0, automatically, so the flux becomes 0, means what? So up to 3I minus 2J enough. So this Z component should not be present. Why? Because C is equal to 0, we got it. Right? Therefore, now next. Next, one more question. Next, one more question. So, a coil of n turns and area A is placed in a uniform transverse magnetic field. So, if the plane is turned through 180 degrees about its diameter in 2 seconds, then the change in magnetic flux they are asking. So, what is the formula for flux formula? Flux pi is equal to N B A cos theta we have taken. NBA cos theta. So, what they said, if the coil is turned, so 180 degrees means what? If the coil is like this, it is turning through the 180 degrees. Therefore, now here N they will give, B they will give, A they will give, and only theta. For example, theta 1 is equal to 0, I am taking because initially I don't know. So, I am taking that theta is equal to 0, means initially area vector, field vector both are in the same direction. So, this is the area vector, this is the field vector, both are in the same direction. When you are turning the coil through 180 degrees, now what? Area vector and field vector both becomes what? Opposite direction. Therefore, now theta is equal to how much now? Theta is equal to 180. Now, they are asking that what is the change in magnetic flux? Here who is changing? Only theta changes. So, only theta is changing. When theta is changing, therefore, the flux pi is equal to what you can say? Number of turns is constant, B is also constant, area also constant. Therefore, what I told you, it is the cos theta 2 minus cos theta 1. Therefore, now you can substitute there. So, what? NBA. So, cos theta value what? That is the cos 180 minus cos 0. Therefore, now you can say that is equal to NBA cos 180 value minus 1 cos 0 minus 1. Therefore, now what? Here cos 0 minus cos 0 1, but here minus is there, minus and minus, that is equal to minus 2 NBA is the change in magnetic flux. Therefore, when a coil of number of turns n, so with area of cross section A placed in a uniform magnetic field B, if it is turning through an angle 180 degrees from any stage, right now 90 to 180 means 270, adu 30 to 180 na, I don't know. That's why initially I am taking what? Theta 1 is 0, theta is equal to 180. If initially it is a 30 degrees, so what we can say now, that is the, so theta 2 is equal to, so what 180 plus 30 is equal to how much? 210 you can take that, okay. But through 180, therefore, now we have taken 2 NBA is the change in magnetic flux. Next, Faraday's laws. Faraday's laws of electromagnetic induction. So, what are the Faraday's laws of electromagnetic induction? Let us discuss now. So, according to Faraday first law, for example, let us take one coil, this one. This is one circular coil, I am taking that. So, through this circular coil, for example, I am taking that some magnetic field lines are passing. Therefore, these are the magnetic field lines, and that magnetic field, for example, I am taking that B. For example, with respect to the time, if the magnetic field changes, means first of all 1 Tesla, next to 2 Tesla, next to 3 Tesla, means what? If the magnetic field value is changing with respect to the time, means what? B is equal to function of the time nana, means what? For example, B is equal to T square plus 2T plus 1. At the initial, what is the magnetic field? Initial means T is equal to 0. So if you substitute, you are getting that B is equal to 1 Tesla. Therefore, now what? So initially the magnetic field is equal to 1 Tesla. After 1 second, what? So T is equal to 1 second means what? 1. So 1 square, 1 plus 2 into 1. So 2 plus 1, 3, 3 plus 1 is equal to 4 Tesla. Means what? When the time changes, magnetic field also changes. So now with respect to the time, if the magnetic field changes, then what is that? So Faraday observed that. So in this coil, some EMF will be developed, some electromotive force will be developed. Means what? So this coil acting as a battery. Generally, so what is a battery? Every battery provides some electromotive force, and along with that, if it is having some internal resistance, we can take the battery as E comma R. Means what? Every battery having the two properties. One property is the electromotive force, one is the internal resistance. Right? No, this is one conductor, one wire we have taken. It is not a battery. But when the magnetic flux or magnetic field passes through this coil changes, Faraday practically observed that. So in this, some amount of the current will be developed if this coil is the closed coil. Or we are not connecting the battery. How the current will be developed means what? Compulsory current is developed means inside, so the wire acting as a battery means what? It provides some amount of the potential difference, nothing but electromotive force. Now practically said that, so this EMF will be induced in the coil as long as there is a change in magnetic flux or magnetic field. Means if there is a change, if there is a continuous change in the magnetic flux, then and only then induced EMF or induced current will be produced. So the current and EMF through this phenomena is called as the induced EMF and induced current. So this phenomena is called as electromagnetic induction. So the phenomenon of production of EMF or current, so by changing the magnetic flux in any coil is called as the electromagnetic induction. Therefore, first law is what? As long as there is a change in magnetic flux, then there is a induced EMF and induced current. Means what? If the magnetic field is constant with respect to the time, then there is no change in the magnetic flux. So when there is no change in the magnetic flux, then there is no induced EMF or induced current. Means what? The source of induced EMF is what? Change in magnetic flux. Flux compulsory has to change. If the flux remains the constant or magnetic field remains the constant, then so there is no chance to get what? So induced EMF. Therefore, first law is completed. What is that? As long as there is a change in magnetic field, magnetic flux, then there is a induced EMF or induced current in the coil if it is a closed surface. Next, what I am taking that. Now, Faraday's second law, he observed that the induced EMF is directly proportional to rate of change of magnetic flux. So d pi by dt they have given. The induced EMF, Faraday mathematically observed that the induced EMF in any coil is directly proportional to rate of change of magnetic flux. Therefore, now what you can say here, if you remove this proportionality, if you are removing the proportionality, you are getting one constant, d pi by dt, but according to SI units, we can take this proportional constant k is equal to 1. Therefore, now the induced EMF is given by, that is equal to d pi by dt, and this is called as a instantaneous value. This is called as the instantaneous EMF, instantaneous induced EMF, that is not average value. Sometimes they will mention what is the average value. As I told you, when they will mention average, therefore EA is equal to what? That is equal to delta pi by delta t you can take, that is also you can write pi 2 minus pi 1 by T2 minus T1. So EA is equal to delta pi by delta t, that is equal to pi 2 minus pi 1 by T2 minus T1 we have to consider. So that is the average induced EMF, and this is what instantaneous induced EMF. And but according to Lenz's has been observed that, if the magnetic flux in the coil tries to increase, the induced EMF and induced current opposes the change in magnetic flux or change in magnetic flux. Means what? If the flux wants to increase, the induced EMF generates the electric current, that electric current again produces the another magnetic field that is called as the induced magnetic field. So this is the applied magnetic field, and the induced current in turn produces the induced magnetic field according to Ørsted principle or Ørsted conclusion or Ørsted law. So what is Ørsted told? When a current passes through a conductor or coil, it produces a magnetic field. Therefore, if the flux increases, the induced current produces the induced magnetic field in opposite direction of applied magnetic field. So if the flux decreases, the induced current does not allow to decrease the magnetic flux. Now it is supporting the, it is supporting the magnetic flux again. Means what? It is not allowing to decreases, it is not allowing to increases. Therefore now, so in that case, so we can say the original form of induced EMF is given by minus whatever that is d pi by dt. I am taking that. So E is equal to minus d pi by dt. This minus indicates that induced EMF is always opposes the change in magnetic flux, and this is given by Lenz law. So that the direction of induced EMF, the direction of induced current or EMF is given by what? So minus. Of course, so EMF does not having any direction, current also does not having any current, any direction. But thing is that here, so induced EMF opposes. So that opposition or supporting given by the Lenz, therefore E is equal to minus d pi by dt. So this is the, our principle to solve the problems. Therefore minus d pi by dt in every formula compulsory you have to take the minus. So if you forget by keeping the minus in the options, plus answers, minus answers are there. That's why there is a disturbance. So be careful of that one. And so this is only for one term I have taken. For example, if you take n terms now. So if you take the n terms, now the formula becomes what now? E is equal to minus n into, d pi by dt you can take. This is for n terms, and that is what? That is the instantaneous value. This is the instantaneous value. If you take the n terms for the average, EA is equal to minus n into delta pi by delta t you can take. This is the average value of induced EMF. So if you keep this formula in mind, so remaining all factors we can find out. Next, for example, so what we got here? Now, so we have taken instantaneous induced EMF for n number of turns, d pi by dt we have taken, and what we got it? So average value of EMF is equal to minus n into delta pi by delta t we have taken, and delta pi by delta t nothing but whatever that is change in the magnetic flux per unit time. This means pi 2 minus pi 1 by t2 minus t1 you can take. Now, for example, if R is the resistance of the conductor, if R is resistance of the coil, if R is resistance of the coil, then they will ask what is the induced current. This is just induced EMF. So what is the current formula? So according to Ohm's law, now the current I is equal to what? So potential difference by resistance na. But instead of the potential difference, we have to take what? So induced EMF, that induced EMF you can take what? E by R. So if you want instantaneous current means what? We have to substitute that is equal to what? So minus n into, d pi by, dt by what? By R. And if you want, average, then what you can get now? So I average is equal to minus n into delta pi by delta t by what? By R you can take that. Okay na? Therefore now this is the expression for that, just for all of this. So what is that? The basic thing is this one. Next, current is completed. This is what? So induced current we talked about. Next, what? Charge they will ask. What is the induced charge? So now the charge formula what? So Q is equal to I into delta T. Correct? Because the amount of the charge formula what? Current I is equal to dq by dt, and that dq by dt is given by what now then? So dq is equal to I into dt. That's it. I into dt. If you substitute I value, how much now? That is equal to, if you substitute this I value, so what? Minus n into d pi by dt into what? Into r. So into this is the dt, right or not? Therefore now, so in place of the I, you substitute this value, and here what? dt cancel. Now what? The induced charge, for example delta q, you can dq you can take as the q only, no problem. So q is equal to what you can say? So minus n into, so d pi by or delta pi by, so r you can take. Therefore this is the induced charge because of the induction principle. So we are using this is the induced charge, q is equal to minus delta pi by r, right now. So what is the r here? Resistance. And here one important point is that induced EMF just depends upon the change in magnetic flux state. It does not depend upon the nature of the material. Means what? So if you take the coil made up of the copper, and if you take the coil made up of the aluminum, if you take the copper made up of the iron, so what? It does not depend on that one, because here, so there is no resistance, because resistance is different for different types of the materials. That's why, so resistance is giving the nature of the material. But you tell me, so what? It depends only on change in magnetic flux and change in time. It depends upon the time. If the flux changes rapidly, means fastly, means time is small, then induced EMF is more. If the flux changes slowly, means what? Delta t is more. Slow means what? Time taken is more. Fast means what? Time taken is very less. Therefore now induced EMF is more in that case. Okay. So slower the time, more, lesser is the induced EMF. Faster means what? So EMF is very, very strong. But here what? Current depends upon the time as well as nature of conductor. I mean, so nature of coil or resistance also. But induced charge. Yeah, this is the basic points. So current, EMF and charge depends on what factors, right? No? So this is the induced charge. Next, what about induced power? So induced power. So what is the induced power? Now the power is given by what? Power P is equal to V into I. So potential into, so current, but here in place of the potential we can take what? E you can take, therefore E is equal to, E is equal to minus, so d pi by, so dt, so into what? I is equal to what? So minus, so n into d pi by, so dt by r, correct? That's all, So now what? Otherwise you can take like this also direct, no problem. What is that? So this is equal to E square by r also you can take. E square by r formula. So minus into minus plus becomes what? So n square, therefore now what? That's for n square. So d pi by, so dt, so whole square by r you can take that. Therefore now what? This is the, so E square by r, so for formula, therefore this is the induced power vector. Right. Now let us solve some numerical problems. Right. One problem let us discuss. A circular coil of radius, this one, better one more. A small conducting loop of area, so 1 millimeter square is placed in the plane of a long straight wire at a distance of so 20 centimeter from it. Current in the straight wire changes from so 100 ampere to so 0 in 0.1 second. Find the average EMF induced in the, so current they are asking. So next what they have given that, one more question, better let us solve that. Instead of I will, let us solve that later on that question. Now the flux pi is equal to, so if pi is equal to t square plus 2t plus 5. Let us solve that question later, because that is a theoretical question. This is somewhat so easy question. I mean, so we can solve easily, because we have to write the question on the board. It takes them more time for that, because then the question it is. That's why one small question let us solve theoretically. So if the flux pi is equal to t square plus 2t plus 5, then find the first point is that find, first question, instantaneous. So instantaneous EMF. So at t is equal to 1 second. So at t is equal to 1 second. Next what? Second one is that average EMF. Average EMF. So between, so 1 seconds to so 2 seconds. between 1 seconds to 2 seconds. So that is what? So instantaneous EMF at t is equal to 1 second and average EMF between 1 second and 2 seconds. That is the expression they have given like that. So therefore now according to Faraday law, so what is that? So EMF is equal to, so induced EMF is equal to what? Minus d pi by dt. Therefore first of all, before that, here they are asking average value and so both value. Therefore now let us go for the, first of all I am going for the instantaneous. So first answer, what is that? E is equal to minus d pi by dt. So compulsory we have to take the, so integration, we have to take the differentiation. So and compulsory minus also we have to take, because so as I told you in the options plus and minus both values are present. So d pi by dt, here t square you will get what? 2t plus 2 into t, you are getting that 2 plus what? That is a 0. Therefore now you can say, so minus of minus 2 if you take the common into t plus 1 is the answer for that. But what? That is also instantaneous. So EMF, that also depends upon the time. Therefore at the time t is equal to what time I have given? At t is equal to 1 second. At t is equal to 1 second. Now what is the EMF? E is equal to minus 2 into 1 plus 1. Therefore E is equal to minus 4 volts. Be careful, as I told you, they will give the minus and plus options also, because if you forget the Lenz's rule as per that this minus, therefore now what? E is equal to minus 4 volts you want to get. So don't forget the minus summa. So E is equal to minus 4 volts is the correct answer. In the options plus 4 volts also is there. If you forget to take the minus, that option also will come. Therefore be careful. Therefore now next watch. So average value. So average value what I have taken now, that is given by, first of all, at time t is equal to 1 second. At time t is equal to what? T1 is equal to 1 second. Flux pi 1 I will take. Pi 1 is equal to 1 square, that is a 1. So 2 into 1 2 plus 5. So that is equal to what? That is equal to 8 I have taken. Next what? At the time, at time t2 is equal to, so 2 seconds. Now that is given by pi 2 is equal to 2 square means what? That is a 4 plus 2 2s are 4 plus 5 is equal to, that is equal to what? That is equal to 13 I have taken. So now what I am taking that? So here therefore the average average induced EMF EA is equal to minus of what? That is equal to pi 2 minus pi 1 by, so T2 minus T1. That is equal to given by, so minus so pi 2 value how much now? That is equal to 13 minus 8 by, so T2 minus T1. So T2 is equal to 2 seconds, T1 is equal to 1 second. Therefore 2 minus 1, so is equal to what? Minus 13 minus 8 is equal to 5. That is equal to what? Minus 5 volts. We can take the answer. Right, that is a minus 5 volts. So 13 minus 8 are 2 minus 1. That is a, so this is the, so what? Average, so induced EMF. Instead of this, sometimes they will also give that, so what? Resistance. For example, if they will give that resistance of the coil R is equal to, so 2 ohms, then they will ask what is the average current and what is the, so instantaneous current. Same question, but we know that what? That is the induced current. Instantaneous current what am I? Instantaneous EMF by resistance. How much you got? That is equal to minus 4 by 2. So because E value we got, induced in instantaneous EMF we got minus 4 by 2. That is equal to how much now? That is equal to minus 2 ampere. Therefore next, so average value is equal to E average by given resistance, that is equal to minus 5 by 2. That is equal to minus 2.5 ampere. Like this, all you can find out. Once if the flux change with respect to that time, so we can find out all values like this. Okay, na? Right. Now let's go. One more. For example, they will give like that. The number of turns of a coil, the number of turns of a coil N is equal to, for example, 100 I am taking that. So there is a uniform magnetic field. That magnetic field I am taking that B is equal to, for example, so 20, so millitesla I am taking that. This you take better 1000 and 20 millitesla I have taken. So now here the area of the coil A is equal to, so 1 centimeter square I am taking that. A is equal to 1 centimeter square I have taken. Right now, next what I am taking that now. So here if the theta value changes from T1 is equal to 30 degrees to and theta 2 is equal to, so 60 degrees, right now, then they will ask that. So what is the, so induced EMF, and if the resistance R is equal to for example 2 ohm, so what is the, so induced current. Right now, here what, theta 1 is equal to 32, theta 2 is equal to 60 degrees. That is not a instantaneous change, because so there is a change in so angle, so which is given by, so from 30 degrees to 60 degrees. Right now, then what we have to find out, so induced EMF and induced currents. So what I told you, so according to that, so first of all, change in magnetic flux, how much, Nana? Delta pi is equal to minus N B A, so into what, that is the cos theta 2 minus cos theta 1, because so 3 different points we have given or not, only theta changes, only field changes, only area changes. In that case, in this case only, so theta is going to be changed. Therefore, in that case delta pi is given by N value how much, that is equal to 1000, and so B value how much, so B is equal to, that is equal to 20 into, so 10 power, so minus 3, and area how much I have given, area is equal to 1 into 10 power, so minus 6 into cos theta 2 minus cos theta 1. So cos theta 2 is equal to cos 60, so cos 60 value how much, that is equal to 1 by 2 minus this is what, cos 30 value, so root 3 by 2 we have taken. Right. Therefore, now, so here you can get what? So this is the, so this is the 1000 and 10 power minus 3 cancel, and this is the 2 into, here 0 is there, 10 power, so minus 5, and here what we can get, 1 minus 1.732 by, so what, that is the, so 2 you can get it, or you keep the root 3 value as it is, because so not need to just let us take that like this only, root 3 by 2 we can take it. Next what? So 2 get cancelled. Now the flux what we got, that is equal to 1 minus root 3. So into what? Into 10 power minus 5 Weber we got. This is the, so change in magnetic flux. But what I am asking that, so induced EMF and sorry, here the time interval what, in a time interval, so delta t is equal to, for example, 2 seconds. This angle changes, so from theta 1 30 degrees to theta 2 60 degrees. So what time it is taking that? So delta 2 is equal to 2 seconds. In the 2 seconds, the angle is converting from, so 30 degrees to 60 degrees turning. Therefore now, so the induced EMF is given by, so E is equal to, so what, minus, so already we have taken N beta here. Therefore what you can say, that is equal to delta pi by delta t. Generally for N terms what I have given, E is equal to minus N into d pi by dt by taking the N common, but here already N I have used it. That's why once again don't take here. Therefore if you substitute there, what you can get now, 1 minus root 3, so into 10 power minus 5 by what, that is equal to how much I have given time, that is equal to 2 seconds. Therefore this is the volts, that is the answer for that. Okay, na? Therefore now sometimes they will give the easy angles only. Therefore now you can convert into that. So therefore E is equal to, so here minus we got it now, so minus 1 by root 3 by, so 2 into 10 power minus 3. And you know, so if you take the minus inside, because root 3 value is greater than 1. Therefore, so if you take the minus inside, so you can get the answer that is equal to root 3 minus 1 by 2 into 10 power minus 5 volts. So this is the final answer. And in the same way, we can find out what, instantaneous current also. Therefore, we got EMF is equal to how much, and also we have to get so instantaneous currents. What is the formula for current? I is equal to E by R. R value given how much? Resistance is equal to 2 ohm we have given, and induced EMF already we got. Substitute there, we can get the answer. Therefore, this is so one of the model problem. Next. Next, for example, the flux changes in a coil is given by with respect to the time. So, flux pi is equal to, that is equal to T square, so plus 3T minus 1. Then what is the induced charge? Q is equal to how much? Instantaneous current. At what point? At time t is equal to 2 seconds. What is the induced charge? If the resistance of the coil, for example, I am taking that 2 ohm and the number of turns n is equal to 100. Number of turns n is equal to 100 and the resistance of the coil is equal to 2 ohm and the flux changing in the coil with respect to time how much? Pi is equal to T square plus 3T minus 1 I have given like that. Therefore, they are asking what is the induced charge. So, at that time t is equal to 2 seconds. Right? Now, so what we can get the answer now? For example, now, so here we know that. So, first of all, so what is the charge formula? Charge Q is equal to minus n into, so d pi by what, that is equal to R only, right now. So what? So instantaneous, therefore d pi we have to find out with respect to the time. Therefore now what? So here pi is equal, therefore now, equal to 2 ohms only. Therefore now what you can get now, that is equal to minus 500 coulombs. Q is equal to minus 500 coulombs. We can get the answer for that. Next, next one. For example, now here one more question is the number of turns of a coil n is equal to, for example, 100 I am taking that. So now here, so the magnetic field changing from, so B1 is equal to 2 Tesla to, so B2 is equal to, this is, you take that better, 4 Tesla, B1 is equal to 4 Tesla 2 and B2 is equal to 1 Tesla. So in a time interval of, that is what, delta t is equal to, for example, so 3 seconds I am taking. In a time interval of 3 seconds, the magnetic field is changing from where to where. So what? That is equal to, so 4 Tesla to 1 Tesla. So then they will ask that. So what is the, so in resistance of the coil, for example, I am taking that R is equal to, so 10 ohm. And so here the time intervals B1 to B2, that is the field changing. Therefore now resistance is equal to 10 ohm and area of the coil A is equal to, so 10 what is that? That is, for example, let us take that 2 meters square and then they will ask that. So what is the, so induced EMF, what is the induced EMF and what is the induced current also they will ask that. Induced EMF and induced current, both we have to find out. Okay, so this is the, so information. See, so here field changing, right? So when the field is changing, so that is instantaneous average. It is not instantaneous because sometimes they will give that field changing like that. B is equal to T square plus 2T plus 1. When the magnetic field changes with respect to the time like that, therefore in such case we have to discuss, yes, that is the instantaneous so values, but this is the purely average value because field is changing averagely, not instantaneously. Therefore, what is the formula for that? That is equal to E is equal to minus, so delta phi by, so delta t given, and that is equal to what? That is equal to, so delta pi. Here who is changing? Only, so field is changing. Therefore, now what? Minus n a, so what? Cos theta. Okay, na? So cos theta into what? That is equal to, so B2 minus B1 by, so what? Delta t. This is the expression. But here what they have taken? So theta. What about the theta? In the question, in the given question, if they want to mention the theta value, so be careful that, so what? That is the, so theta is always equal to 0. Means what? The area vector, field vector, both are acting in the same direction. In such case, so now you can take what? So theta is equal to 0. Theta is equal to 0 means cos 0 is equal to 1. Okay, na? Therefore, if you substitute all values, you can get U is equal to minus. So n value how much I have given? So n is equal to 100 into area how much I have given? That is equal to, so 2 and into cos theta is equal to 1 and B2 minus B1. So means what? That is a 1 minus 4, 1 minus 4 and what I have given, so that is equal to, that is 3. Therefore now this is equal to what? Here 1 minus 4 minus 3, minus into minus plus, therefore plus 1000 100 into 2, so 3 by what? By, so 3 I am taking 3 cancel, that is equal to how much? That is equal to 200 volt is the answer. Okay, this is the, so induced EMF. And next what? So here we want the current also, the current value what? Current I is equal to E by, so R, and E is equal to, that is equal to 200, R value is equal to, so 10. So this is cancel, is equal to how much? 20 ampere is the correct answer for that. Okay, therefore now these are the, so problems from the Faraday's laws, and tomorrow let us discuss motional EMF and so mutual induction concept. So thank you.
Good morning, everyone. After a long gap, we met today. So this is Shrikant Sir Zoology. Yesterday, your previous zoology lecture has explained regarding excretory products and elimination up to RAS cycle, renin, angiotensin, aldosterone system mechanism is successfully completed. So today we are going to discuss about accessory excretory organs. Accessory excretory organs. Dear students, basically kidneys play a vital role in excretion. Kidneys play a vital role in elimination of nitrogenous waste materials. In human beings, along with kidneys, some other body organs also play a role in elimination of nitrogenous waste materials. In human beings, along with kidneys, some other body organs also play a role in elimination of nitrogenous waste materials. Such body organs are collectively called accessory excretory organs. Understood? Like lungs, liver and skin. Lungs, liver and skin. These three organs play a role in elimination of nitrogenous waste materials along with kidneys. Due to this reason, lungs, liver and skin are collectively called accessory excretory organs or supportive excretory organs. Now we will discuss individually. First one, lungs. Dear students, basically lungs can eliminate large quantities of carbon dioxide. Lungs can eliminate large quantities of carbon dioxide, approximately 200 ml of carbon dioxide per minute. Understood? Lungs can remove large quantities of carbon dioxide, approximately 200 ml of carbon dioxide per minute. So we have learnt about basic fundamental characteristic features of oxygen transport as well as carbon dioxide transport in previous chapter, breathing and exchange of gases. So 100 ml of carbon dioxide can deliver 400 ml of deoxygenated blood can deliver 4 ml of carbon dioxide from tissues to alveoli of lungs. But 100 ml of oxygenated blood can deliver 5 ml of oxygen from alveoli of lungs to tissues. Please keep it in your mind. Lungs can eliminate large quantities of carbon dioxide, approximately 200 ml of carbon dioxide per minute. Along with carbon dioxide, lungs can also eliminate significant quantities of water every day. Along with carbon dioxide, lungs can eliminate significant quantities of water every day. Understood? So you have to keep special focus on these two salient features, dear students. So listen here again, lungs can eliminate large quantities of carbon dioxide, approximately 200 ml of carbon dioxide per minute. Along with carbon dioxide, lungs can also eliminate significant quantities of water every day. Understood? And next accessory excretory organ is liver. My dear students, Liver is the largest gland in our body. We have learnt about that statement in previous classes. Liver is the largest endocrine gland in our body. So basically, liver secretes bile juice. Liver secretes bile juice. Basically, bile juice is yellow green in color. Liver secretes bile juice. Bile juice is yellow green in color. Here, bile juice contains bile pigments. Bile juice contains bile pigments. So bile pigments are of two types, namely bilirubin and biliverdin. Bile pigments are of two types. Number one, bilirubin, and second one is biliverdin. And bile juice also contains cholesterol, degraded steroid hormones, degraded steroid hormones, degraded vitamins, and degraded drugs. Got it? Liver secretes bile juice. Bile juice contains bile pigments like bilirubin and biliverdin. Along with bile pigments, bile juice also contains cholesterol, degraded steroid hormones, degraded vitamins, degraded drugs. All these substances will be eliminated from our body. All these substances will be expelled, will be evolved, will be eliminated from our body along with digestive wastes. Understood? Bile pigments like bilirubin, biliverdin, cholesterol, degraded steroid hormones, degraded vitamins and degraded drugs. All these materials, all these substances will be expelled out from our body along with digestive waste materials. Understood? So once recapitulate what we have discussed. Lungs can eliminate large quantities of carbon dioxide, approximately 200 ml of carbon dioxide per minute. Along with carbon dioxide, lungs can also eliminate significant quantities of water every day. Liver secretes bile juice. Bile juice contains bile pigments like bilirubin, biliverdin. Along with bile pigments, bile juice also contains cholesterol, degraded steroid hormones, degraded vitamins, degraded drugs. All these substances will be emerged out, will be expelled out from our body along with digestive waste materials. Got it? So, one more accessory excretory organ is remained, that is skin. Lungs, liver, skin. These three are collectively called accessory excretory organs. Right. Skin. Dear students, skin is composed of two types of glands. Our skin includes two types of glands. Number one, sweat glands. Number one, sweat glands. And second one is sebaceous glands. Okay. Skin includes two types of glands, namely number one sweat glands and second one is a sebaceous glands. Here sweat glands eliminate sodium chloride. Sweat glands can eliminate sodium chloride, small amounts of urea and lactic acid. Sweat glands can eliminate sodium chloride, small amounts of urea and lactic acid. These three substances will be eliminated from our body in the form of sweat. In the form of sweat. Basically, sweat glands secrete sweat. Sweat glands secrete sweat. Through sweat, sodium chloride, small amounts of urea and lactic acid will be excreted out. Got it? Sweat glands eliminate sodium chloride, small amounts of urea and lactic acid in the form of sweat. And next one, sebaceous glands. Dear students, sebaceous glands secrete oil-like substance. Sebaceous glands secrete oil-like substance called sebum. Understood? Sebaceous glands secrete oil-like substance called sebum. My dear students, basically sebum forms oily protective layer. Sebum forms oily protective layer over the body. Understood? Sebaceous glands secrete oil-like substance called sebum. Sebum forms oily protective layer over the body. Sebaceous glands can eliminate. Sebaceous glands can eliminate waxes, sterols and hydrocarbons. Got it? Sebaceous glands can eliminate waxes, sterols and hydrocarbons in the form of sebum. In the form of sebum. Sebaceous glands secrete oil-like substance called sebum. Sebum forms oily protective layer over the body. Sebaceous glands can eliminate waxes, sterols and hydrocarbons in the form of sebum. My dear students, along with the lungs, liver and skin, along with lungs, liver and skin, even saliva also eliminates little amount of nitrogenous waste materials. Understood? Along with liver, skin and lungs, even saliva also eliminates small amounts of nitrogenous waste materials from our body. Understood? So accessory excretory organs successfully completed. So once recapitulate what we have discussed. Sweat glands eliminate sodium chloride, small amounts of urea and lactic acid in the form of sweat. Sebaceous glands secrete oil-like substance called sebum. Sebum forms oily protective layer over the body. Sebaceous glands can eliminate waxes, sterols and hydrocarbons in the form of sebum. So just now we have learnt about lungs. Lungs can eliminate large quantities of carbon dioxide, approximately 200 ml of carbon dioxide per minute. Along with carbon dioxide, lungs can also eliminate significant quantities of water every day. Once analyze. Okay, dear students, I hope you people have understood regarding accessory excretory organs. Right. So, my dear students, we have learnt about diabetes insipidus previously. Yesterday, sir has explained in detail regarding diabetes insipidus. Diabetes insipidus is caused by the deficiency of antidiuretic hormone or ADH, otherwise known as vasopressin. Now, we are going to discuss about diabetes mellitus. Diabetes mellitus. So, pancreas is commonly considered as mixed gland. Pancreas is commonly considered as mixed gland because pancreas includes both endocrine portion as well as exocrine portion. Exclusively endocrine portion of pancreas secretes two hormones. One is insulin, second one is glucagon. First one is insulin and the second one is glucagon. Especially insulin converts. Insulin converts excess of blood glucose. Insulin converts excess of blood glucose into glycogen. Got it? Insulin converts excess of blood glucose into glycogen. Understood? Here, insulin converts excess of blood glucose into glycogen. It means insulin decreases glucose levels in blood. Insulin decreases glucose levels in blood. This phenomenon is called hypoglycemia. This phenomenon is said to be hypoglycemia. Insulin converts excess of blood glucose into glycogen. Due to the conversion of excess of blood glucose into glycogen in the presence of insulin, glucose levels in blood automatically decreases. This phenomenon is called hypoglycemia. Here hypoglycemia is caused by insulin. Hypoglycemia is caused by insulin. That is why insulin is commonly considered as hypoglycemic hormone. Hypoglycemic hormone. Understood? Insulin converts excess of blood glucose into glycogen. Due to this reason, glucose levels in blood decreases by insulin. This phenomenon is said to be hypoglycemia. Here hypoglycemia is caused by insulin. That is why insulin is commonly considered as hypoglycemic hormone. Hypoglycemic hormone. Understood? Don't confuse amma. Insulin converts excess of blood glucose into glycogen. Here insulin decreases glucose levels in blood called hypoglycemia. And insulin is commonly considered as hypoglycemic hormone. Why? Because insulin causes hypoglycemia. Okay na? See, my dear students, due to the deficiency of insulin, due to the deficiency of insulin or due to the poor secretion of insulin, excess of blood glucose will not be converted into glycogen. Due to the deficiency of insulin, due to the poor secretion of insulin, excess of blood glucose won't be converted into glycogen. At that point of time, glucose levels in blood will be increased. Glucose levels in blood will be increased. Okay na? Due to the deficiency of insulin, excess of blood glucose will not be converted into glycogen. At that point of time, automatically glucose levels in blood will be enhanced. Glucose levels in blood will be increased. Finally, from blood, glucose and some ketone bodies, will be excreted out along with urine. This condition is said to be diabetes mellitus. Due to the deficiency of insulin, excess of blood glucose won't be converted into glycogen. At that point of time, automatically glucose levels in blood will be enhanced. Glucose levels in blood will be increased. Finally, from blood, glucose and some ketone bodies will be excreted out along with urine. This condition, this abnormality is said to be diabetes mellitus. And my dear students, if urine sample contains glucose called glycosuria, if urine sample contains glucose called glycosuria, but if urine sample contains ketone bodies called ketonuria. Just enumerate the difference between both glycosuria and ketonuria. If urine of diabetic patient contains glucose called glycosuria, or if in case urine contains ketone bodies called ketonuria. Glycosuria and ketonuria both are the indicators for diabetes mellitus. Glycosuria and ketonuria both are the indicators for diabetes mellitus. Understood? So this is about diabetes mellitus. So final conclusion is diabetes mellitus is caused by the deficiency of insulin. Diabetes mellitus is caused by the deficiency of insulin. Basically, insulin converts excess of blood glucose into glycogen. Understood? Insulin converts excess of blood glucose into glycogen. Here, insulin decreases glucose levels in blood. This condition is hypoglycemia, and insulin is commonly considered as hypoglycemic hormone. But due to the deficiency of insulin, excess of blood glucose will not be converted into glycogen. At that point of time, automatically glucose levels in blood will be increased. Finally, from blood, glucose and some ketone bodies will be excreted out along with urine. This abnormality is scientifically called diabetes mellitus. If urine sample contains glucose called glycosuria, if same urine sample contains ketone bodies is called ketonuria. Glycosuria and ketonuria both are the indicators for diabetes mellitus. But here diabetes insipidus is caused by the deficiency of antidiuretic hormone or ADH or vasopressin. So yesterday sir has explained regarding that in detail. ADH or vasopressin hormone, basically ADH or vasopressin hormone stimulates reabsorption of water in both DCT, distal convoluted tubule, and CD or collecting duct. And ADH or vasopressin hormone prevents diuresis. Diuresis means excess urination. Along with that, ADH or vasopressin hormone prevents dehydration. Understood? So the deficiency of ADH or vasopressin leads to a disease called diabetes insipidus, dear students. Understood? Symptoms of diabetes insipidus include: number 1, poor reabsorption of water in both DCT and CD. It leads to diuresis and dehydration. Just enumerate the difference between both diabetes mellitus and diabetes insipidus. Diabetes mellitus is caused by the deficiency of insulin, but diabetes insipidus is caused by the deficiency of ADH or antidiuretic hormone or vasopressin. Got it? Right. One minute. Right, sorry for inconvenience. Right, dear students, human urine is light yellow colored and watery fluid. Human urine is light yellow colored watery fluid because basically human urine contains one special pigment called urochrome pigment. Human urine contains urochrome pigment. Urochrome pigment provides light yellow color to urine. Understood? Human urine, assertion. Human urine is light yellow colored watery fluid. The reason behind that is due to the presence of urochrome pigment. Human urine contains urochrome pigment. Urochrome pigment provides light yellow color to the urine. Here reason correctly justifies, reason correctly explains assertion. Understood? So in case of assertion reason relevant questions, you have to think systematically. You people have to create a proper coordination between both assertion and reason. Understood? Right? And pH of urine is 6, means slightly acidic. Here also assertion, pH of urine is 6. It represents slight acidic nature. So this is assertion. What is the accurate reason behind that assertion? Can you say? pH of urine is 6. It represents slightly acidic because hydrogen ions are actively secreted into primary urine. Hydrogen ions are actively secreted into primary urine. Here, active secretion of hydrogen ions into primary urine provide acidic nature to urine. Understood? pH of urine is 6, which represents slightly acidic. This is assertion. Reason is active secretion of hydrogen ions into primary urine. Active secretion of hydrogen ions into primary urine provide acidic nature to urine. Here also reason correctly explains assertion. Reason correctly explains assertion. Here human urine is a light yellow colored and watery fluid because human urine contains urochrome pigment. Urochrome pigment provides light yellow color to the urine. And pH of urine is 6. It represents slight acidic nature. Hydrogen ions are actively secreted into primary urine. Active secretion of hydrogen ions into primary urine provide acidic nature to urine. Understood? Just analyze each and every point in a systematic manner. Okay na? Right. And my dear students, on an average, a healthy man, can excrete 1 to 1.5 liters of urine per day. Understood? On an average, a healthy man can eliminate 1 to 1.5 liters of urine per day. And along with that, on an average, a healthy man can excrete 25 to 30 grams of urea per day. First statement represents urine and second statement represents urea. Understood? Urine, urea, both are different aspects. Urea is one of the nitrogenous waste material of urine. Understood? Urea is one of the nitrogenous waste material of urine. Keep it in your mind. On an average, a healthy man can excrete 1 to 1.5 liters of urine per day. On an average, a healthy human being can excrete 25 to 30 grams of urea per day. Understood? Right. And my dear students, urine test, urine analysis helps to detect, helps to diagnose, helps to recognize several metabolic disorders. Understood? Urine test helps to detect, urine test helps to diagnose, urine test helps to recognize several metabolic disorders. Along with that, urine test helps to analyze poor functioning of kidneys or malfunctioning of kidneys. Malfunctioning andre poor functioning. Understood? See, human urine is light yellow colored and watery fluid because human urine contains urochrome pigment which provides light yellow color to the urine. And pH of urine is 6, means slightly acidic. Active secretion of hydrogen ions into primary urine. Active secretion of hydrogen ions into primary urine provide acidic nature to urine. On an average, a healthy human being can excrete 1 to 1.5 liters of urine per day, and at the same time 25 to 30 grams of urea per day. 1 to 1.5 liters of urine per day and 25 to 30 grams of urea per day. And urine test helps to diagnose malfunctioning of kidneys and metabolic disorders of our body. Got it? Once analyze. Right. Next, disorders of excretory system. Number 1, glomerulonephritis. Glomerulonephritis, it means inflammation of glomerulus, by microorganisms, especially bacteria and virus, is called glomerulonephritis. The process of inflammation of glomerulus is called glomerulonephritis. My dear students, due to the action of bacteria or viruses, glomerulus will be inflamed. Glomerulus will be inflamed or glomerulus will be swollen. Inflammation of glomerulus or swelling of glomerulus is called glomerulonephritis. Here, glomerulus is one of the most essential component of nephron. Why? Because urine filtration will be done in glomerulus primarily. Okay? Glomerulus and Bowman's capsule, both are collectively called Malpighian body. Glomerulus and Bowman's capsule, both are collectively called Malpighian body, otherwise known as renal corpuscle. And the second one, renal caliculi or kidney stones. Renal caliculi or kidney stones. My dear students, due to dehydration, excess amount of urea accumulates in blood. Due to dehydration, excess amount of urea accumulates in blood. Accumulation of excess amount of urea in blood. Accumulation of excess amount of urea in blood is called uremia. Understood? Due to dehydration, due to dehydration, insoluble mass of crystallized salts. Due to dehydration, insoluble mass of crystallized salts and oxalates accumulates in kidney. Sorry for inconvenience. Due to dehydration, insoluble mass of crystallized salts or oxalates accumulates within the kidney. Here, accumulation of insoluble mass of crystallized salts or accumulation of oxalates appear like stones. Called kidney stones, scientifically called renal caliculi. Don't confuse. Due to dehydration, insoluble mass of crystallized salts or oxalates accumulates within the kidney. Here, accumulated crystallized salts or accumulated oxalates appear like stones called kidney stones, scientifically called renal caliculi. Inflammation of glomerulus is called glomerulonephritis. Due to dehydration, insoluble mass of crystallized salts or oxalates accumulate in kidney. They appear like stones called kidney stones, scientifically called renal caliculi. And third one is uremia. Dear students, due to malfunctioning of kidneys, malfunctioning means poor functioning. Malfunctioning andre poor functioning. Due to malfunctioning of kidneys or due to poor functioning of kidneys, excess amount of urea accumulates in blood. Excess amount of urea accumulates in blood. Accumulation of excess amount of urea in blood is called uremia. Accumulation of excess amount of urea in blood is called uremia. Due to malfunctioning of kidneys or due to poor functioning of kidneys, excess amount of urea accumulates in blood. Accumulation of excess amount of urea in blood is called uremia. My dear students, uremia leads to kidney failure. Uremia leads to kidney failure. Kidney failure is otherwise known as renal failure. Here renal represents kidney. Renal represents kidney. Hemodialysis or artificial kidney is a diagnostic procedure. Hemodialysis is used to segregate excess amount of urea from the blood of uremia patient. Later we will discuss about hemodialysis, process of hemodialysis and steps involved in hemodialysis. So listen, once recapitulate what we have learnt. Inflammation of glomerulus is called glomerulonephritis. Due to dehydration, insoluble mass of crystallized salts or oxalates accumulate in kidney. Accumulated insoluble mass of crystallized salts or accumulated oxalates appear like stones called kidney stones, scientifically called renal caliculi. Due to malfunctioning of kidneys or due to poor functioning of kidneys, excess amount of urea accumulates in blood. The process of accumulation of excess amount of urea in blood is called uremia. The process of accumulation of excess amount of urea in blood due to malfunctioning of kidneys or due to poor functioning of kidneys is called uremia. Uremia leads to kidney failure. Kidney failure is otherwise known as renal failure. Hemodialysis is a special diagnostic procedure. Hemodialysis is used to separate, used to isolate, used to remove, used to centrifuge excess amount of urea from the blood of uremia patient. Now we will discuss about hemodialysis. Once focus here. Right? Hemodialysis or artificial kidney. Dear students, basically I have delivered one statement just now. Hemodialysis is a special diagnostic procedure. Hemodialysis is used to separate excess amount of urea from the blood of uremia patient. Due to poor functioning of kidneys or due to malfunctioning of kidneys, excess amount of urea accumulates in blood. That condition is said to be uremia. Here hemodialysis can segregate excess urea from the blood of uremia patient. So here hemodialysis includes one special chamber. Hemodialysis includes one special chamber called dialyzing chamber. Hemodialysis includes one special chamber called dialyzing chamber. Here, dialyzing chamber is filled with fluid. Dialyzing chamber is filled with fluid called dialyzing fluid. Dialyzing chamber is filled with fluid called dialyzing fluid. My dear students, dialyzing fluid contains almost all the components of plasma. Dialyzing fluid contains almost all the components of plasma. Plasma is one of the major constituent of blood. Already we have discussed in body fluids and circulation chapter. Dialyzing fluid contains almost all the components of plasma except nitrogenous waste materials. Except nitrogenous waste materials like urea. Understood? Hemodialysis includes one special chamber called dialyzing chamber. Here, dialyzing chamber is filled with fluid called dialyzing fluid. Dialyzing fluid contains almost all the components of plasma except nitrogenous waste materials like urea. It means dialyzing fluid does not contain nitrogenous waste materials, or dialyzing fluid does not contain urea. Dialyzing fluid does not contain nitrogenous waste materials, or dialyzing fluid does not contain urea. Understood? Right, Amma? Along with this setup, in hemodialysis or in dialyzing chamber, one special tube-like structure is present. In dialyzing chamber, one special tube-like structure is present, is called channel or vessel. Along with the dialyzing fluid, in dialyzing chamber, one special tube-like structure is present called channel or vessel. Here, channel or vessel is surrounded by a membrane. Channel or vessel is surrounded by a membrane. This membrane contains microscopic openings. This membrane contains microscopic openings. This membrane is scientifically called cellophane membrane. Porous cellophane membrane. Don't confuse, Listen again. All the labels are successfully completed. Explanation part is remained. Hemodialysis includes one special chamber called dialyzing chamber. Dialyzing chamber is filled with fluid called dialyzing fluid. Dialyzing fluid contains almost all the components of plasma except nitrogenous waste materials like urea. It means dialyzing fluid does not contain nitrogenous waste materials, or dialyzing fluid does not contain urea. Along with dialyzing fluid, in dialyzing chamber, one special tube-like structure is present called channel or vessel. Here, channel or vessel is surrounded by a membrane. This membrane is scientifically called cellophane membrane. But here, cellophane membrane contains microscopic openings, or cellophane membrane contains microscopic pores. Hence the name porous cellophane membrane. Porous cellophane membrane. Now, steps involved in hemodialysis. My dear students, first we have to collect deoxygenated blood. We have to collect deoxygenated blood from patient's body or from uremia patient's body. Collect deoxygenated blood from patient's body through convenient artery. Convenient artery. Sir, basically arteries carry oxygenated blood. But why did you mention artery here? Because you mentioned deoxygenated blood. That's why if we focus on that, we have to mention vein here. But instead of vein, I have mentioned artery. Why? Because all arteries carry oxygenated blood only. I agree with that. Except pulmonary artery. All arteries carry oxygenated blood only except pulmonary artery. Keep it in your mind. Pulmonary artery carries deoxygenated blood from right ventricle into lungs for purification. Pulmonary artery carries deoxygenated blood from right ventricle into lungs for purification. Please keep it in your mind. Collect deoxygenated blood from patient's body through convenient artery. Basically, my dear students, if deoxygenated blood exposes to external environment, if collected deoxygenated blood exposes to external atmosphere or external air, immediately deoxygenated blood will be clotted or deoxygenated blood will be coagulated. To prevent that, we have to mix this deoxygenated blood with heparin. We have to mix deoxygenated blood with heparin. Why? Because heparin prevents deoxygenated blood from blood clotting, or heparin prevents deoxygenated blood from blood coagulation. It means heparin works against blood coagulation. Heparin works against blood coagulation. That is why heparin is scientifically called anticoagulant. Anti means against. So here heparin works against blood coagulation. Heparin works against blood clotting. That is why heparin is commonly considered as anticoagulant. Anticoagulant. Understood? If collected deoxygenated blood exposes to external environment or external air, immediately deoxygenated blood will be coagulated or deoxygenated blood will be clotted. To prevent that, we have to mix collected deoxygenated blood with heparin. Here, heparin prevents deoxygenated blood from blood coagulation. Here, heparin works against blood coagulation. That is why heparin is commonly considered as anticoagulant. Okay? So, to be continued. Thank you for your kind cooperation. Right.
right? Good morning all of you. Today I am going to discuss about carbonyl compounds, that is aldehydes, ketones, carboxylic acids. This is the chapter aldehydes, ketones, carboxylic acid, right? This I will discuss today, tomorrow and day after tomorrow, 3 days. Including this, some alcohol, phenol ethers also, some other questions already there, I am having. That questions also we will discuss simultaneously, right? So, very important topic. This is aldehyde, ketone, carboxylic acid, including alcohol, phenol ether also. Now, we will discuss aldehydes, ketones, carboxylic acid, some of the points. So, anyway, here also we will discuss preparation methods, physical properties and chemical properties. First one, I am going to discuss about preparation methods. Related to preparation method, just I will write some reactions. Observe, based on that you have to write the products, right? First one is, I am taking alcohols. This is the alcohol. This is the alcohol. This already we discussed yesterday. Just again I am going to discuss about this one. This is primary alcohol, this is the secondary alcohol. Primary alcohol and secondary alcohol, our requirement product is here. What a requirement product? Aldehydes and ketones, and later carboxylic acid, that is leave it later. Okay, carboxylic acid also simultaneously. Now, primary alcohol to first carbonyl compound, secondary alcohol to carbonyl compound. So, primary alcohol to carbonyl compound, that is aldehyde. From here is what happened, removal of hydrogen, that is called, what do you call? Removal of hydrogen is called reduction, removal of hydrogen is called oxidation. Oxidation means this is reducing agent. This reducing agent means you have to use here oxidizing agent. That oxidizing agent is, which oxidizing agent you have to use? Mild oxidizing agent we have to use. Why mild oxidizing agent? First our requirement product is aldehyde and ketone, that means carbonyl compound. So reaction will be stopped at only this one only, that is called aldehyde. We don't want further, we don't want carboxylic acid now, right? That's the reaction will be stopped at aldehyde only. That time we have to use mild oxidizing agent. Already we know mild oxidizing agents. Yesterday I told, one is PCC, other one is PDC, third one is CrO3 anhydrous CrO3. Those are called mild oxidizing agent. Mild oxidizing agent is their final product is carbonyl compound, that is aldehyde with primary alcohol. Now this is secondary alcohol. Secondary alcohol with mild oxidizing agent. Then what I can get? Ketone. This already you know. Tertiary alcohol is there with the mild oxidizing agent, no reaction. Already we know why, because absence of alpha hydrogen. Now this is aldehyde, this is the ketone. Those are called aldehyde and ketone. These two are called aldehyde and ketone. You should call as carbonyl compound, because here why you call carbonyl compound? In this carbonyl group is present. So CO, that's what. Now if I want acid, carboxylic acid I want, then what we have to do? Instead of this, instead of mild oxidizing agent, what I have to use? Strong oxidizing agent I have to use. If I use the strong oxidizing agent, what will happen? First product is aldehyde, correct? Then strong oxidizing agent I am using, here further oxidation will be takes place. Further oxidation will be takes place to convert it to carboxylic acid. Now in case of this one, strong oxidizing agent, first ketone, yes, correct only now. Again further heating, elevated temperature, then what happened? You will get mixture of carboxylic acid. In case of ketone is there, ketone with the strong oxidizing agent, you will get the mixture of carboxylic acid, right? So what we want, that only now. So carboxylic acid we want means we have to use the strong oxidizing agent. Aldehyde ketone we want means we have to use mild oxidizing agent. Still there mild oxidizing agent, PCC, PDC and CrO3. Then other than those three, still two are there. Later we will get it. You wait. Now this is the first point. Now second point observe, this is the very important second point. Just I am taking this one, double bond with one methyl group outside, then what I am going to do, I am going to do an ozonolysis, O3Zn followed by H2O, that is called ozonolysis. So instead of that I am giving this one, CH3 CH double bond CH2 normally, this already we know. So O3Zn H2O, ozonolysis means what happened, wherever the double bond, what I am saying double bond, wherever the double bond is, the double bond you have to break down, this side oxygen we have to keep, write the product, that is only our answer. That means CH3 CHO, here CH2O, CH2O means HC double bond OH, C, 2 hydrogens, 1 oxygen, C, 2 hydrogens, 1 oxygen, that is the product, that mixture of aldehydes, right. That means ozonolysis uses detection of double bond or identification of double bond. That means wherever the wherever the double bond is there only will be go and attack the O3 molecule, go and adding O3 molecule. That is the meaning, double bond where it is there only will be add. That is called test for unsaturation or not test for identification of unsaturation or detection of unsaturation. That is the ozonolysis use. Next one. This one observe, same what you call reagent only, O3. Same as it is, wherever the double bond is there only you have to break oxygen, oxygen. Then what I can get, CH3 C double bond O CH3. That means this is ketone. This one is aldehyde, so HC double bond OH. This is the product. That means you will get aldehydes, only aldehyde, you will get mixture of aldehyde and ketone, you will get only ketone, that is the important method. So you can prepare all, both aldehyde, ketone, both mixture also. Now same like this observe now, this one of the time they ask the question. Double bond you have to break down, this side oxygen you have to keep. Now total how many carbon? 1, 2, 3, 4, 4, 5 plus 1, 6 carbon, observe here, first one, CH3. Here middle, double bond, that is ketone. Next one, 1, 2, 3, 4, 1, 2, 3, that means CH2 3 times, CH2, CH2, CH2. This one is converted to CHO. This is the product, right? Total how many carbon? 1, 2, 2 plus 3, 5, 5 plus 1, 6. Here also 6 carbons are there. This is only product, right? Next one. Now, I am giving one question to you. Same, for example, I am getting the product is CH3, C double bond O, CH2, CH3. That is called butane 2-one. Butane 2-one and CH3, CHO. One of the product is butane 2-one, and that means in case of ozonolysis we are getting the mixture of butane 2-one and ethanol. So what is the starting material? Like that question also they will ask. In case of ozonolysis we are getting the product is butane 2-one and ethanol. Mixture of butane 2-one and ethanol. So what is starting material? Starting material means how to do now? Ozonolysis means what you have done? Wherever the double bond is there, double bond you have to break, that side oxygen, this side oxygen you have to keep. Now this side that means what they given, product they are given, they are asking reactant, reverse now. Before they are given reactant, they are asking product. Now this is reverse. This type of questions also one of the time they ask. Observe how to do that type of question. First, arrangement observe now clearly. Arrangement. This one we want now. Keto group is here. Keto group you have to keep like this. This methyl. Remaining whatever the group is at this side, that group will be substituent only. Like this substitute, like that you have to arrange. That means CH3, CH2, that is called C2H5. Otherwise you can write no problem. What you have to write? CH2, CH3, no problem. Like this you have to arrange. I arrange it. This one also as it is. Here CH3. Now keto group this side you have to write. That means aldehyde. C double bond OH. Any substituent there, substituent you have to write like this. Any group is there, any carbon change like this you have to write. That means both aldehyde and ketone groups they have to arrange adjacent to each other. Then what happened? Now what happened here? Wherever the double bond is there only you have to break down, right? Now in this case, whatever the oxygens are there, that oxygens what we are added, that oxygen we have to remove. I will remove oxygens. Then you join that two total molecules, join that. So CH3, C, down C2H5 means substituent. Here what is there now? Double bond is there, double bond, CH, CH3. This is only our requirement starting material. Now otherwise if you are getting doubt again, then you break down. Then what I can get? Break down, then you keep this side oxygen, that side oxygen you have to keep like this. Then what I can get? CH3, CHO. CH3, CHO. Another one, CH3, C double bond O, CH3, C double bond O. C2H5 means CH2, CH3. That's what you are getting, that mixture of butane 2-1 and ethanol. Like that, we have to do the ozonolysis process. Right? Next one. Both physical and both preparation methods and chemical properties, just I am giving some named reactions. So, overall named reaction. Now, today I will discuss some named reaction, tomorrow I will discuss some named reaction. Compulsory they are asking the named reaction. One side they are giving named reaction, other side they are giving the product. Match the following they are asking. Most of the time they are asking a question like that only now. Right? Now, this is what? RC double bond OCl, that is called acid chloride. Acid chloride reacting with H2, PD, BaSO4 in quinoline. Quinoline also called sulfur. Anyone you can use. This is called as what the reagent? This you should know. Lindlar's catalyst. This is called Lindlar's catalyst. Lindlar's catalyst. Then what I can get the product? Acid chloride in the presence of H2PD BaSO4 in quinoline to form a H and Cl, HCl eliminate, that H will be added, you will get the aldehyde. Either aliphatic or aromatic, both aldehyde you will get it. No, this is called as, this is one of the named reaction, this is called as Rosenmund reduction. Rosenmund reduction. Why you call reduction? So chlorine halogen atom, more electronate element removal by adding of hydrogen, that is called reduction. The name is called what? Rosenmund reduction. Rosenmund reduction means what? Acid chloride to aldehyde. So this is special for the preparation of only aldehyde, not for ketone. Next, this is one of the named reaction. Next one. This is what now here. This is called nitrile, also called cyanide. RC triple bond, and that is called nitrile, also called cyanide. Reacting with SnCl2, tin chloride or stannous chloride. Then followed by what? Direct I am writing now. H3O plus, direct product I am writing now. Right? First actually what will form? Intermediate is formed. So RCN plus SnCl2 followed by HCl is there. Then followed by hydrolysis. HCl means this here hydrogen is provided, hydrogens are provided now. Then what you can get? Intermediate product like this will get it now. Sometimes they will ask like this also, intermediate also like this. That means what happened? Carbon, nitrogen, triple bond, one bond you remove, that side hydrogen, this side hydrogen. When one pi bond you have to remove, two hydrogens we have to add. This is also called reduction. Right? Then what I can get? CH double bond, this is called intermediate, the intermediate name is called imine. Imine. That means nitriles are reduced to corresponding imine when it is treated with stannous chloride in the presence of HCl, imine. It is followed by hydrolysis. So already written step means then you can write here only now. Hydrolysis. Hydrolysis means what? What is the meaning of hydrolysis? Adding of hydrogens. Adding of water. Here how many bonds are there? Two bonds are there. In case of cyanide I told C triple bond N. C triple bond and hydrolysis means how many water molecules we have to add? 3 water molecules. Here two bonds are there, 2 water molecules we have to add. Like this. Here OH, H, here OH, H. That means byproduct is NH3. NH3 byproduct. Remaining product is what the product? R, CH. 2 OHs are there now. OH, OH. That means one carbon containing two hydroxyl groups are highly unstable, then what you have to remove? Water you have to remove, and what I can get? RCHO. What the product? Aldehyde. This also will get aldehyde. That means nitriles are reduced to corresponding imine when it treated with the stannous chloride in the presence of HCl and followed by hydrolysis to form a aldehyde is called as Stephen's reaction or Stephen's reduction. Stephen's reaction, that is Rosenman, this is Stephen's reaction. This is one of the reaction, named reaction. Next one. Next one is what? Named reaction. Nitriles, very very important. Nitriles and esters reduced to corresponding aldehyde by using one of the special reagent. So many times they are, that is called dibol H. So dibol H followed by hydrolysis. Dibol H. Dibol H means what? Diisobutyl. Diisobutyl aluminum hydrate. So this is the structure. Like this they will give you. They will not give like this. Sometimes they will give you dibol H. Otherwise like this. What is this IBE2? I means iso. Bu means butyl. Isobutyl. How many times? 2 times. That is called diisobutyl aluminum with hydride. This is called aluminum. Diisobutyl aluminum hydride is also called hydride ion transfer reagent. Hydride. Hydride means it supplies H minus ion, right? Then this one is the nitriles are reduced to corresponding aldehyde. Then what I can get? RCHO. This here you have to break down, right? Actual mechanism, so many steps are there. Direct I am writing now. You have to break down. This is converted to aldehyde. This is converted to byproduct is ammonia. That means nitriles are reduced to corresponding aldehyde by using diisobutyl aluminum hydride. That is called as dibol H. Not only nitrile, it is also reduced to what do you call ester also. Observe here ester. I will write just one example. CH3, CH2 9 times. C double bond O, C2H5 or CH3, no problem. This is one of the ester. Whatever the group you can take, no problem, but whatever the chain you can take, no problem, but compulsory that is ester. Ester with what? Same reagent, dibol H only. Dibol H, diisobutyl aluminum hydride. This is also hydrogen transfer reagent. It is like a NaBH4. It is like NaBH4. NaBH4 is what? Mild reducing agent. It is also mild reducing agent. That mild reducing agent also called selective reducing agent. That means selective reducing agent means that will reduce the selective functional groups. What are those? Aldehydes, ketones, acid chloride. That one. Which one? NaBH4. Reduce it to corresponding alcohol. Here also same. Here only 2 functional groups. These are selective functional groups. These two only dibol H will reduce to only these 2. One is nitrile, other one is ester. This one of the time they ask the question. This is only question. NEET. So this one they are given, they are using dibol H. So what is the product I can get? Same as it is. Now ester means you have to break down the bond. C double bond O. This is converted to aldehyde. This is converted to alcohol. That is leave it now. That is the byproduct. We don't want now. Anyway, alcohol. So main product is aldehyde. So ester is reduced to aldehyde. This one. That means answer is CH3, CH2 9 times. CO is converted to C double bond OH. Byproduct we don't want. That is only now our requirement product. That is called aldehyde. So finally, what is of the dibol H? It reduces. So nitriles and aldehydes are reduced to corresponding aldehyde. That is why it is a selective and mild reducing agent. Which one? Dibol H. Now till now 3 main compounds are compulsory. This year also you will get it, you need in the match the following. Alright, compulsory. Any question they will, any one question they will ask. Next one. This one reaction, tell me now. 2 possibilities I am saying now. What is called this one? Toluene. reacting with CrO2Cl2, that is called chromyl chloride, in the presence of CS2 followed by hydrolysis, otherwise this one. Toluene CrO3 in the presence of acetic anhydride followed by hydrolysis. What I can get the product? This already we know, chromyl chloride, intermediate starting material, this is chromyl chloride. Chromyl chloride is called Itard's reaction, that means Itard's reagent. Itard's reaction, that is also called Itard's reagent. Which one? Chromyl chloride is called Itard's reagent, right? Itard's reagent. Then what I can get? One intermediate chromium complex you will get it now. One of the time they ask the chromium intermediate complex, one of the time in the NEET exam. A, this is X, then followed by hydrolysis, then you get Y. Here also, X followed by hydrolysis, you will get Y. What is XY? They ask. As you directly at a time written. First one, intermediate chromyl chloride with what you call toluene, intermediate product you should know. That means your total how many hydrogens are there? 3 hydrogens. The 3 hydrogen, the 2 hydrogens are replaced by this we have to attach CH, O, CrO, how many hydrogen? 1 hydrogen, Cl2 followed by twice, 2 times. That means actual CH3, the 2 hydrogens are replaced by that chromium complex is added. That is called chromium complex. That is called addition product. This is the intermediate chromium complex. This chromium complex is followed by hydrolysis. Hydrolysis means same. Here how many chromium complexes are there? Chromium compounds are there. This chromium compound how many times are there? 2 times. 2 times means that 2 times we have to break. 2 times we have to break means how many moles of water molecule we have to add? 2 moles. That means here OH, H, OH, H. That is the byproduct eliminate. That means this is containing CH, OH, OH. Again CH containing 2 hydroxyl group. What you have to remove? Water. Then what I can get the product? Aldehyde. This is called benzaldehyde. Toluene to benzaldehyde by using Itard's reagent. Otherwise this one also same one of the type of Itard's, right? One of the reaction. Then what I can get? Product first. I can take toluene as it is. In the presence of CrO3 I can add acetic anhydride. Acetic anhydride observe clearly. CH3CO, O, C double bond O, CH. This is called acetic anhydride. That means CH3 how many times? 2 times. Twice and oxygen. This is called acetic anhydride. This complex will be added to this one. Then what I can get? Same 2 hydrogen replaced by this complex. O, C double bond O, C double bond O, CH3. How many times? 2 times. That is the chromium complex. No, this is not chromium complex. Acetic anhydride complex. Diacetate. This is called acetate, diacetate. Benzyl diacetate. So this is the intermediate product. Then again followed by hydrolysis. Then what I can get? You have to break the bond. OH, H, OH, H. Acetic acid eliminate. CH3, C double bond O, OH. Acetic acid. How many moles? 2 moles. CH containing OH, OH. Water eliminate. Then what I can get? Product is aldehyde. But both cases what I am getting? Aldehyde. That is called Itard's reaction. This is one of the named reaction. Next named reaction, last and final one of this today's, remaining later we will discuss. Now this one, benzene with CO plus HCl in the presence of CuCl or anhydrous AlCl3, that is called cuprous chloride or anhydrous AlCl3. This is called CO plus HCl means this HCO will add, HCOCl will be added, that is called hydroformylation. Then final product is what I can get? CHO. That means here hydrogen is there. One of the hydrogen replaced by Cl, HCl eliminate. What there now? C double bond with H, that is called aldehyde. This is called benzaldehyde. Benzene with benzaldehyde with carbon monoxide plus HCl in the presence of anhydrous AlCl3 with cuprous chloride is called, what do you call? Gutterman-Koch. Gutterman-Koch, right? Gutterman-Koch reaction. right? These are the some named reactions. If you want still other named reaction, I will tell you still more too, right? One is carbonyl compound. That means what? Okay, just example I will write now. Instead of general equation, I am writing general example. This is called what do you call ethanol aldehyde with zinc followed by amalgam with concentrated HCl. Zinc amalgam with concentrated HCl. Metal with mercury is called amalgams. That is called zinc amalgam with concentrated HCl. What I can get means that keto group, either aldehyde or keto group, carbonyl group is converted to CH2. That means converted to alkane. Just an understanding point of view, CH2 instead of CH, then what I can say converted to alkane. That means what happened? CH3. Here already CH is there. Which oxygen I am removing. Oxygen I am removing means here oxygen I have now many bond, 2 bonds. The 2 bonds you have to write. We have to add 2 hydrogen. Then what I can get? CH3. That means CH3 CH. That means what? Aldehyde or carbonyl compound can reduce to alkane. Reduce to alkane is in the presence of zinc amalgam. Presence of zinc amalgam and concentrated HCl. So here adding of hydrogen, that is called reduction. That means this is called reducing agent. That hydrogen is provided by supplied by HCl, concentrated HCl. So what happened? Carbonyl compound reduced to alkane, corresponding alkane in the presence of zinc amalgam with concentrated HCl is called Clemmensen reduction. Clemmensen's reduction. Reduction means addition of hydrogen, removal of oxygen. So oxygen removed by adding of hydrogen. That means converted to alkane, corresponding alkane. That is called Clemmensen reduction. So not only aldehyde, any aldehyde or ketone, any carbonyl compound you can take, no problem, not a issue. Next one. Now instead of aldehyde I will take ketone. With ketone is treated with first one hydrazine, NH2. That is called hydrazine. NH2 is called what? Hydrazine. First what you have to remove? So H2 and O water eliminate. Then hydrogen followed by ethylene glycol. Direct I am writing now. Ethylene glycol. Ethylene glycol is what is the role? Ethylene glycol is a high boiling point solvent. High boiling solvent. So high boiling solvent, it required high temperature to remove the water molecule. That temperature is supplied by ethylene glycol. Right? Ethylene glycol with KOH followed by small heating. Right? Ethylene glycol with KOH is the reagent. Then what I can get the product? Same product. What is the same product? CH3, CH2, CH. That means what? Oxygen removed by adding of hydrogen. This is also called reduction. That means this is called reducing agent. That means hydrogen followed by ethylene glycol with KOH. That is also called reducing agent. This reaction is called Wolff-Kishner reduction. What do you call? Wolff-Kishner reduction. So these are the named reactions. So that means Clemmensen reduction and Wolff-Kishner reaction, both are carbonyl compounds are reduced to simply alkane. That means oxygen removed by adding of hydrogen. That is called Clemmensen. Other one is Wolff-Kishner reduction. Right? These are the named reactions. Still more named reactions are there. Later we will discuss. Next, before going to that, next one is reactivity. That means carbonyl compounds undergo nucleophilic addition reaction. Carbonyl compounds undergo what type of reaction? Nucleophilic addition reaction. Here very, very important. Right? Compulsory they are asking the question, nucleophilic addition reaction. Clearly observe. This is what? Aldehyde. This is what? Ketone. Aldehydes and ketones, that means carbonyl compound undergo nucleophilic addition reaction. That meaning nucleophile is adding to the adding to the carbonyl compound. That means carbonyl compounds undergo nucleophilic addition reaction. Why? Observe clearly. Just general equation I will tell you. Here one point I am going to say, this aldehyde or anyway you can take ketone also, no problem, not an issue. Either H is there aldehyde, R is there ketone. Okay. In this is the main rule, C double bond, that is called carbonyl group. In this carbon and oxygen is the more electronegative because of electronegativity difference. Because why? Carbon and oxygen, which one is the more electronegative? Oxygen. Oxygen is more electronegative than carbon. Because of electronegativity difference, electrons are moving towards oxygen side. Electrons are moving towards which side? Oxygen side. That time, oxygen getting which charge? Oxygen getting negative charge. Carbon getting which charge? Positive charge. Oxygen getting negative charge, carbon getting positive charge. Here what happened? Charge separation is present. Why charge separation is present? Because of electronegativity difference. Charge separation is present, this is called what? Polar molecule. Okay, very good. That means carbonyl compounds are polar in nature because of electronegativity difference. How it is? How can you say that electronegativity different? Based on electronegativity. Okay, that is the first point. Second point, two possibilities are there now here. Oxygen getting negative charge, carbon getting positive charge. That means one of the point here, in this oxygen getting negative charge, more electronegative element getting negative charge is highly stable. This is stable. Now carbon getting which charge? Positive charge. Carbon getting positive charge means what you call carbocation, also called as electrophile. That means electrophilic nature. Why you call electrophilic nature here? Electron deficient is there. How can you say? Carbon surrounding by how many electrons? How many bonds? 1, 2, 3. 3 bonds means how many electrons? 6 electrons. 6 electrons. Otherwise, here leave it now. Here observe now. Oxygen already satisfied 8 electrons. That means excess of electron is there now. Excess of electron means that is called nucleophile. Deficient of electron is called electrophile. That means one of the time they ask the question. In case of carbonyl compound, carbon is acting as a electrophile. Carbonyl oxygen acting as a nucleophile. That statement correct or wrong? Yes, statement is correct. Carbon is acting as electrophile, carbonyl oxygen acting as a nucleophile. Why? Because oxygen getting negative charge. That means excess of electron. That's a nucleophile. Excess of electron means able to donate. This electrophile means deficient. Why you call deficient? Already 6 electrons are there. To get octet means how many electrons we need? 8 electrons. 8 electrons. 8 electron means how many electron deficient? 2 electron deficient. That means deficient species, electron deficient species called electrophile, also called carbocation. This is electrophile. Right? So electrophile means these electrophiles are highly unstable and more reactive. This is a more reactive compared to this. It's already negative charge, this is stable. Nucleophile is somewhat stable than electrophile. That means which one is a more reactive? Electrophile is more reactive. Electrophile is more reactive means electrophile, what is charge is there? Positive charge is there. Positive charge is there means what will come and attack fast? Nucleophile. Where is there? Positive charge is there. Negative charge will be come and attack. Negative charge means what you call? Nucleophile. Nucleophile. Come and attack means come and add. Add into the electrophilic center. That is called adding of reaction. That is called, reaction is called what? Nucleophilic addition reaction. Here possibility check it now. Here O minus is there and C plus is there. O minus means H plus will be added. That means electrophile will be added. That means electrophilic addition reaction. Here negative positive charge is there means what will come and attack? Nucleophile also will be added. Nucleophile will come and attack. That means here two possibilities are there. Electrophile addition will take place, nucleophilic addition also will be takes place, but electrophilic addition reaction is not possible. Nucleophilic addition reaction is possible because it is more stable, it is less stable because of electrophile. Less stable means here more reactive. That is the reason first nucleophile will attack on carbonyl carbon. That's why what I can say finally, carbonyl compounds undergo nucleophilic addition reactions. Again, one point, other point. Here carbonyl carbon and carbonyl oxygen. Carbonyl carbon is electrophile, carbonyl oxygen is nucleophile. Nucleophile means this electron rich, this is electron deficient. Electron rich species. Electron rich species means it is able to donate. That means electron pair donor. This is electron deficient. Electron deficient means electron pair acceptor. Electron pair acceptor is called Lewis acid. Electron pair donor is called Lewis base. That means carbonyl carbon is a electrophile, and Lewis acid. Carbonyl oxygen is a nucleophile and Lewis base. Why Lewis base? Oxygen having the excess of electron is able to donate. That means electron pair donor. This electron pair acceptor. Electron pair acceptor is called Lewis acid. Electron pair donor is called Lewis base. Next, our point observe now. Nucleophilic addition reaction, aldehydes and ketone. Which one is the more reactive? These both are aliphatic. Aldehydes are more reactive than ketone. Which reaction? Nucleophilic addition reaction. Very, very important. Aldehydes are more reactive than ketone. Why? Two reasons are there. These reasons, one is steric hindrance. Or steric reason, other one is electronic effects. Electronic effects means, that is the meaning, inductive effect, mesomeric effect, hyperconjugation. Those are called electronic effects, right? Because of these two reasons, one is steric hindrance, other one is electronic effect. Because of these two reasons, aldehydes, aliphatic aldehyde, this aldehyde, okay, aliphatic aldehydes are more reactive than ketone in case of nucleophilic addition reaction. So explanation, small explanation I will give you. Observe now. Aldehyde and ketone, right? So what will come and attack in this case? Nucleophile. Here also what will come and add, not attack, add nucleophile. Both cases nucleophile will be added. That's why it undergo nucleophilic addition reaction. Okay, correct. So in case of steric hindrance, in case of ketone, observe here ketone and the adjacent groups both are bulkier groups. Two alkyl groups are there. Two alkyl groups are there, means this are more bulkier group, that means more steric hindrance compared to this. Here also steric hindrance is there, but here only one alkyl group is there. One alkyl group is there means here also steric hindrance is there, but somewhat less compared to this. More steric hindrance in case of ketone. Because of more steric hindrance, what will happen? It is hinders. Hinder meaning stop. It stops the approaching of nucleophile. That means ketones hinders the approaching of nucleophile. So approaching means it will stop nucleophile. What are the nucleophile is come and adding to the carbonyl compound, that will be stopped by ketone. Why? Because steric hindrance. It will be stopped means what happened? Reactivity will be less compared to aldehyde. That means first that is called steric hindrance. Second one observe steric electronic effects. Electronic effect means this aldehyde, this is ketone, adjacent group is alkyl. Alkyl means what? Plus I and plus M, also called plus H also. What is plus M? Inductive effect, mesomeric effect. These are called electron releasing or electron donating groups. There also electron releasing or electron donating group. Where is the more electron releasing, electron with donating groups are they? Ketones having the more electron releasing and electron donating groups are there. Then what will happen? So observe here. Actually, carbon and oxygen getting negative charge, carbon getting positive charge. That means if nucleophile want to attack means their electrophilic nature will be more, where carbonyl carbon. It want to more means electrophilicity is what happened here. Adjacent groups, what the group is there? Electron releasing groups are there. That electron releasing to electrons will be released to the carbonyl carbon. Then what happened? Electrophilicity will be decreases. Electrophilicity will be less in case of ketone. Why? Because of adjacent groups. Adjacent groups, what are those? Alkyl groups. That means electron releasing group. Sir, here also there, no sir? Yes, here also there. Compared to this, here somewhat less electron releasing group, because only one alkyl group. Here two alkyl groups. Here two alkyl groups are there, more electron releasing group. More electron releasing group means less electrophilic nature. Less electrophilic nature means nucleophile attacking also very, very less. Very, very less means it is less reactive compared to this. So finally, what I have to conclude? Steric hindrance and electronic effect. Because of steric and electronic effect, aldehydes are more reactive than ketone. Okay, some other conclusion, final conclusion. Nucleophilic addition reaction is inversely proportional to plus I and plus M, very very important. Observe here. Here also electron releasing group, here also electron releasing group. Where is the more electron releasing groups are there? In case of ketone. More electron releasing group means what about reactivity? Less. Less electron releasing group means what about reactivity? More. That means which relation? Inverse relation. That means electron releasing groups or electron donating groups are increases. Reactivity will be decreases. Exactly opposite to the minus I and minus M. Minus M means what? Electron withdrawing group. That means electron withdrawing groups directly proportional to nucleophilic addition reaction. Electron releasing group inversely proportional to nucleophilic addition reaction. If you know this point, compulsory you will get the one question. Compulsory they are asking the question. So electron withdrawing group increases, nucleophilic addition reaction decreases, increases. Electron releasing group increases, nucleophilic addition reaction decreases. Based on this, I am going to give the one question. Then observe now. One is ethanol. Names I am giving. Based on that names, you have to write the structures. Ethanol. Next one is propanol. Third one is propanone. Fourth one is butanone. Okay. Yeah, no problem. These all are aliphatic. That means ethanol, 2 carbon aldehyde. Propanol, 3 carbon aldehyde. Propanone, 3 carbon ketone. Butanone, this also ketone. That means here question is 2 are the aldehyde, 2 are the ketone. No doubt at all here. Aldehydes are more reactive than ketone. That is what I am asking what? Nucleophilic addition reaction order. There is no doubt. Aldehydes are more reactive than ketone. Now I explained. Right? In ethanol and propanol, which is the more reactive? Ethanol is more reactive than propanol because here also alkyl group, here also alkyl group. Here more alkyl groups compared to this. That's why 1, 2. So 1 is more reactive than 2. Okay. Now ketone, these two are the ketone. This is called propanone, this is called butanone. So in these two anyway, aldehydes are more reactive than ketone. Okay. In these two, which one is the more reactive? 3 carbon, that is 4 carbon. 3 carbon is more reactive than 4 carbon. That's it is the reactivity order. Reactivity order of ethanol, propanol, and butanone. Right? So nucleophilic addition reaction. Some other important question is there. This is last year they asked the question in the NEET related to addition reaction only. Observe here. One is benzoaldehyde. Direct I am writing structure. Okay. Benzoaldehyde. Second one is paratolualdehyde. Paratolualdehyde. Benzoaldehyde compulsory with para position methyl group, that is called paratolualdehyde. Next one, para-nitrobenzoaldehyde. So benzoaldehyde compulsory, para position nitro. Right. Next one, acetophenone. Structures you should know. Acetophenone, that is what? Benzene with COCH, that is called acetophenone. These are the compounds they are given. Right. Next one important point you should know. Right, observe here. Before going this question, one point you have to know. Aliphatic aldehydes and aliphatic ketones. Aliphatic aldehydes are more reactive than aliphatic aldehydes are more reactive than aliphatic ketone. Okay. Now here, observe here. Now I am giving one of the aldehyde is aliphatic. I am giving one of the aldehyde is aromatic. Right. These two I am giving now. One is aliphatic aldehyde, other one is aromatic aldehyde. In these two, which one is the more reactive? Reactive means nucleophilic addition reaction. Aliphatic aldehydes are more reactive than aromatic aldehyde. What is the reason here? The reason is simple. What happened here? Observe clearly. First one. Carbon and oxygen, which one is the more electronegative? Oxygen. So oxygen getting negative charge, electrons are moving towards oxygen. Then what I can get? CO minus and H. Here carbon getting the positive charge, right? Carbon having the electrophile is there, then directly will come and attack nucleophile. Means electrophilicity will be there, then directly will come and attack nucleophile, then reactivity will be increases. Okay, but here positive charge, that means electrophilic nature, electrophilicity of carbonyl carbon is having the conjugation with benzene ring. Conjugation, that means double bond. What type of conjugation? Double bond, single bond, positive charge. Having the conjugation. Conjugation is there means it involves in resonance. Yes, resonance. Because of resonance, this electrophilicity of carbonyl carbon will be decreases. That is the reason here nucleophile attacking of chance is very less. Means electrophilic positive charge is present here, then nucleophile will attack. Here positive charge will not be present. Why? It is having the conjugation. Because of conjugation what will happen? It involves in resonance. Because of resonance what will happen? Electrophilicity is decreases. Electrophilicity will be decreases means nucleophile attacking chance is very less. So that's why aromatic aldehydes are less reactive towards nucleophilic addition reaction than aliphatic aldehyde. That is the important point. Reason is, simple reason is resonance. That's all. So based on this, I am going to give the one question now. This is the question. That is what? Benzoaldehyde, paratolualdehyde, para-nitrobenzoaldehyde, that is called acetophenone. These four are there. Nucleophilic addition reaction order. Already I told you what I told this one. Nucleophilic addition reaction directly proportional to minus I minus M, inversely proportional to plus I plus M. That you should know first groups. What are the groups are there? All are the benzoaldehyde. These are the benzoaldehyde. Means these are aldehydes. This is the ketone. These three are aldehyde. This is the ketone. So in this aldehyde and ketone, which one more reactive? Already I told this one. Aldehydes are more reactive than ketone. Obviously 1, 2, 3 is more reactive than fourth one. Okay, that means finally it is least one. These three are highest because these three are aldehyde. This is ketone. Okay. So fourth one is least. Leave it now. In these three we have to decide now. In these three, this is normal benzoaldehyde. This is methyl group is there. Methyl group means alkyl group. Alkyl group meaning that is called plus I and plus M. Plus I means what? Electron releasing group. Now in this one NO2 group is there here. NO2 means what? Minus I and minus M. Minus I and minus M means what? Electron withdrawing group. Here electron withdrawing group, this is electron releasing group, this is neutral. That means what happened? Clearly. So electron withdrawing group increases, nucleophilic addition reaction increases. So in this which one is the electron withdrawing group? 1, 2, 3. Third one is the electron withdrawing group. So that's why third one is the highest. Next. In this two, this is neutral, this is plus. Plus means electron releasing group. Electron releasing group increases, what about reactivity? Decreases. That means in this two, which is highest? Benzoaldehyde. That means 1. Next one, 3. Last one is what? Fourth one. Why last one is 4? Because this is ketone. Why these three are highest? Because these are aldehydes. Reasons are this one. Very important. One of the time they ask the question. Not one of the time, last year only. Last year they asked the question. Next, some questions we have to solve. Parafluorotoluene to parafluorobenzoaldehyde. This is the conversion. Then observe first what happened. Parafluorotoluene toluene to benzoaldehyde. Structure first. Toluene, fluoro, para position fluoro. Okay. 2 parafluoro. Para position fluoro will not change, means as it is. CH3 is converted to aldehyde. That means methyl group is converted to aldehyde. What is the reagent we have to use? That is the reagent they are asking now. Right? That means toluene to aldehyde. That reagent already I told, that is called Itod's reaction. That means Itod's reagent. Itod's reagent, what is Itod's reagent? Chromyl chloride, CrO2Cl2 followed by CS2 followed by what? Hydrolysis. That means chromyl chloride in the presence of CS2, carbon disulfate followed by hydrolysis. You will get the toluene first intermediate product you will get, that is called chromium complex you will get, that followed by hydrolysis, then you will get benzaldehyde. This one also you can use. Sometimes instead of this one is not given. Sometimes what they given, this one is given. CrO3 followed by acetic anhydride. Acetic anhydride. This structure you should know first. Acetic anhydride. CH3 C double bond O, O C double bond O, CH3 is called acetic anhydride. Followed by what you have to do? Hydrolysis. Then automatically you will get toluene is converted to what? Benzaldehyde. In this two, which one is the better method? This is only better method. Why sir this is the better method? It will give the good yield. Why it is give the good yield? Compared to this chromium complex is somewhat what you call, somewhat byproduct you will get. Some byproduct is a byproduct is a precipitate. That precipitate will not be soluble. That is the reason. Will not be soluble means that on that case your byproduct will be there. Any compound having the byproduct is there. That byproduct is there means that compound, that reaction will give the low yield. Byproduct will not be there, that will give the good yield. That is the reason. In these two, which one is the better one? Second one is the better one. That's why instead of this, they are given this one only, that option. Right. Next one. C6H5CH2 twice CD. That means this is called benzyl, dibenzyl cadmium with 2 moles of CH3COCl, that is called acetyl chloride. What is the product? This is also one of the time they ask the question. Simple question. Observe now. What we have to remove? Here how many moles of benzyl is there now? 2 moles. Here how many moles of acetyl chloride is there? 2 moles. That means here cadmium is the 1 mole. This cadmium byproduct of the first two. If you know the byproduct, then automatically you will get the answer. CD, what we have to remove? Here cadmium we have to remove. Here what you have to remove? Chlorine. So how many moles? 2 moles. That means CdCl2 we have to remove. That is called cadmium chloride. Cadmium chloride removed. Remaining what is there? The remaining what is there? Then total will be add, join. Here C6H5 with CH2 is there. C6H5 CH2. How many moles? 2 moles. Again, this is here what is there now? Here CdCl eliminate. Here what is there now? CH3CO. But CO, CH3. This also how many moles? 2 moles. That means this is the product. 2 moles of the product. It is a better method for the preparation of ketone by using cadmium with what you call alkyl means acetyl chloride, right? This is the product. Our product is what you call ketone. Allyl alcohol, next one. Allyl alcohol to propinol. Allyl alcohol to what? Propinol. First allyl alcohol we should know the structure. CH2 double bond, CH2OA, that is called allyl alcohol. What is allyl alcohol? Hydroxyl group is attached to sp2. Hydroxyl group is attached to sp3 carbon. This sp3 hybridized carbon. Next to carbon double bond. This also you should know. Allyl, benzyl, vinyl, aryl. These definitions compulsory you should know. One of the time they ask the question. They are given names. That time that side they are given definitions one time. That time other side they are given examples. Match the following. Right? So that's why you should know the definitions. Allyl, benzyl, vinyl, aryl. And again vicinal, geminal, those two we should, those all definitions we should know. Now finally this is called allyl alcohol. Allyl alcohol to what? Propinol. So CH2 double bond is as it is with alcohol is converted to what? Aldehyde. That is called what? 1, 2, 3, propene, ene, double bond, enol. That means propanol. So, allyl alcohol to propanol. The structure you should know. So, what happened from double bond is as it is. It means double bond will not oxidize. Only alcohol is converted to aldehyde. This is oxidation. So, alcohol to aldehyde, not acid. That means what you have to use? Mild oxidizing agents. So, mild oxidizing agent is what? PCC, pyridinium chlorochromate, or PDC. Otherwise, you can use CrO3 plus anhydrous CrO3. In these three, one is PCC, other one is PDC, other one is anhydrous CrO3. In these three, any one you can use. Observe one question here. Chlorobenzene with NaOH 623 Kelvin, 300 atmosphere followed by H plus, that is X. Treated with Na2Cr2O7 followed by H2SO4, Y. What is X and Y? This is the question one of the time they ask, right? Na2Cr2O7, that is called potassium dichromate. First this one you have to know first. Chlorine is replaced by OH. If this condition is not there, reaction will not take place. That means chlorine is eliminated as a halide ion, that is means nucleophile. OH is coming as a OH minus, that is called nucleophile. One of the nucleophile is replaced by another nucleophile is called nucleophilic substitution reaction, that is nucleophilic substitution reaction. This is what? Aliphatic aromatica, aromatic, that means aryl halide, less reactive towards nucleophilic substitution reaction. Reasons already we know. What are the reason? One is resonance, second one is hybridization, third one is instability of phenyl cation, fourth one is possible repulsions. Because of those four reasons, aryl halides are less reactive towards nucleophilic substitution reaction. But this want to take place nucleophilic addition reaction, we have to supply external condition, that means high temperature, high pressure, or electron withdrawing groups. This already I discussed, just I am reminding you. So, because that's why this I am using high temperature and high pressure. Because of high pressure, high temperature, this bond you can break down very easy. Cl is replaced by OH. And what I can get the product? OH, that is called phenol. That is called what? Phenol. Phenol with Na2Cr2O7, potassium dichromate followed by H plus. Sorry, sodium dichromate and potassium dichromate, both are the strong oxidizing agents. Strong oxidizing agent, then what I can get? Converted to like this. What is this? This is which alcohol actually? Secondary alcohol. Secondary alcohol with oxidizing agent you will get ketone, right? Strong oxidizing agent means again ketone again converted to what now? Mixture of acid I told you, but here there is no chance to formation of mixture of acid because this is somewhat strain, more strain, otherwise more stable we can't break down and directly converted to alcohol to that's what phenol to ketone only. This is called as benzoquinone. What do you call? Benzoquinone or simply benzoquinone. This is the answer only now. This is one of the time they ask the question, right? Just I am giving one question to you. This is how to solve the question. This is also one of the time they ask in home. C5H11 O. C5H11O. These are the alcohols. Just I am giving the hint, alcohols, right? Question is, Total number of isomers. How many total number of isomers are possible? Including stereoisomers also. That means including stereoisomers. First you can write structural isomer. Structural isomers plus SI means what? One is stereoisomer, other one is structural isomer. Both structural isomers plus stereoisomer, that is totally how many isomers are possible? I am giving the answer is 11. So how it is possible? 11. Then you check it now. Right? This is the information today's class. Okay, Amma, thank you. Remaining I will continue tomorrow.
So good morning students. In the yesterday's class we have started the fresh chapter biomolecules. In that we have discussed many things related to this biomicro and biomacro molecules, secondary metabolites, and we are under the discussion related to the issues of the enzyme. See, these enzymes are chemically proteins, functionally catalytic compounds, I mean by catalysts. Tertiary structure of the protein is acting as the enzyme because in the tertiary structure it contains the active site. Yesterday we told that this nature of enzyme action that involves first substrate binds to the active site of the enzyme, forming a obligatory, transient, short-lived, high-energetic structure called as ES complex, enzyme substrate complex. And these enzyme substrate complex undergo many bonds making and bond making and breaking of the bonds. That leads to a new structure of the substrate will be formed, that is a product. Product will be released from the enzyme. So in this entire process, enzyme is unchanged. The unchanged enzyme will continue the catalytic cycle again. In this process, substrate to become the product, it has to pass through a particular structure called as transition state. So enzyme substrate first enter into a high energy state called transition state, then only it is entering into the form of product. There is energy difference between substrate and the product, it is called as activation energy. So the enzyme function is going to speed up the rate of reaction by decreasing the activation energy. Without the enzyme, substrate need more activation energy to reach the transition state. But with the help of the enzyme, substrate can easily reach the transition state without absorbing more energy. So enzyme decreasing that activation energy so that substrate can easily enter into transition state and become a product. Then after saying that, we told if the substrate energy is higher than the product, the reaction will be exothermic or spontaneous. Whereas substrate energy is lesser than the product, reaction will be going to the endothermic reaction. So photosynthesis is going to be the endothermic reaction, respiration is going to be the exothermic reaction, to be simple examples. Later on, now we have to discuss factors affecting the enzyme activity. Factors affecting enzyme activity. So in this, there are many factors are there which are going to affect the enzyme activity. But to be simple, we are going to discuss the 4 factors: temperature, pH, presence of inhibitors and competitive inhibitors. See, there are many, among many, first let me discuss the temperature. So there is a rule, which factor going to affect the enzyme? The factor which are going to affect the tertiary structure of the protein, those are going to the factors that affect the enzyme activity. I am repeating, the factors which can affect the tertiary structure of the protein, those are the factors that can affect the activity of the enzyme. Now the temperature is one of the major factor. For every enzyme to function, there is one particular temperature is required, we call it as an optimum temperature. So at the optimum temperature, let me explain this with the help of a graph. On the x-axis I am taking the temperature, on the y-axis I am taking the enzyme activity. So highest enzyme activity will be there at particular temperature, that temperature is going to be called as optimum. So optimum temperature is the temperature at which enzyme showing the maximum activity, and lesser than optimum temperature or higher than optimum temperature, enzyme activity will be reduced. So low temperature, less than optimum, suppose an enzyme is active at 35 degrees Celsius, this is the optimum temperature. 30, 25, 20, 10, all these are going to be low temperature. Low temperature enzyme activity will be decreases. After optimum temperature, more the temperature, less the enzyme activity. So temperature at which enzyme is showing maximum activity, the temperature is going to be called as optimum. Suppose the question will be like this, this is point A, this is point B, this is point C. Name the point at which enzyme show maximum activity, that is a point C. This is enzyme activity at the optimum temperature. So at the low temperature, what happens to the enzyme activity? At the low temperature, enzyme will be there in temporarily inactive state. Enzyme will be there in temporarily inactive state it is going to be. Whereas at the high temperature, what will happen? Yesterday I told you, enzyme is an organic catalyst, more than 40 degrees Celsius, enzyme will be denatured. So here denature means tertiary structure of the protein will be broken down into secondary structure and the primary structure. These secondary and primary structures do not have active sites, so that it cannot act as an enzyme. So high temperature, enzyme will be denatured, permanently damaged. Low temperature, enzyme will be there in temporarily inactive condition. What is required for the enzyme? Optimum temperature. Next, After that, pH. So pH is another factor that can affect the enzyme activity. Same units are changes. pH on the x-axis, enzyme activity on the y-axis. So there will be one particular pH at which enzyme show maximum. That particular pH is going to be called as optimum pH. Basic principle is same. So less than optimum pH, enzyme activity decreases. Enzyme activity decreases. More than optimum pH, enzyme activity also again decreases. So for this in the NCERT they didn't give any particular example, but how can we understand? So observe the link here. The enzyme is nothing but a protein, tertiary structure of the protein. Protein is a polymer of amino acids. So while we are discussing about the amino acids, we told that amino acids are having the ionizable nature. Ionizable nature. So at solutions of different pH, if you go for low pH, I mean by acidic concentration, structure of the amino acid changes. Basic concentration, structure of the amino acid changes. If there is a change in the pH, that will affect the amino acid structure, so that protein structure will be disturbed, eventually enzyme structure will be disturbed. So this is a possible explanation what we can extract here. So what can you say here? Observe the pH at which enzyme show maximum activity, that pH is going to be called as optimum pH. The pH less than optimum will be enzyme activity decreases. The pH at which more than optimum, the enzyme activity again decreases. Both cases at optimum it will function well, less than or more than the optimum, enzyme activity decreases. So this is temperature and optimum. Next one is a substrate concentration. Substrate concentration. So before understanding the substrate concentration, we have to understand with the help of a simple example. Suppose in a reaction there are 100 enzymes are available. Initially only 10 substrates are there. Available enzymes are 100, substrates are only 10. What is the rate of reaction? Do you remember? R is equals to amount of product formed per unit time. So that 10 substrates are there, even though 100 enzymes are available, the number of products will be 10. 10 products per unit time, whatever the time we can take. If you increase the substrate concentration by 20, for example, available enzymes are 100, substrates are 20, products will be 20 per unit time. So what we have to observe here, if you increase the substrate concentration, rate of the reaction also increases. If you go on increasing the substrate concentration, enzyme activity go on increasing until it reaches the maximum. What is the maximum? Number of enzymes equals the number of substrates. At this condition, maximum velocity will be there, that is 100 products will be formed per unit time. So what up to here the observation we have to have is, if you increase the substrate concentration, rate of reaction also increases until it reaches the maximum. So at the maximum velocity, do you remember rate can be also called as velocity if there is a particular direction. So this velocity will be maximum when there is a amount of enzyme and amount of product will be equal. Other than this, if you go further beyond, suppose 110 or 120 or infinity, until however whatever your wish, if you go on increasing the substrate concentration more than the optimum, what is the maximum velocity, amount of product formed will be same. Means this in the form of a graph, let we convert it. On the x-axis I am taking the substrate concentration, on the y-axis I am taking the velocity. Velocity I mean by rate of the reaction. So if initially if the substrate concentration increases 0 to 1, 2, 3, 4, 5 like this, substrate concentration increases, rate of reaction also increases until it reaches the maximum velocity. So this is the point, we can assume it as V max, maximum velocity. If you go on increasing the substrate concentration, velocity of the reaction also increases until it reaches the maximum. Maximum means number of substrates equals the number of enzyme. So until it reaches the maximum, there is an increase. After that, if you further, this is the point where it is maximum. Further, if you go on increasing the substrate velocity, substrate concentration, there is no further increase. The graph will be stationary. Why? Because at the maximum velocity, enzymes equals to substrate. More than the maximum if you go, number of substrates are more, number of substrates are greater than number of enzymes. So, number of enzymes will be lesser than the substrate. So, suppose 110 substrates are there, only 100 enzymes are there. 100 enzymes can bind to only 100 substrates. Number of substrate will be more than enzyme, so that rate of reaction will be increased. So, totally we can conclude here. Initially, if you increase the substrate concentration, velocity or the rate of reaction increases until it reaches the maximum. At the maximum, if you further increase the concentration of the substrate, there is no further increase in the velocity, because enzyme molecules are lesser than the substrate. Then here another unit we can assume. There is a constant called as, we can write it here, Km. What is this Km? Km is a Michaelis-Menten constant. Michaelis-Menten constant. What is this constant? It is a substrate concentration at which velocity of the reaction is half of the maximum. Half of the maximum means here Vmax by 2. Half of the maximum velocity. If you intersect this and try to bring it onto the substrate concentration. So, Km indicates the substrate concentration at which the velocity of the reaction is half of the maximum. Such concentration we can represent by Michaelis-Menten constant. So, what we can assume here? Initially, if substrate concentration increases, velocity also increases until the maximum. After the maximum, even though if you increase the substrate concentration, there is no further increase, because number of substrates are more than number of enzymes. In this, another constant is Michaelis-Menten constant. It indicates the substrate concentration at which velocity is half of the maximum. So, this is the substrate concentration. Next, presence of certain chemicals called as inhibitors. So, inhibitors are the other elements which are going to affect the enzyme activity. First, what is an inhibitor? Suppose for the enzyme, I am drawing the pictorial form. This is the active site. Who has to bind the compound which is going to bind to the active site of the enzyme, that is considered as a substrate. So, the substrate after binding the enzyme, it will be converted into product. Now, what is an inhibitor? Inhibitor is a chemical that is going to bind to the enzyme anywhere it is going to bind to the enzyme and decreases the enzyme activity. The chemical that binds the enzyme and shuts off, textbook word, shuts off, decreases or stops the enzyme activity, such chemicals are called as inhibitors. Such process is called as inhibition. Chemical name is inhibitor, process is called inhibition. So, inhibitors are the chemicals binds and decreases the enzyme activity. There are different kinds of inhibitors are there. As per our syllabus is concerned, we are discussing one particular inhibitor called as a competitive inhibitor. So, what is this competitive inhibitor represents? Competitive inhibitor resembles the substrate. Competitive inhibitor resembles the substrate, or the inhibitor that resembles the substrate's unit molecular structure. Structure of the inhibitor will be same like structure of the substrate. So, that automatically there arises a competition. Suppose let us say this is the structure of a substrate S. It is ready to bind with the active site of the enzyme, but no, there is another chemical going to enter into the story here, that is inhibitor. So, inhibitor resembles the substrate's unit molecular structure. So, that this can also bind with the active site of the enzyme. Then there is a competition occurs between inhibitor and the substrate concentration. So, that ultimately who will bind? Inhibitor will bind and stops the binding of substrate to the enzyme. If enzyme was bound to the substrate will be converted into product. But instead of binding of substrate to the active site, this inhibitor stopping the substrate, so that this inhibitor binding to the enzyme and stops the enzyme activity, because inhibitor cannot be converted into product. So, what is the difference between inhibitor and a competitive inhibitor? Inhibitor is a chemical, binds anywhere, shuts off the enzyme activity. Competitive inhibitor is a kind of inhibitor where it is going to stop the enzyme activity, but there is a specification here. This inhibitor resembles same like substrate. So, the inhibitor looks same like substrate and competes with the substrate to bind to the active site of the enzyme. That is why it is called as a competitive inhibitor. For example, the enzyme we can have is a Krebs cycle enzyme succinic dehydrogenase. So succinic dehydrogenase is an enzyme belongs to Krebs cycle. We have already discussed the details of this. In the Krebs cycle, succinic acid is converted into fumaric acid. Succinic acid is converted into fumaric acid with the help of enzyme succinic dehydrogenase. Same succinic dehydrogenase is complex 2 in case of the ETS, oxidative phosphorylation happening within the mitochondria, process of respiration. So now this succinic dehydrogenase enzyme going to have a active site that will be binded by the substrate. The substrate for this is going to be called succinic acid. You can also call it as a succinate. Succinate or succinic acid is the substrate bind to the succinic dehydrogenase. But same like succinate, there is another compound called malonate or malonic acid. This malonic acid binds with the succinic acid for binding to the, competes with the succinic acid to bind to the active site of the enzyme. Ultimately malonic acid will bind, decreases the enzyme activity. So here students confuse as much. Generally there are two particular acids look same, malic, malonic. Malic is not involved in this. Malonic acid or malonate, ATE means acid in this condition. So malonate is going to compete with the substrate succinate for binding to the enzyme succinic dehydrogenase. See, these competitive inhibitors are generally used to control the bacterial pathogens. Bacterial pathogens will be controlled by competitive inhibitors. So this is one of the important statement everyone has to remember. So these are the 4 factors which are going to affect the enzyme activity: temperature, pH, substrate concentration and the inhibitors. Enzymes require optimum temperature and optimum pH for showing the maximum activity. Substrate concentration, initially it increases the velocity of the reaction until it reaches maximum velocity. After that there is no increase. Inhibitors binding to the enzyme activity, decreasing the enzyme activity. If the inhibitor looks like the substrate, it is going to be called as competitive inhibitor. Example for the competitive inhibitor is malonate, enzyme is succinic dehydrogenase and the substrate in this case is succinate. And this competitive inhibitors are going to control the bacterial pathogens. So there completes the factors affecting enzyme activity. Hope you got the idea. After that, let we continue with the remaining details. I mean by classification or nomenclature of the enzymes. Classification and nomenclature of enzyme. Observe. So first, when it comes to classification, there are different kinds of enzymes are there. Thousands of enzymes have been discovered, isolated and studied until now from different kinds of organisms. Related to this, one particular number from the biotechnology I am taking, 900 different restriction enzymes have been identified from 200 and different strains of bacteria. So whatever restriction or normal, it is an enzyme. So like that, just remembering, thousands of enzymes, thousands of types of enzymes till now discovered, isolated and studied. Later, all these enzymes for our ease of understanding and studying, we are converting into different classes and we are naming it. So there are 6 classes of enzymes are there. 6 classes of enzymes, each class having 4 to 13 subclasses. Each class having 4 to 13 subclasses. Each subclass again divided into subclasses. So now when it comes to nomenclature, each enzyme is having a 4-digit number. Each enzyme is having a 4-digit number. What is this 4-digit indicate? The first digit indicates the class of the enzyme among the 6. Second indicates the subclass. I told each class contains 4 to 13 subclasses. The third digit indicates the subclass. Subclass. And the fourth digit, don't expect what I am going to write. It is not subclass. It is going to be order of isolation. Order of isolation. So these are the 4-digit number for each enzyme. We are having this enzyme classes, subclasses, subclasses and order of isolation. So this is the, or you can call it as a serial number we can call it, or order of isolation. Next, let me discuss these 6 classes of the enzymes. First class is oxidoreductases. Oxidoreductases, also called as dehydrogenases. Dehydrogenases or oxidoreductases. What they are saying? Suppose, for example, there is a substrate which is there in a reduced form, going to get reacted with another substrate called S dash. It is there in an oxidized form. Later on, this going to be exchanged. Before saying the products, basic idea what we should have here is, reduced form means it is having more hydrogens. Addition of hydrogen is called reduction. Removal of hydrogen is called oxidation. Let me look at this in the perspective of hydrogen. There is electron perspective, there are oxygen perspective, different things are there related to this reduction and oxidation. For our easy understanding, high addition of hydrogens is called reduction, removal of hydrogens is called oxidation. Now, from this, hydrogens are removed and added to this. So that what is happening to this? Removal of hydrogens, substrate S, by losing the hydrogens it will come the oxidized state, and substrate S dash, by receiving the hydrogens it will become reduced state. So the oxidoreductases are the enzymes which are doing oxidation and reduction reactions between the substrates. Oxidation and reduction reactions occurs by transferring the hydrogens or even oxygens or electrons. So simply, mainly we are considering it as hydrogens, no, we are calling it as dehydrogenases, removal of hydrogens, or oxidoreductases. These are the enzymes that involves the transfer of hydrogens from one substrate to another substrate. Subsequently, one substrate is going to get oxidized, another going to be reduced form. So these are the enzymes called oxidoreductases or dehydrogenases, first class of enzymes. Second class of enzymes are transferases. So these transferases are enzymes which are going to involving in transfer of groups. Transfer of groups between different substrates. Let me consider it as a group G. So there is a substrate having a group G, whether it is a OH group or a acidic group, or it may be function different, any ketone, aldehyde, different kinds of functional groups are there. For example, I have considered one group, that is group G. So substrate attached with a group G going to react with another substrate called S dash. So now this group G which is removed from here and transferred to the S dash. So that substrate S plus substrate S dash G. So what is happened? There is a transferring of groups from one substrate to another substrate. Such kind of enzymes are called as transferases. These transferases going to transfer the groups, remember, other than hydrogen. They are not going to transfer the groups called hydrogens, because hydrogens are done transfer by oxidoreductases or dehydrogenases. In the textbook they have clarity mentioned, transferases are the enzymes involved in the transferring of substrates called groups from one transferring of groups from one substrate to another substrate other than hydrogen, except hydrogen. Then the third class of enzymes are going to be hydrolases. Hydrolases. Hydrolases are the enzymes involved in hydrolysis, breakdown. Lysis means breakdown. So hydrolysis of compounds or bonds. Hydrolysis of the bonds. So there are many kinds of breakdown is going to happen within the living organisms or any other way. For example, starch, I told it is a polysaccharide, homopolymer of glucose having the bonds called glycosidic bonds from one glucose molecule to another glucose molecule. This starch will undergo hydrolysis by the enzyme hydrolases so that it will be converted into glucose. Many glucose units. Suppose in this condition you can take sucrose. Sucrose will be broken down into glucose and fructose with the help of enzyme invertase. Here also this is the situation where glycosidic bond will be broken. So hydrolases are the compounds which are involved in breakdown of bonds. In the textbook they had given different examples, ether, ester, peptide, glycosidic, diester, different kinds of bonds are there. So different kinds of bonds will be broken by the enzymes called hydrolases, by the process called hydrolysis. These are the third group of enzymes. Next, fourth group of enzymes are going to be called as lyases. Lyases are the enzymes involved in removal of groups. Removal of groups by mechanism other than hydrolysis. By mechanism other than hydrolysis. They are not involved, they are just removing the groups. By one place to another place, groups are removed. So transferases involved in transferring of groups, lyases are involved in removal of groups by not following the method of hydrolysis, and they are going to leave the double bonds. This is the important character here. So lyases involves in removal of groups by mechanism other than hydrolysis by leaving the double bonds. With the example, let me study this. There is a carbon and there is another carbon. This is attached with a group called X, this is attached with a group called Y. Later on, after the action of these lyases enzymes, between carbon and carbon they left the double bonds, and these groups X and Y are removed. So with this example you can understand the lyases. Lyases involves in the removal of groups by mechanism other than hydrolysis, leaving the double bonds. Those are the lyase enzymes. Next, fifth group of enzymes are isomerases. Very simple enzymes, isomerases. These isomerases are involved in the interconversion of different kinds of isomers, positional isomers, geometric isomers, even what can you say, geometric isomers, different kinds of isomers. So one form of isomer, D form, will be converted into L form, levorotatory converted into dextrorotatory. So the one form of isomer is converted into another form. This interconversion is done by the enzymes isomerases. Positional isomers, geometric isomers, different kinds of isomers are there. For example, our understanding, glucose is in aldose form, converted into fructose. Glycolysis itself we have seen. Glucose will form the glucose 6-phosphate, that is okay. Glucose 6-phosphate will be converted into fructose 6-phosphate. So fructose is a ketose form, glucose is an aldehyde form. Aldehyde form of sugar is converted into ketose form of sugar by the process of isomerization. The enzyme involved here is isomerases. They are going to do the interconversion of the substrates. Next, after that, last one is going to be the ligases. So ligases are the enzymes, especially we are highlighting these enzymes in biotechnology concept, even in molecular basis concept. So biotechnology where we have seen this ligases for the joining of two DNA molecules. So specifically this is the class of enzymes, what they are doing, they are involved in linking together of two compounds. They are involved in linking together of the two compounds. So these liases are the enzymes, we can consider it as a molecular glue. Why they are considered it as molecular glue? In rDNA technology, vector DNA will be attached with the gene of interest or alien DNA by the enzymes ligases. Molecular scissors are restriction enzymes, molecular glue is going to be the ligases. Not only DNA, it can attach different kinds of compounds. Different kinds of compounds will be joined by the enzymes called ligases. So overall picture if you observe, until now thousands of enzymes have been discovered, isolated and studied. Among them we are considered them as 6 classes. Each class is having 4 to 13 subclasses. Later on, each enzyme we are given the nomenclature by 4-digit number. Class, subclass, subclass and order of isolation or serial number, whatever it may be. Next, this what are the 6 classes? Oxidoreductases, transferases, hydrolases, lyases, isomerases and ligases. Oxidoreductases involved in the transferring of hydrogen simply. They are involved in reduction oxidation reactions. And the transferases, transferring of groups from one substrate to another substrate other than hydrogens. Hydrolases are going to break down different kinds of bonds like ether, ester, peptide, glycosidic, phosphoester, different kinds of bonds are there. Starch will be broken down into glucose by the action of this hydrolases enzyme. Next, fifth group is going to be lyases. They are involved in removal of the groups. Isomerases, interconversion of the groups. Ligases, linking together of the groups. Generally, students in the question papers, they are confusing between lyases and ligases. Simple logic. Remember, G for glue. G for glue. Glue or gum, which is going to attach two things. So ligases are the enzymes which are going to attach two compounds. So G for glue, gluing enzymes, simply. The opposite is going to be the ligases, they are involved in removal of the groups. So these are the 6 classes of the enzymes and their detailed stories. Later, last discussion has to be done, that is going to be the cofactors. So what are these cofactors? In the enzyme, generally we told enzyme is a protein part. But if you go deeper into the enzyme discussions, protein part of the enzyme is having another friend, that is a non-protein part. Can we say? So enzyme is having main part is protein part, additional part is also there, that is called as a non-proteinaceous compound. Non-protein. So protein part of the enzyme is called apoenzyme. Apoenzyme. Non-protein part of the enzyme is called cofactor. So both are combinedly considered as a holoenzyme. Holoenzyme means a complete enzyme. Complete enzyme. So there is no doubt, sir, we have discussed no enzymes are proteins. Now why you are saying it is a non-protein? So main part of the enzyme, which is the functional part of the enzyme, is the protein part. We can consider it as a apoenzyme. But this apoenzyme to function properly, they require additional support. The additional support or activating part of the enzyme, that is going to be called as a non-proteinaceous. We have given a name called cofactors. So cofactors are the non-proteinase components which are going to make the enzyme catalytically active. Non-protein part called cofactors makes the enzyme catalytically active. Such cofactors are very important for the enzyme to function. So what is the importance of these cofactors? Now if you remove the cofactor from enzyme, catalytical activity will be lost. So for the enzyme to function properly catalytically, non-protein part is very, very important. So this word is not there in the textbook, but we have to assume this, we have to understand this. Apoenzyme is a protein part, cofactor is a non-protein part. So how to remember? Here also general confusion comes. How I used to say generally, protein P, apoenzyme P. So protein part is the apoenzyme. Just connect it as like this for the remembering purpose. So apoenzyme means what? Protein part. Opposite is cofactor, which is a non-protein part. So cofactor makes the enzyme catalytically active. We can call it as a holoenzyme. Holoenzyme. Next, these cofactors are of different types. Different types of cofactors are there. Let we discuss. So in this first one is going to be the prosthetic group. Next one is going to be the coenzyme. And finally it is going to be the metal ion. So there are 3 cofactors are there here, prosthetic group, coenzyme and the metal ions. See this prosthetic group, spelling prosthetic group. Now this prosthetic group is a organic cofactor, carbon containing cofactor, and this prosthetic group going to bind the apoenzyme tightly bound to apoenzyme, very, very, very tightly bound to the apoenzyme. And this prosthetic group example is heme. Heme is a prosthetic group, acts as a cofactor. For the enzyme, 2 particular enzymes are there. One is peroxidase and catalase. Peroxidase and catalase are the 2 enzymes. For them, there is a essential non-proteinaceous cofactor is required in the form of prosthetic group, that is heme. But these 2 enzymes are involved in hydrolysis of H2O2. Guess what? Hydrogen peroxide. So this hydrogen peroxide will be broken down into oxygen and water. For the balancing of the reaction, I am taking 2H2O. 2H2O will be become released as O2 and 2H2O2 will be become O2 and 2H2O. So overall what we can say, prosthetic group is a cofactor, non-proteinaceous part, it is organic cofactor tightly bound to the apoenzyme and it is helpful for the catalytic activity of the enzyme. Example prosthetic group is the heme. Heme is a prosthetic group for the two enzymes, one is the peroxidase, another one is going to be the catalase. These two enzymes involved in breakdown of the hydrogen peroxide into oxygen plus water. So this is about the prosthetic group. Next one is the coenzyme. But this coenzyme is also a organic cofactor. Coenzyme is also a organic cofactor. It is also going to bind with the apoenzyme, but the kind of binding is different here. It is not going to bind it tightly, the binding here is transiently. Transiently it is going to bind with the apoenzyme or protein part of the enzyme. So what is meant by transient? Only during the time of catalysis. During the time of reaction, this coenzyme binds to enzyme. The moment the catalysis was completed, I mean by breakdown process was completed, it will be released. If I say the example easy for you to catch up, NAD and NADP. Full form, nicotine amide adenine dinucleotide. Nicotinamide adenine dinucleotide. For this one, nicotinamide adenine dinucleotide phosphate. These two are the example for the coenzymes. These two, for example, if I say, if you remember the pyruvic acid, not the pyruvic acid, G3P in the glycolysis. G3P in the glycolysis. G3P is converted into 1,3 bisphosphoglyceric acid. 1,3 bisphosphoglyceric acid. Here, for the enzyme involved here, dehydrogenase enzyme, NAD plus is binding, accepting the hydrogens, and it will be released as NADH plus H plus. This is bind to this particular enzyme, dehydrogenase enzyme, which is involved here only at the time of reaction. The moment reaction was completed, it was gone away. That's why it is called as a transient binding. So coenzyme is an organic cofactor, its binding is transient, only during the time of catalysis and temporary binding. After that it will be released. But even though its binding is temporary, if it is not bound to the apoenzyme can't function. Binding is very important. Next, among all three, majority of the enzyme catalyzed reactions, who is the cofactor? Coenzymes, means dominant. This is involved in majority of the reactions which are done by the enzymes. And now these coenzymes to function, they require essential chemical component. Essential chemical components are required in them. What are these essential chemical components? These are in the form of vitamins. So vitamins are the compounds which are acting as important chemical components of these coenzymes. So don't confuse, for the enzyme or protein part of the enzyme to function, cofactor is required. One of the kind of cofactor is coenzyme. So coenzyme is a non-proteinaceous part making the apoenzyme active. For this coenzyme to function, it requires essential cofactor, essential chemical component, that is going to be called as vitamins. So vitamins makes the coenzyme active, coenzyme makes the coenzyme makes the apoenzyme active. That is the logic. Now this for these two, NAD and NADP, for them niacin, B complex vitamin. So this niacin is going to act as an essential chemical component in case of NAD and NADP. Further, if you want another example, FAD, ferredoxin adenine dinucleotide. This FAD, where we have seen this FAD? So again, succinic dehydrogenase enzyme. Just now we have discussed for competitive inhibitors. So succinic acid is converted into fumaric acid. In this condition, FAD will be converted into FADH2. Enzyme succinic dehydrogenase. For the succinic dehydrogenase to function, FAD binding is important. After that it was gone away, enzyme will become inactive. The moment both come closer, enzyme will become active. That is the logic. So coenzymes are the organic cofactor, binding is temporary only at the time of reaction, and in them essential chemical components are required, those are called as vitamins. For example, coenzymes are NAD, NADP and FAD. NAD and NADP, niacin is the essential chemical component. And among the three kinds of cofactors, majority of the enzyme catalyzer reactions are done by the coenzymes. Next, metal ions. So metal itself, it is going to say one logic, these are inorganic. So these are the inorganic cofactors, and these are not going to bind tightly or not going to bind transiently. These are going to bind by formation of different kinds of bonds. Those bonds are called formation of coordination bonds. They are going to form the coordination bonds with the side chains of the active site. Side chains of the active site. How come? Let me draw an imaginary diagram. I am saying here itself it is an imaginary diagram for our understanding. Suppose this is an enzyme which is a protein in the tertiary structure. This is the active site and these are the side chains present in this particular active site. And these metal ions are going to form the bonds. We can call those bonds as coordination bonds. So the metal ions forms the coordination bonds with the side chains of the active site. Simply they are going to attach with the active site with the formation of coordination bonds. Remember like that, more than enough. And there is another thing, when the substrate come and bind to the active site, these are going to these are going to, metal ions are going to form the coordination bonds with the substrate also. So the textbook statement, what it says, metal ions are the inorganic cofactors. They are going to form a coordination bonds with the side chains of active site, and they also form the coordination bonds with the substrate because they are present at the active site. To the active site, who are going to bind? Substrate, while they are ready at the active site, so that they can bond this, they can form coordination bonds with the substrate also. So this is the thing. So metal ions, example zinc is a metal ion for the enzyme carboxypeptidase. Enzyme carboxypeptidase. What the textbook says, it is a proteolytic enzyme. Proteolytic means it is going to break down the proteins. Name itself say peptidase. It is going to break the peptide bonds. So carboxypeptidase is an enzyme, proteolytic enzyme. For this enzyme to function, zinc is required. This is the example present in this. Let me connect it with the respiration concept. Already we have covered. Link reaction, if you remember properly, link reaction. So in the link reaction, pyruvic acid, which is formed as a product of glycolysis, in the cytoplasm, it will be transported into the mitochondria during aerobic respiration. So this pyruvic acid will be converted into acetyl coenzyme A. Acetyl coenzyme A. In this, the enzyme involved is pyruvate dehydrogenase. Pyruvate dehydrogenase. For this enzyme to function, one metal ion is required, that is magnesium 2+, divalent cation. So magnesium is a metal ion present for the pyruvic dehydrogenase. Along with that, it also requires another cofactor, that is NAD+. NAD+ will become NADH+ H+. Another kind of coenzyme is required. What is another kind of coenzyme? Coenzyme A. So I have explained this reaction there also. It is easy for you to understand now. So what is the reaction? Pyruvic acid is converted into acetyl coenzyme A, link reaction. The enzyme involved is pyruvic dehydrogenase. For this enzyme to function, metal ion is required. Which metal ion? Magnesium. So magnesium is attached so that pyruvic dehydrogenase converts the pyruvic acid into acetyl coenzyme A. So along with the magnesium divalent cation, it required the coenzyme called NAD+. Along with another coenzyme is required, that is a coenzyme A. So this is a classical example how and why and what they are going to do. The pyruvate dehydrogenase enzyme or any kind of enzyme to function, metal ions or coenzymes or prosthetic enzymes are required. So this is the overall picture. What can you understand here? Cofactors are the non-proteinaceous parts, binds to the protein part of the enzyme. What do you call protein part of the enzyme? Apoenzyme. Apoenzyme binds with the cofactor so that this will be activated. The active form or wholesome part of the enzyme is going to be called as holoenzyme. So these cofactors are the non-proteinaceous factors divided into three types: prosthetic group, coenzyme and the metal ions. So prosthetic group is an organic cofactor, coenzyme is also organic cofactor, metal ion is an inorganic cofactor. Prosthetic group binds tightly to the apoenzyme, coenzyme is going to bind to the apoenzyme but transiently during the time of catalysis. And this metal ion is going to form the coordination bonds with the side chains of active site, and also it can form the coordination bonds with the substrate. So this is the kind of binding. And now the examples: heme is a prosthetic group for peroxidase and catalase involved in breakdown of hydrogen peroxide. Coenzymes are examples: NAD, NADP and FAD. In them there is essential chemical component is required, those are the vitamins. In this case for these two, that is an niacin. Next, metal ion example is zinc, their example is magnesium. Zinc is an important metal ion or cofactor for the carboxypeptidase, which is a proteolytic enzyme that is involved in the breakdown of the proteins. And now here for the pyruvate dehydrogenase enzyme, metal ion is magnesium, along with that NAD and coenzyme A are required. So there completes the total concept of enzymes, and thereby subsequently we have completed the biomolecules concept. So this biomolecules concept, majority students requested one. After that, let me move ahead. Lipids are found in soluble or insoluble fraction, acid soluble or acid insoluble fraction. Just think on it. So lipids found in acid insoluble fraction. Answer. Why? Next question. Are they polymers strictly? No, they are not the polymers. Are they having molecular weight more than 800 Daltons? No. But still, even though their molecular weight is less than 800 Daltons, still they are present in acid insoluble fraction or retentate. How it is possible? Do you remember the logic? Lipids, while we are grinding the cell structure, we are disrupting the cell structure. Whatever lipids present in this plasma membrane will be released and form a circular structures called as vesicles. These vesicles are not soluble in this water and acid. That is why they are present in insoluble fraction. Remember it. Next. After saying this thing, another most requested thing is cell cycle and cell division concept. Cell cycle and cell division. Today let me complete the introductory part. Tomorrow we will complete the total chapter itself, as it is a small one. Now cell cycle, cell division, first what is happening during the cell cycle? So any kind of cell, any kind of cell. In botany language, if I have to say, meristematic cell. So meristematic cell, where we have seen plasmatic growth, that is a plant growth and development, increase in the amount of protoplasm. First, cell will undergo a process called as a cell growth. Cell growth. What is meant by cell growth? Increase in the amount of cytoplasm, or we can consider it as a protoplasm. As undergoing the growth, size of the cell will be increased. After undergoing increase in the size of the cell, this cell undergoes second process. During this process itself, it is going to undergo second process, that is called as DNA replication. So DNA replication is a process, amount of DNA will be copied into 2. Next. After that, as the cell size increases, it will undergo third process called as a cell division. So this combinedly is called as a life cycle of a cell, or we can also consider it as a cell division, cell cycle. So observe, cell first undergo growth, in which components of the cell will be increased, including cytoplasm, cell organelles and everything. During the cell growth itself is undergoing second process called as DNA replication, where amount of DNA is doubled. And the third, after undergoing the above two processes, eventually it is dividing into 2. So what they had given the definition for the cell cycle, simple definition: cell synthesizes components of the cell, undergo duplication of the genome, and eventually dividing into 2. That is going to be the cell cycle. But these three processes should undergo in a coordinated manner for the proper division of the cell. First cell growth, DNA replication, after that cell division. There should be a coordination between these processes. Then only complete division or proper division of the mother cell into two daughter cells will be completed. That is the logic. Next, among these three, this cell growth is a continuous process. Cell growth is a continuous process. Any kind of cell undergoing continuous growth, if it is a meristematic cell, if it is there in the cell division cycle. So, cell growth is a continuous process, undergo increase in the cytoplasm. That, whereas DNA replication occurs in a single step. I hope so you remember that step. That step is going to be called as DNA replication. So, DNA replication is a process where it is going to happen only in one particular, not single step, it is actually single phase. It is occurring in single phase. What is that single phase? S phase. S means synthesis phase. Whereas cell division, after undergoing these two, cell is undergoing the division. So, these are the three particular things should occur in a coordinated manner. Under these three are under the control of genes, genetic control for the coordination process. Next, after that, duration of the cell cycle. Duration of cell cycle is different in different kinds of cells. What is the duration here in case of our favorite yeast, Saccharomyces cerevisiae? It is having 90 minutes. Cell division time for the yeast is going to be the 90 minutes. Related to the yeast, there are many points are there in our syllabus is concerned. First point, it is a unicellular eukaryotic organism and it is belongs to fungi Ascomycetes. And this yeast is, we have discussed it in the chapter microbes in human welfare, baker's yeast and brewer's yeast. It is involved in baking procedures. And in respiration chapter, what we have discussed about the yeast, yeast undergo alcohol fermentation. Yeast poison itself to death when alcohol concentration reaches up to 13%. And the same yeast we have discussed in case of human genome project. It is a non-human model where we have done the sequencing. And even procedure of the human genome project, we can consider the yeast for carrying the, gene of interest, yeast artificial chromosome. So, different places we have discussed about the yeast, and this is the next place where yeast cell cycle time is going to be 90 minutes. And another one is most commonly used one, E. coli bacteria. This information I have taken from molecular basis concept and it is connected here. So, E. coli bacteria, it is going to have the 20 minutes of cell cycle duration. And another one is going to be the human cell. Within the human being, we didn't observe it, human cell in culture. In vitro conditions. So, human cell in the culture undergo 24 hours for the division. Like that, if you go on searching, different kinds of durations are possible. What we have to extract here information, cell cycle duration is different in different organisms based on the complexity of cell. Then this cell cycle will be divided into two phases. One is interphase, another one is going to be the M phase. So, interphase is the resting phase, generally we call, but the cell is preparing itself for the division to happen. So, this interface and related issues we are going to discuss in the tomorrow's class. And what we have discussed now in the biomolecules, enzyme classification, enzyme cofactors and factors affecting enzyme activity. And we have started the new chapter called cell cycle cell division. This will be discussed in the upcoming class. So, total tomorrow we are going to complete this. We are having still, after tomorrow, we are having still 2 days are there. How much possible we can cover it off. So, this is our for today. Once go through the concept of biomolecules, so that any other doubts are there will be cleared by the end. Thank you.
Okay, good afternoon all of you students. In the last class, viscosity and pressure concept we can explain now the topic is nothing but Bernoulli's theorem. Now listen some small points on the fluid mechanics some small topic is there. After that surface tension and surface energy. Okay, now first one is equation of continuity. Equation of continuity. Already we know that this is the tube. This area and this area are different. Like area is A1, no, area is A2. The liquid is entering with a speed V1, no, liquid is leaving with a velocity V2. So that's why what is the meaning of here different area of the tubes kadam A1 and A2. Velocities are V1 and V2 ga, right. Now one of the important point. The mass of the liquid entering per second in the tube is equal to mass of the liquid leaving in the tube per second. Here mass of the liquid entering in the tube at one end is equal to mass of the liquid leaving in the tube per second is also same and also known as volume rate of flow. Per second how much volume of the liquid is entering, the same volume of the liquid is leaving per second. So simply is known as volume rate of flow. Volume rate of flow and volume by time. The volume rate of flow of the fluid in the tube is equal to area into velocity. Like, so A1 V1 is equal to A2 V2. That value constant like A1 V1 is equal to A2 V2. Very, very important formula. So in a different area of the cross section of the tube, the mass of the liquid entering per second is equal to mass of the liquid leaving per second, or the volume of the liquid per second entering is equal to volume of the liquid per second leaving, both are same. And also known as volume rate of flow and volume by time. Volume by time is nothing but area into velocity. That value constant This one volume This one velocity So simply A1 V1 is equal to A2 V2. So area is inversely proportional to velocity. More area having the less velocity. Less area having the more velocity. So that's why this point is the important. Now, the equation of the continuity is works on the principle of law of conservation of mass. Law of conservation of mass. Equation of continuity works on the principle of law of conservation of the mass. And the mass of the liquid entering is equal to mass of the liquid leaving. That's where works on the principle of law of conservation of the mass. Like, this is the important point. Area is inversely proportional to velocity. Area and velocity graph shape inversely rectangular hyperbola. Inversely proportional to rectangular hyperbola. This is the another important graph. Now, one example. Here area A1 V1 is the speed, A2 and V2, A3 and V3. So what is the relation between them? Now here liquid is entering. The liquid is entering in the tube. Now that liquid is dividing the two parts. Now already we know that volume of the liquid entering per second in the tube is equal to volume of the liquid leaving per second in the tube. That's why volume rate of flow is the same. A1 V1 is equal to A2 V2. What is the entering? A1 V1. What is the volume of the liquid leaving? A2 V2 plus A3 V3. So therefore A1 V1 is equal to A2 V2 plus A3 V3. This is the another important point. So in equation of continuity, these points are the important. Now next point. Bernoulli's theorem. Now, Bernoulli's theorem means this is the ground. Here, one tube is there. This is the one tube. So, here, the pressure energy is P. Here, height is H1, pressure energy P1, pressure energy P2, height is H2. The liquid entering with a speed V1, liquid leaving with a speed is V2. Now, the Bernoulli's theorem works on the principle of law of conservation of energy. Law of conservation of energy. So, Bernoulli's theorem, it works on the principle of law of conservation of the energy. Now, here, this is the tube, different areas. Here, one area, this is the another area. Different areas, that's where the speeds also different. Here, V1 and V2. This end height is H1, this end height is H2. Whose pressure energies are P1 and P2. Now, according to the Bernoulli's theorem, when a liquid is flowing in a tube, at any point, whatever may be the point, starting, ending and middle one, any point, the sum of the pressure energy and potential energy and kinetic energy per unit volume of the liquid is constant. What is this one? At any point in the tube, this one is the pressure, not pressure. This is nothing but pressure energy per unit volume, potential energy per unit volume, kinetic energy per unit volume. So, at any point in the tube, the sum of the pressure energy and potential energy and kinetic energy per unit volume of the liquid is the same. That is known as Bernoulli's theorem. So, P plus rho GH plus half rho V square is equal to constant. That is the Bernoulli's theorem main point. So, it works on the principle of law of conservation of energy. This one is the very important point. Next one. Now, another important point. Venturi meter. Already yesterday we can explain the one point. Venturi meter, previous NEET question. Venturi meter works on the principle of Bernoulli's theorem. So, here one important point is there. Now listen. Now listen carefully, this is the Venturi meter. What is the main use of this Venturi meter? It is used to measure the volume rate of flow of the liquid in a tube. For example, in a tube, some liquid is flowing. So per second, how much of the volume of the liquid is flowing? How to identify? Like by using the Venturi meter. By using the Venturi meter, like this device, it is used to measure the volume rate of flow of the fluid in a tube. That is the very important theory point. Now, that point main only one formula. Now listen carefully. What is the volume rate of flow of the fluid in a tube? That is the one of the formula. What is that? Volume rate of flow of fluid is, volume rate of flow of the fluid in a tube is A1 A2 root of 2GH by A1 square minus A2 square. That's why the only formula is enough. What is the volume rate of flow of the fluid flow in a tube? A1 A2 root 2GH by A1 square minus A2 square. Area A1, area A2. Larger area having the velocity V1, smaller area having the velocity V2. Now here liquid, here one more height is rise, here less height is rise. What is the difference of the height? H, like 2GH by A1 square minus A2 square. Only this one is the enough important point. So another important point. Here what is the velocity V1? What is this velocity V2? Now the relation between V1 and V2 is V2 square my1 minus V1 square is equal to 2gh. Initial velocity, this one final velocity. What is the difference of the liquid height h? That's why what is the relation between them? V1 square minus V2 square minus V1 square is equal to 2gh. In total Venturi meter, only the important points are like this two. So already we know that Venturi meter works on the principle of Bernoulli's theorem. Because of this total derivations came by this Bernoulli's theorem. So that's where these two formulas are is enough in Venturi meter. Now last point, speed of efflux. Speed of efflux or Torricelli's theorem. Or Torricelli's theorem or speed of efflux. One more point, now listen carefully. This is the vessel. Up to here, water is there, whose cross-sectional area is A. The total height is h. The total height is h. Here, one small orifice. Orifice means like a hole. That whole area is a small a. Now, compared to tank area, like vessel area, this hole is very small. Like this value is very, very greater than a. That's why here liquid is ejected horizontal. What is the speed of the liquid? What is the speed of that liquid? Is known as speed of efflux. So what is that speed of efflux? V is equal to root 2gh. V is equal to root 2gh. That is known as speed of efflux. Speed of efflux. And also nothing but Torricelli's theorem. One of the important point. Now listen carefully. Now another point. This is the total height is h. Total height of water is there. Here one small orifice. Small orifice. How much height? This one is h. Here h minus h. This is the ground. When a liquid is ejected, some speed is known as speed of efflux. The liquid is falls on the horizontal surface. Now first point. What is the speed of the efflux? V is equal to, how much height is there? This one h. Now in case of the height h, what is the value of V? Like 2gh. That whole above now, how much height is there h? That's where what is the speed here? 2gh. 2gh. Now second point. The time taken by the liquid to reach the ground is, the time taken by the liquid to reach the ground is time 2h by g. 2 into h minus h by g. Already we know that horizontal projectile. When your body projected horizontally, how much time is taken? Root 2h by g. Height is nothing but h minus h by g. Third point. This is known as a range. This is known as a range. What is the range formula? Range is nothing but velocity into time of light. Velocity into time of light. What is the answer? 2 into h minus h. Velocity into time. These two are multiplying, we get the range. This one is also the important point. Now, fourth point. Now listen carefully. Another important point. For maximum range, this the distance very large. For maximum range, how much height of the hole can be taken from the top layer? From the top layer, how much of the depth when orifice is taken, that height is nothing but h by 2. So when this range value is maximum, for maximum range, the hole can be taken how much depth? Like h by 2. That's why what is this maximum range? How much distance this water is falling? That maximum range is nothing but capital H. Exact hole this height, this is height h. For h by 2 height, when hole is taken, That's why the liquid is fallen how much distance, amma? This height is whatever may be this value, that height water is falling. So that is another important point. So for maximum range, the depth of the orifice is half of the height of the water. That's why what is the maximum range? The total height of the water level. That 2 points are the important one. Next, the time taken by the water to empty the tank from T1 to from H1 to H2 is time taken to empty the tank from height H1 to H2 is, from height H1 to height H2 is, that time is equal to A by A this is another important formula. The time taken by the water, the time taken by the water to empty the tank, the time taken by the water to empty the tank from height H1 to height H2 is, what is the formula? The time is equal to A by A tank area, small a, area of the orifice, root 2 by G into root H1 minus root H2. This is another important formula. Now in this concept, these 5 are the main important formulas. In that 5 important formulas, third point is the important. Sorry, fourth point is the important one. And fifth point is also. Fifth point is the given the previous APMT question. Fifth point. This one possibility is there important model. Now previous question. Now listen that previous question is, this is the water, totally is filled with water. Here one square hole side A at a depth y Here one circular hole radius r at a depth 4y. At a depth 4y. On both the areas liquid is ejected. But one of the point is given, volume rate of flow on both the holes are same. Volume rate of flow of both orifice are same. Then what is the radius? Then what is the radius of the hole? Right. In both the holes the liquid is ejected. Here also liquid ejected. In both the holes which one is same? Volume rate of flow. What is the meaning of volume rate of flow? Per second some volume of the liquid ejecting. Same volume of the liquid is ejecting from this circular hole. Both are same. That's why what is the radius? Right. What is the given? Volume rate of flow is the same. Volume rate of flow means area into velocity. And both are same. Right. What is this area? This is nothing but square hole side A square. How much depth is there? Y gada. At that's where what is the speed of the liquid ejecting? Like root 2 GH and root 2 GH and Y. Next for another one area pi r square. Circular hole. That's where what is the speed? 2GH value 4y. 4y. This value a square, pi r square, 4 value take them outside 2 Remaining value root 2gy. Root 2gy, root 2gy cancel, leave it. Then how to find the r square value? A square by 2 pi. Therefore r value a by root 2 pi. That radius r is equal to a by 2 pi. This is the previous question. So in both the holes, volume rate of flow of the liquid is the same. Volume rate of flow means area into velocity and area into velocity. A1 V1 is equal to A2 V2 are same. That's why what is the radius of this orifice? Orifice and hole. What is the radius of this hole? Volume rate of flow same ga A1 V1 is equal to A2 V2. Area, what is the area ma? Side square and like A square root 2gy. What is this area ma? Pi r square kada root 2g, h value 4y. 4 value take them outside 2 amma, root 2gy cancel. Pi r square into 2, this value a square, therefore r square means a square by 2 pi, r is equal to a by root 2 pi. Important model. Okay, Nama. Right. Now the next concept is nothing but surface tension. Surface tension. Some important points, Amma. First, we can explain some important points. What is the meaning of surface tension? The force per unit length of an imaginary line drawn on the free surface of the liquid is known as surface tension. Like this is the imaginary surface of water, Amma. One needle is placed, Amma. Needle. That needle is floating. That needle is floating means, Amma, the liquid surface can behave as a stretched elastic membrane. Like similar to that of our skin is there, Amma. We can pull them and release it. Come to original surface, come to original nature. Ga. Similarly, the liquid surface behavior also same one. Here, one needle is placed on the free surface, that surface tangentially some force is acting. On both sides, some force is acting tangentially perpendicular to its length. Now, the surface tension is defined as force per unit length. Force per unit length. This is the force acting tangential to the liquid surface per length of the wire. That force per length is nothing but surface tension. So, one of the important point. Now, listen. That's why what is the value of F, T into L? So, that F is equal to T into L. Now, another point here. Previous question is also there. Now, when a disc is placed on the water surface, disc is placed on the water surface, how much force is required to pull the body on the water surface against the surface tension? What is that point, Amma? Now again, when a disc is placed on the water surface, Amma, that water surface, when the disc is removed, Amma, and we can pull them upward, Amma, it is not easily pulling. Water can be pulled them in downward. And how much force is required to pull them against the surface tension? To moving upward. What is that force, Amma? T into L. T is the surface tension. Now listen carefully. How much length is in contact with the water surface, Amma, here? This is the disc. That disc, Amma, how much length is in contact, Amma? How much length is in contact? Only outer surface, Amma. On the outer surface, Amma, is the force is acting tangential. Force is acting tangential. How much length is in contact with water? 2 pi r. Like, what is the force required, Amma, to lift the body against the surface tension? T into L. L is nothing but 2 pi r. That is the previous neat question. Now another point, Amma. Like this is the water, Amma, like needle. This is the needle. Needle is placed on the free surface of water. How much force is required to lift the body against the surface tension? Now again, T into L. How much length is in contact with the water, Amma, this needle? Needle is placed on the free surface. This side water, this side water. And this side force is acting, this one and this one. This length L, this length L. How much length? 2L. So, what is the force required, Amma, to float the body on the free surface of the water means T into 2L. So, these 2 points are the important one. This one is the given on the previous year. Okay, now similarly, this is the ring. When a ring is placed on the free surface of water, what is the force required to lift the body against the surface tension? How much length amma is in contact with the water surface amma? Radius emo r. Outer part emo is in contact with the water. Inner surface is also contact with the water kada, and outer reason emo 2 pi r. Inner reason emo 2 pi r. That's where what is the force required amma? T into L. What is the L value? 2 pi r into 2. Why here multiple with 2 ra? Outer region length emo 2 pi r. Inner region also ra, water is in contact with ring kada. That's why ra inner and outer and like 2 pi r into 2. So that's why ra, that is the another important point amma. Next one, surface energy. Surface energy, the work done per increase of the area is known as surface energy or surface tension. Now listen, that work done is nothing but T into delta A. RT is equal to work done per increase of the area or change of the area. The work done per increase of the area is known as surface tension, is also known as surface energy. So therefore W is equal to T into delta A, tension into change in area. Work done is nothing but tension into change in area. Change in area means final minus initial. So that is another important formula. Now one example. Now initially an water, like a water drop amma. Initial radius is R1, is changes to radius R2. How much of the work is done? So initially water dropper having the radius R1 is changes to radius R2 amma. How much of the work is done when the liquid dropper whose radius is increased from R1 to R2? Now listen, what is the initial area? 4 pi R1 square. What is the final area? 4 pi R2 square. What is the increase of area? A2 minus A1. 4 pi R2 square minus R1 square. What is the work done formula? T into delta A. T is the surface tension of the liquid amma. That value is given amma. That is the constant value. Change in area 4 pi of R2 square minus R1 square. That's why that is the another important point amma. Same example amma. Soap bubble. Initially the soap bubble of radius R1 is increased to radius R2. What is the work done? But amma, this one amma water drop amma. That one amma soap bubble. In case of the soap bubble amma, what is the expression of the work done? Now that work done is equal to T into delta A 4 pi R2 square minus 4 pi R1 square ega. But amma, here one small correction. The soap bubble, that soap bubble having the inner surface and outer surface, there are the two surfaces are there. That's why here is a multiple with 2, here also multiple with 2. That's why amma T into 8 pi value common. So 8 pi value common amma. That's why R2 square minus R1 square. So film, soap bubble, soap film. Film is also is there amma, take them into two surfaces. Take them multiple 2 because of it having the two surfaces. Soap bubble, film. Film is also nothing but two surfaces. That point is the important one. Here also water drop. So these 2 points are the important one. Now next point, Amma. Now listen, Amma. Capillarity. Capillarity means the rise or fall of liquid in a the rise or fall of liquid in a tube. In a capillary tube. In a capillary tube is known as a capillarity. Capillary tube like hair thickness of the diameter is there, Amma. On the diameter liquid sometimes rise, sometimes fall. That phenomenon is known as capillarity by the surface tension. Now listen. For example, this is the water. Listen carefully, Amma. So this water can be taken in a vessel, Amma. Like the shape is like this one. This one mercury, Amma. Like this one. This one water. This one mercury. Now water and vessel both are in meet in this point. Both are in meet in this point. For a tangential line is drawn to the liquid surface. Tangent line is drawn to the liquid surface. That tangent line makes an angle theta with solid inside the liquid, not taken outside, inside. That angle is known as angle of contact. What is the meaning of angle of contact, Amma? The angle made by the tangent line drawn to the liquid surface. Tangent line drawn to the liquid surface. And solid means glass. Inside the liquid is known as angle of contact. Now here, Amma, a tangent line is drawn to the liquid surface. Makes an angle with solid. Solid means this one solid. But inside the liquid and like this one. Inside the liquid means that one. That angle is known as angle of contact. But here, Amma, theta value, Amma, is less than 90. Here, Amma, theta value, Amma, greater than 90. But, Amma, where exactly this is the mercury, for mercury, theta value 135. But this is the pure water, Amma. In case of the pure water, theta value like 0. Theta value like 0. So when theta value greater than 90 is nothing but, Amma, the water, the liquid, Amma, is not in contact with the surface. These two are they are not in contact. Like not in contact means the wetness. The wetness value there. When this one and this one is not wet the glass. The mercury, Amma, is not wet the glass. But, Amma, water can be taken in a glass. What happened? The water complete wetness of the glass kada. So here, Amma, water wet the glass. But here, Amma, mercury not wet the glass. Mercury not wet the glass. Another important point, Amma. So not wet the glass, that's where theta value greater than 90, Amma, is not wet. That's where that type of the materials are used for the raincoats. In case of the raincoats, Amma, when water can be incident on the raincoats, what happens? Easily sliding, because of theta value is nothing but greater than 90. When a theta value greater than 90, Amma, this liquid, Amma, is not in contact with glass. That is another important point to previous question. Next one. The shape is nothing but concave meniscus. Shape is nothing but concave meniscus. Here, Amma, shape is nothing but convex meniscus. That shape is nothing but concave meniscus, Amma. This one, Amma, convex meniscus. Like these points are the very, very important one, Amma. Now, this is the water. When a capillary tube is dipped in water, that's why liquid can be rises to a height h. Liquid can be rise h. R is nothing but radius. Rho is the density. That's why what is the surface tension? H R d z by 2 cos theta. Density value like d. What is the value of h, Amma? Sorry, what is the value of surface tension? H R d g by 2 cos theta. Very, very important formula. So, how much height, Amma? H. R is the radius. D is the density. G is the gravity. Theta is the angle of contact. What is the surface tension? HRdz by 2 cos theta. This is the another important formulas. These all are the important formulas in surface tension. Now we can explain some important previous models. Now listen. Now question number 2024 one question is the given. A thin flat circular disc of radius 4.5 centimeter, radius value 4.5 centimeter, is placed on the surface of water like surface tension value 0.07 Newton per meter. That's why what is the force required to take away from the surface? That disc is placed on the water surface. How much of the force is required from the water surface? Already we know that force is equal to T into L. T 0.07. How much length is in contact with the water surface? 2 pi r. 2 pi r. That is the disc 2 pi r. In case of the ring, 2 pi r into 2, inner surface or outer surface. Like this value 7 into 10 power minus 2, pi value 22 by 7, radius value 4.5 centimeter. 7 cancel. 2 4.5 9. Here 22. 22 9s are 198. So what is the remaining value? 10 power minus 2, 10 power minus 2, 10 power minus 4. Like 0.0198 newtons. So 0.0198 newtons. That is the question in 2024. Simple question is asking. This is the clearly given. This is nothing but a disc. Disc only taken as a length is 2 pi r. For ring 2 pi r into 2. Right. Now another question. 2023 question. The amount of the energy required to soap bubble of radius 2 centimeter. Soap bubble clearly given soap bubble of radius 2 centimeter. 2 centimeter of the soap solution is nearly. In soap solution suddenly to form the 2 centimeter of the soap bubble what is the work done is required. Right. What is the work done T into delta A. A2 minus A1. Initial soap solution there is no bubble, and initial area there is no area of the bubble. Suddenly to form the final area A. What is the area of the soap bubble 4 pi r square for spherical shape ki. But soap bubble having the two surfaces into 2. Right. In a question 0.03 surface tension value is given This value in bracket 0.03 is given. So that's why 8 pi value 3.14 r square 4 into 10 power minus 2 means 10 power minus 4. So that's value simplify them. This value 3 into 10 power minus 2. 3 into 10 power minus 2 here minus 4 minus 6 and only 3. 3 into 8 24. Next this value 3.14 into 4 approximately 12. So how much value 12 4s are 48. 12 2s are 24 plus 4 28. This is the work done like joules. 288 into 10 power minus 6 joules. So now again, initial soap solution when suddenly soap solution any disturbance is there, suddenly we get the one soap bubble That radius value 2 centimeter amma. What is the work done? That work done is nothing but T into A2 minus A1. Initially there is no soap bubble, 0. Suddenly you can form the another soap bubble radius 4 pi r square. Having the two surfaces kada into 2. So T into 8 pi r square. So slowly we take the calculation number 288 into 10 power minus 6. Now next question. question. 2022 question. A soap bubble is expand. What is the pressure inside the bubble? Soap bubble is expand. What is the pressure inside the soap bubble? Now listen carefully. This is the soap bubble, amma. That soap bubble is expand. Expand means amma that radius 1 no, this one name radius R2. Expand means radius value increase ga. What is the excess pressure? Now inside now listen amma one small point. The inside pressure P, outside atmospheric pressure. So this is the soap bubble. So the excess pressure inside soap bubble is P minus P naught. The excess pressure inside the soap bubble is P minus P naught. That excess pressure is nothing but 40 by R. This is for soap bubble amma. For liquid drop amma, like P minus P naught, like 2T by R. So, but here amma radius value increase ga. Radius value increase means what about the excess pressure value decreases kada. Now answer is decreases. So if soap bubble is expand, radius value increases, the pressure inside the soap bubble is decreases. Radius value is increases, excess pressure inside the soap bubble is decreases. That is the another important point. Now another question. In a 2019 question, a soap bubble having the radius of 1 centimeter is blown from the detergent solution of the surface tension. Soap bubble, again soap bubble of a radius value 1 millimeter, whose surface tension is 2.5 into 10 power minus 2 Newton per meter is the clearly given amma. This pressure, the soap bubble, this is the soap bubble gara having the radius surface tension value is given. The pressure inside the soap bubble, the pressure inside the soap bubble, what happens amma? That value is equal to Z0 below the free surface of the water in the container. Now listen. This is the soap bubble radius R. P, this one P naught. This is the liquid surface amma. Z0 height here some pressure is there. But is asking what is that amma? The pressure inside the soap bubble, like this P value, the pressure at a certain depth amma, Z0 depth some pressure is there gara, that value both are equal. That's why what is the value of Z0? Already we know that in Z0 depth what is the pressure amma? Here P naught. Here H rho g and Z0 rho g nega. But amma this one excess pressure P minus P naught is equal to 40 by R. What is the total pressure inside the soap film? P is equal to minus P naught, take them, plus P naught, 40 by R. P naught value cancel. Z0 is equal to 40 by R rho g. or rho g. Z naught is equal to 4 into 25 into 10 power minus 4 by r, radius value 1 millimeter, rho 1000, g value 10. R, radius 1 millimeter, rho is nothing but density of water 1000 into g. These two are cancelled. 2.4 into 4, 10. That 10 cancel, like 10 power minus 2 meter or 1 centimeter. So the answer is 10 power minus 2 meter or 1 centimeter. So that is the 2019 question. The total pressure inside the soap bubble is equal to the top at Z naught height error at Z naught depth of the total pressure. Z naught depth what is the pressure P naught plus H rho g nega. The excess pressure means the P minus P naught What is the total pressure inside the soap bubble P. Inside the soap bubble is P. What is the value of P minus P naught, take them on right side P naught plus 40 by R. These are equal is given. P naught cancel, therefore Z naught value. Now another point that is the 2020 question. 2020 question The liquid does not wet the liquid surface. What is the angle of contact? Now listen. The liquid does not wet the solid surface. That's why what is the angle of the contact 0, greater than 90, less than 90 and none of the above. Already we know that the liquid is not wet the glass like mercury and glass. For mercury and glass angle of the contact value theta value greater than 90 exact value 135 So compulsory the liquid is not wet the glass means theta value greater than 90. So answer just greater than 90. Problem is over. Okay, that is the previous question 2020. Now 2019. question A small hole of area 2 millimeter square 2 millimeters square area 2 millimeter square is present near the bottom of the fully open tank. Height it is 2 meters. 2 meters height. So G value can be taken as 10. The rate of volume of the water through the hole is, one small hole is at the bottom. What is the volume rate of flow of the liquid flowing through the tube? What is the meaning of volume rate of flow? Volume rate of flow is nothing but area into velocity nega. What is the area value given 2 millimeter means 10 power minus 3 whole square 10 power minus 6. But already we know that 2 meters height liquid is ejecting with a speed is root 2gh. Root 2gh. So 2gh value 2. So 2 into 10 power minus 6 into 40. Root 40. Root 40 means approximately 6 above. 6 square means 36 kada, but 40 approximately 6 above, nearer to 6. How much value 12 into 10 power minus 6 volume rate of flow meter cube by second. The answer value 12 into 10 power minus 6 meter cube per second. So exact 12.6 in given option 12.6 into 10 power minus 6 meter cube per second. So this is the 2019 question. Now another question. In 2016 question, 2016, a rectangular film, clearly given rectangular film. A rectangular film is extended from 4 centimeter into 2 centimeter to 5 centimeter into 4 centimeter. Then the work done is 3 into 10 power minus 4 joules. 3 into 10 power minus 4 joules. What is the surface tension? What is the surface tension? But is the clearly given rectangular film, soap bubble or film having the two surfaces. What is the initial area? 4 into 2, 8 into 10 power minus 2 into minus 2, 10 power minus 4. This only area. Film having the two surfaces like into 2 meter square. So that's why 16 into 10 power minus 4. What is the final area? 5 into 4, 20, 10 power minus 4. Only that is the area. But film having the two surfaces into 2. Like 40 into 10 power minus 4 meter square. What is the change in area? Delta A, A2 minus A1. 40 minus 16. 40 minus 16 how much? 24 into 10 power minus 4 meter square. So what is the work done formula? T into delta A. Therefore, T is equal to work done per increase of area. What is the work done value? 3 into 10 power minus 4 by 3 into 10 power minus 4 by change of area 24. So 10 power minus 4 cancel. So 1 by 8. So 1 by 8. So 1 by 8 means 0.125. So 0.125 Newton per meter. Newton per meter. This is the 2016 question. But here clearly given rectangular film. Rectangular film and soap bubble having the two surfaces. Liquid drop, air bubble having the only one surface. Next last model. 3 liquids of densities. 3 liquids of densities. Rho 1, rho 2 and rho 3. 3 liquids of densities. But is rho 1 greater than rho 2 greater than rho 3. Again this is the 2016 question. Having the same value of the surface tension. Having the same value of the surface tension. T value is the same. And to the same height in 3 identical capillarity tubes. Same radius and same radius. And theta 1 and theta 2 and theta 3 are the angle of contacts. Angle of contacts. That's why what is the relation between them? What is the relation between the angle of the contact? Now listen, already we know that this is the liquid. When a capillary tube is dipped inside the liquid, liquid is rises to a height is h. What is the relation between the T and angle of contact? HR dz by 2 cos theta. But the density value name here rho. HR rho g by 2 cos theta. Radius value same. Radius value same. And same surface tension value same. 2 value constant, g value constant, and also height is also given the same. What is the relation between rho and cos theta? Rho directly proportional to cos theta. Now listen carefully. But rho 1 greater than rho 2 greater than rho 3. But proportionality cos theta 1 cos theta 2 cos theta 3. Directly proportionality this value is highest means this value is also highest cos theta value. But in option is the given in terms of theta 1 theta 2 theta 3. Cos theta value is more amma, then theta value is less, and reverse. For angle of contact amma, least value amma 0, least value 0. For angle of contact amma, greater than 90 is also there, greater than 90 is also there. That's why amma, the relation between theta 1, theta 2, theta 3 is 0, less than theta 1, less than theta 2, less than theta 3, less than pi by 2. So this is the option amma. So that is the 2016 question amma. Okay amma. Right amma. So today concept amma, surface tension amma, compulsory ra one question is possibility is there amma. Only the formula based is the given amma. Just you can revise the formulas and practice the previous models is enough. Okay amma. Our next class.
Hello all. Today the chapter for the discussion is D and F block elements. I had just sent the document that is required for the discussion today. I think it was sent a minute ago. I'm sorry for the delay because I was expecting that in the morning, but due to reasons, certain reasons, and me being busy, I could not send it in the at the earliest time possible. So what we are trying to understand now is the questions that I had sent you. We'll discuss one after the other. The first thing that I'm trying to tell you is, which of the following property is not explained by the reason mentioned? This is the 46th question. This is completely D and F block mele tayari madida on the question paper. Adaralli almost ella cover madidini nanu. Adaragoskara adanne discuss madidare almost ella concepts cover aagtave anta adanna kalisidine. Which of the following property is not explained by the reason mentioned? D and F block ge bahala properties adave D block elements ge adaralli kelavu properties anna kottidare. Adaralli yava property ge correct reason kottilla annodu question illi. So first property bandbittu variability in oxidation states. Variability in oxidation states andre enu? Oxidation states bahala exhibit madodu. Ivu eshtu oxidation states anna edakke exhibit ಮಾಡ್ತಿದಾವೆ? ಅದಕ್ಕೆ ರೀಸನ್ ಏನಂತಂದ್ರೆ D ಬ್ಲಾಕ್ ನಲ್ಲಿ incomplete filling ಇರೋದು. ಇದರಲ್ಲಿ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್, ಅದರಲ್ಲಿರುವಂತಹ 1 2 3 4 5 6 7 8 9 10 Zn ನಲ್ಲಿ 10 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಫಿಲ್ ಆಗ್ತವೆ. ಆದರೆ ಅದಕ್ಕೆ ಜಿಂಕ್ ನಲ್ಲಿ ನಮಗೆ ಎಲ್ಲ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸ್ ಬರಲ್ಲ. ಇನ್ಕಂಪ್ಲೀಟ್ ಫಿಲ್ಲಿಂಗ್ ಎಲ್ಲಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಅಲ್ಲಿ ಮೋರ್ ನಮಗೆ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸ್ ಕಾಣ್ತವೆ. ಸೊ ಇನ್ಕಂಪ್ಲೀಟ್ ಫಿಲ್ಲಿಂಗ್ ಅನ್ನೋದು ಅಪ್ರಾಪ್ರಿಯೇಟ್ ರೀಸನ್. ದೇರ್ ಫೋರ್ ಮ್ಯಾಂಗನೀಸ್ ನೀವು ನೋಡಿ ಹಾಫ್ ಫಿಲ್ಡ್ ಇದೆ ಅಂದರೆ ಅದು ಇನ್ಕಂಪ್ಲೀಟ್ ಫಿಲ್ಲಿಂಗ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. ಅದರಲ್ಲಿ ನಮಗೆ ಈ 5 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಪ್ಲಸ್ ಈ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಸೇರಿ 7 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ನಂಬರ್ ಆಫ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸ್ ಮ್ಯಾಂಗನೀಸ್ನಲ್ಲಿ ಬರಲಿಕ್ಕೆ ಕಾರಣ ಈ ಪೈರಪ್ ಆಗಲಾರ್ದ ಇನ್ಕಂಪ್ಲೀಟ್ ಫಿಲ್ಲಿಂಗ್ ಇರೋದು. ದೇರ್ ಫೋರ್ ದಟ್ ಈಸ್ ಅನ್ ಅಬ್ಸಲ್ಯೂಟ್ ರೀಸನ್ ಗಿವನ್ ಟುವರ್ಡ್ಸ್ ದ್ಯಾಟ್. ಲೆಟ್ಸ್ ಮೂವ್ ಟು ದ ಸೆಕೆಂಡ್ ಕ್ವೆಶ್ಚನ್, ಸೆಕೆಂಡ್ ಆಪ್ಷನ್, ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ನೇಚರ್. ಈ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ನೇಚರನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಇದಕ್ಕೆ ಆರ್ಬಿಟಾಲ್ ಆಂಗ್ಯುಲರ್ ಮೊಮೆಂಟಮ್ ಈಸ್ ಕ್ವೆಂಚ್ಡ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ನೇಚರ್ ಬರೋದು ಎದಕ್ಕೆ ಬರ್ತಾ ಇದೆ? ಡಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ನಲ್ಲಿ ಡ್ಯೂ ಟು ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದು ಆ್ಯಕ್ಚುಲ್ ರೀಸನ್. ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಷ್ಟು ಜಾಸ್ತಿ ಇದ್ದರೆ ಅಷ್ಟು ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ನೇಚರ್ ಬರ್ತಾ ಇರುತ್ತೆ. ಇದು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಆದರೆ ಇಲ್ಲಿ ಆರ್ಬಿಟಾಲ್ ಆಂಗ್ಯುಲರ್ ಮೊಮೆಂಟಮ್ ಕ್ವೆಂಚ್ ಆಗೋದು ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ನಾವು 3D ಟ್ರಾನ್ಸಿಷನ್ ಸೀರೀಸ್ ಎಲಿಮೆಂಟ್ಸಿನ ಕಂಪೌಂಡ್ಸ್ ನೋಡಿದರೆ ಈ ಎಲಿಮೆಂಟ್ಸ್ನಲ್ಲಿ ಆರ್ಬಿಟಾಲ್ ಆಂಗ್ಯುಲರ್ ಮೊಮೆಂಟಮ್ ಏನಿದೆ ಅದು ಖಂಡಿತ ಕ್ವೆಂಚ್ ಆಗತ್ತೆ. ಕ್ವೆಂಚ್ ಆಗೋದು ಅಂದರೆ ಎಫೆಕ್ಟ್ ಆಗುತ್ತೆ. ಆ್ಯಂಡ್ ಆ್ಯಸ್ ಅ ರಿಸಲ್ಟ್ ಅದು ಕಮ್ಮಿ ಆಗುತ್ತೆ. ಈಗ ನಮಗೆ ಆಂಗ್ಯುಲರ್ ಮೊಮೆಂಟಮ್ ಅನ್ನೋದು 2 ಟೈಪ್ಸ್ ಆಫ್ ಮೋಷನ್ನಿಂದ ಬರ್ತಾ ಇದೆ. ಒಂದು ಸ್ಪಿನ್ ಟೈಪ್ ಆಫ್ ಮೋಷನ್, ಎರಡನೇದು ಆರ್ಬಿಟಾಲ್ ಮೋಷನ್. ಎರಡರಲ್ಲಿ 2 ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ಸ್ ಬರ್ತವೆ. ಒಂದು ಸ್ಪಿನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್, ಎರಡನೇದು ಆರ್ಬಿಟಾಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್. ಇದರಲ್ಲಿ ಆರ್ಬಿಟಾಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ ಏನಿದೆ ಅದು ಲಿಗ್ಯಾಂಡ್ಸ್ ಇರೋದ್ರಿಂದ ಈ ಕಂಪೌಂಡ್ಸ್ನಲ್ಲಿ 3D ಟ್ರಾನ್ಸಿಷನ್ ಸೀರೀಸ್ ಕಂಪೌಂಡ್ಸ್ನಲ್ಲಿ ಲಿಗ್ಯಾಂಡ್ಸ್ನ ಎಫೆಕ್ಟ್ರಿಂದ ಈ ಆರ್ಬಿಟಾಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ ಏನಿರುತ್ತೆ ಅದು ಕ್ವೆಂಚ್ ಆಗುತ್ತೆ. ಅದು ಕ್ವೆಂಚ್ ಆಗಿರೋದ್ರಿಂದ ನಾವು ಅದನ್ನು ತಗೊಳ್ಳುವ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಕೇವಲ ಸ್ಪಿನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟನ್ನು ಮಾತ್ರ ತಗೊಳ್ತೀವಿ. ಹಾಗಾಗಿ ಅದು ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ ಕಮ್ಮಿ ಆಗುತ್ತೆ ಅನ್ನೋದು ಒಂದು ವಿಷಯ. ಆದರೆ ಕರೆಕ್ಟ್ ರೀಸನ್ ಫಾರ್ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಆಫ್ ದೀಸ್ ಎಲಿಮೆಂಟ್ಸ್ ಈಸ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಷ್ಟೇ ಬಿಟ್ಟು ಬೇರೆ ಯಾವುದೂ ಅಲ್ಲ ಅನ್ನೋದು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ಸೆಕೆಂಡ್ ಆಪ್ಷನ್ ಈಸ್ ಅ ರಾಂಗ್ ಥಿಂಗ್. ಹೈ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಆಟಮೈಸೇಷನ್. ಎಂಥಾಲ್ಪಿ ಆಫ್ ಆಟಮೈಸೇಷನ್ ಎದಕ್ಕಷ್ಟು ಜಾಸ್ತಿ ಇದೆ ಅಂತಂದರೆ ಇದರಲ್ಲಿ ಕೇವಲ NS ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಷ್ಟೇ ಅಲ್ಲ, N-1 ಡಿರಿಂದ ಕೂಡ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನೋ ಫಿಲ್ಲಪ್ ಆಗ್ತವೆ. ಆ ಕಾರಣಕ್ಕೆ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಆಟಮೈಸೇಷನ್ ಆಫ್ ಡಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಈಸ್ ಹೈಯರ್ ಅನ್ನುವ ವಿಷಯವನ್ನು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ನೆಕ್ಸ್ಟ್ ಒನ್, E0 ನಿಕಲ್ ಪ್ಲಸ್ 2 ನಿಕಲ್ ಬೀಯಿಂಗ್ ಲೋ. E0 ವ್ಯಾಲ್ಯೂ ಆಫ್ ನಿಕಲ್ ಪ್ಲಸ್ 2 ನಿಕಲ್ ಈಸ್ ಲೋ. ಎಸ್, ಇದು ಖಂಡಿತ ಕರೆಕ್ಟೇ, ಲೋ ವ್ಯಾಲ್ಯೂನೇ ಇದೆ. ಇದಕ್ಕೆ ಕಾರಣ ವಾಟ್ ವಿ ನೀಡ್ ಟು ಸೇ ಇಸ್ ಹೈ ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ hydration enthalpy of E0 when compared to the rest of the enthalpies. E0 ಗೆ ಏನೇನು enthalpies ಕಾರಣ ಆಗಿರ್ತವೆ? enthalpy of atomization plus enthalpy of ionization 1 plus enthalpy of second ionization plus hydration enthalpy. ಈ 4 ಎಂಥಾಲ್ಪೀಸ್ ಕೂಡ E0 m+2m ಗೆ ಕಾರಣ ಆಗ್ತವೆ. ಅದರಲ್ಲಿ ಇದೆಲ್ಲ ಕೂಡ ಇವುಗಳ ಸಮ್ ಪಾಸಿಟಿವ್, ಇದು ಒಂದು ನೆಗೆಟಿವ್. ಅದು ಓವರಾಲ್ ಆಗಿ ಲೋ ಇದೆ ಅಂತಂದರೆ ಅದು ಕೇವಲ ಹೈಡ್ರೇಷನ್ ಎಂಥಾಲ್ಪಿ ಕಮ್ಮಿ ಇನ್ ಕೇಸ್ ಆಫ್ ನಿಕೆಲ್. ಅದೇ ಕಾಪರ್ ಕೇಸ್ನಲ್ಲಿ ಹೈ ಅದಕ್ಕಿದೆ ಅಂತಂದರೆ ಡ್ಯೂ ಟು ದ ಸಮ್ ಆಫ್ ದೀಸ್ 3 ವ್ಯಾಲ್ಯೂಸ್ ಬೀಯಿಂಗ್ ಹೈಯರ್ ಕಂಪೇರ್ಡ್ ಟು ದಿ ಹೈಡ್ರೇಷನ್ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಕಾಪರ್ ಅಂತ ಹೇಳಿ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಲೆಟ್ಸ್ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಒನ್. ಇದು 46 ಸೆಕೆಂಡ್ ಆಪ್ಷನ್ ಇಸ್ ಕರೆಕ್ಟ್. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಕಾಪರ್ ಪ್ಲಸ್ 2 ಈಸ್ ಮೋರ್ ಸ್ಟೇಬಲ್ ದ್ಯಾನ್ ಕಾಪರ್ ಪ್ಲಸ್ 1. ರೀಸನ್ Cu2F2 is unstable. Copper plus 2 aqueous. When we consider copper plus 2 aqueous, ಇದು ಖಂಡಿತ more stable compared to copper plus 1. Copper plus 2 aqueous state nalli more stable compared to copper plus 1 aqueous because copper plus 2 is a smaller ion. ಈ ಸ್ಮಾಲರ್ ಅಯಾನ್ ಇರುವುದರಿಂದ ಇದರ ಸುತ್ತ ನಂಬರ್ ಆಫ್ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಸೇರಿ ಹೈಡ್ರೇಷನ್ ಎಂಥಾಲ್ಪಿ ಅನ್ನೋದು ತುಂಬ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಫಾರ್ ಕಾಪರ್ ಪ್ಲಸ್ 2. ಅದೇ ನಾನು ಕಾಪರ್ ಪ್ಲಸ್ ಒನ್ನನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದಾಗ ಇದು ಲಾರ್ಜರ್ ಅಯಾನ್ ಇರುವುದರಿಂದ ನಂಬರ್ ಆಫ್ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ವಿಚ್ ಅಕ್ಯುಮುಲೇಟ್ ಅರೌಂಡ್ ದಿಸ್ ಈಸ್ ವೆರಿ ಲೆಸ್. ಅಷ್ಟೇ ಅಲ್ಲದೆ ಇಲ್ಲಿ ಚಾರ್ಜ್ ಕೂಡ ಜಾಸ್ತಿ ಇದೆ. ಸೊ ಅಟ್ರಾಕ್ಷನ್ ಟುವರ್ಡ್ಸ್ ಮೆನಿ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಇಸ್ ಪಾಸಿಬಲ್. ಇಲ್ಲಿ ಚಾರ್ಜ್ ಸ್ವಲ್ಪ ಕಮ್ಮಿ ಇದೆ, ನಂಬರ್ ಆಫ್ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಕಮ್ಮಿ ಇರ್ತವೆ. ಅದಕ್ಕೆ ಇಲ್ಲಿ ಹೈಡ್ರೇಷನ್ ಎಂಥಾಲ್ಪಿ ಏನಿದೆ ಇದು ಮೋರ್ ನೆಗೆಟಿವ್ ಕಂಪೇರ್ಡ್ ಟು ಹೈಡ್ರೇಷನ್ ಎಂಥಾಲ್ಪಿ ಆಫ್ ದಿಸ್. ಹಾಗಾಗಿ ಈ ಕಾಪರ್ ಪ್ಲಸ್ 1 ಅನ್ಸ್ಟೇಬಲ್ ಇರೋದರಿಂದ ಇದು ಡಿಸ್ಪ್ರಪೋರ್ಷನೇಷನ್ ಆಗ್ತಾ ಇದೆ ಇಂಟು ಕಾಪರ್ ಆ್ಯಂಡ್ ಕಾಪರ್ ಪ್ಲಸ್ 2 ಇನ್ ದಿ ಏಕ್ವಿಯಸ್ ಸ್ಟೇಟ್. ಈ ತರಹ ಇದು ಡಿಸ್ಪ್ರಪೋರ್ಷನೇಷನ್ ಆಗ್ತಾ ಇರೋದ್ರಿಂದ ಇದು ಅನ್ಸ್ಟೇಬಲ್ ಮತ್ತಿದು ಸ್ಟೇಬಲ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ವಿ. ಸೊ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಆನ್ಸರ್ ಪ್ರಕಾರ ನಾವು ಕರೆಕ್ಟಾಗಿ ಹೇಳಬೇಕಂತಂದರೆ ಅಸರ್ಷನ್ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, ಕಾಪರ್ ಪ್ಲಸ್ 2 ಏಕ್ವಿಯಸ್ ಇಸ್ ಮೋರ್ ಸ್ಟೇಬಲ್ ದ್ಯಾನ್ ಕಾಪರ್ ಪ್ಲಸ್ 1 ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ಇದು ಕರೆಕ್ಟ್. ಆದರೆ ಅದಕ್ಕೆ ಕಾರಣ ಕಾಪರ್ ಪ್ಲಸ್ 1 ಅಂಡರ್ಗೋಸ್ ಡಿಸ್ಪ್ರಪೋರ್ಷನೇಷನ್ ಇನ್ ವಾಟರ್ ಬಟ್ ನಾಟ್ ಕಾಪರ್ ಪ್ಲಸ್ 2. ಅದಕ್ಕೇನು ಕಾರಣ ಅಂತ ಅಂದರೆ ಕಾಪರ್ ಪ್ಲಸ್ 2 ಹ್ಯಾಸ್ ಮೋರ್ ನೆಗೆಟಿವ್ ಹೈಡ್ರೇಷನ್ ಎಂಥಾಲ್ಪಿ ಕಂಪೇರ್ಡ್ ಟು ದಟ್ ಆಫ್ negative hydration enthalpy of copper plus 1 due to the smaller size and higher charge of copper plus 2 when compared to copper plus 1. This is all we need to understand here. Let's move to the next important part. ಇನ್ನೊಂದು ಸ್ಟೇಟ್ಮೆಂಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಅದರಲ್ಲಿ Cu2F2 is unstable. Cu2F2 is unstable ಅನ್ನೋದು 100% ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಯಾಕಂದರೆ ಫ್ಲೋರಿನ್ ಕ್ಯಾನ್ ಸ್ಟೆಬಿಲೈಸ್ ಹೈಯರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಬಟ್ ಇಟ್ ಡಿಸ್ಟೆಬಿಲೈಸಸ್ ಲೋವರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಬೈ ಆಕ್ಸಿಡೈಸಿಂಗ್ ದೆಮ್. Therefore, what we need to understand is Cu2F2 is highly unstable and it does not even exist in fact. This is what we need to understand. Therefore, assertion is true, reason is true, and reason does not explain assertion. Let's move to the next question, 48. ಈ ಕ್ವೆಶ್ಚನ್ ಅಲ್ಲಿ ಕೆಲವು ಸೆಟ್ ಆಫ್ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಆ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಅನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಫಸ್ಟ್ ಒನ್, ಲೋ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸ್ ಆರ್ ಫೌಂಡ್ when a complex compound has ligands of pi acceptor character. ಇದು ಖಂಡಿತ ಇದು ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಇದು ಏನಾಗಿದೆ, ಇದರಲ್ಲಿ ಲೋ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸ್ ಆರ್ ಫೌಂಡ್ ವೆನ್ ಅ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಂಪೌಂಡ್ ಹ್ಯಾಸ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ಆಫ್ ಪೈ ಆಕ್ಸೆಪ್ಟಾರ್ ಕ್ಯಾರೆಕ್ಟರ್. ಎದರಲ್ಲಿ? ಮೆಟಲ್ಸ್ಗೆ. ನಮಗೆ ಎಲ್ಲರಿಗೂ ಗೊತ್ತಿರೋ ವಿಷಯ ಏನಂದರೆ ಡಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್, ಎಸ್ಪೆಷಲಿ 3D ಟ್ರಾನ್ಸಿಷನ್ ಸೀರೀಸ್, ದೇ ಎಕ್ಸಿಬಿಟ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸ್ ರೇಂಜಿಂಗ್ ಫ್ರಮ್ +2 to +7. ಆದರೆ ಲೋವರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸ್ ಆದ 0 ತರಹ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸನ್ನು ಇವು ಎಕ್ಸಿಬಿಟ್ ಮಾಡಬೇಕು ಅಂತ ಅಂದರೆ ಅವು ಖಂಡಿತ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಂಪೌಂಡ್ಸ್ನಲ್ಲಿ ಮಾತ್ರ ಸಾಧ್ಯ, ವೇರ್ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್ ಲೈಕ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ಗೆಟ್ ಅಟ್ಯಾಚ್ ಟು ದ ಮೆಟಲ್. ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್ ತರಹ ಲಿಗ್ಯಾಂಡ್ಸ್ ಅನ್ನೋ ಇದ್ದರೆ ಇವು ಎಲೆಕ್ಟ್ರಾನ್ಸನ್ನು ಕೊಡೋದಷ್ಟೇ ಅಲ್ಲ, ಪೈ ಬಾಂಡ್ ಫಾರ್ಮ್ನಲ್ಲಿ ತಗೊಳ್ತಾವು ಕೂಡ. ಸೊ ಇಲ್ಲಿ ಸಿಗ್ಮಾ ಬಾಂಡ್ ಬರುತ್ತೆ, ಪೈ ಬಾಂಡ್ ಕೂಡ ಬರುತ್ತೆ. ಟುಗೆದರ್ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಸಿನರ್ಜಿಕ್ ಬಾಂಡ್. ಈ ಸಿನರ್ಜಿಕ್ ಬಾಂಡ್ ಕ್ಯಾರೆಕ್ಟರ್ ಇರುವುದರಿಂದ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್ ತರಹ ಪೈ ಆಕ್ಸೆಪ್ಟಾರ್ ಅಂದರೆ ಪೈ ಎಲೆಕ್ಟ್ರಾನ್ಸನ್ನು ಎಕ್ಸೆಪ್ಟ್ ಮಾಡೋದು ದ್ವಾರ ಈ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್ ಲಿಗ್ಯಾಂಡ್ ಅಂದರೆ ಏನು ಮಾಡಬೇಕು, ಡೊನೇಟ್ ಮಾಡಬೇಕು, ಬಟ್ ಇವಾಗ ಅದು ಎಕ್ಸೆಪ್ಟ್ ಕೂಡ ಮಾಡ್ತಾ ಇದೆ. ಆ ತರಹ ಪೈ ಅಕ್ಸೆಪ್ಟಾರ್ ಕ್ಯಾರೆಕ್ಟರ್ ಯಾರಿಗಿರುತ್ತೋ ಅವರದೊಂದಿಗೆ ಮಾತ್ರ ಇವು ಖಂಡಿತ ಈ ತರಹದ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸ್, ಲೋ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸ್ ಲೈಕ್ 0 ದೇ ಕ್ಯಾನ್ ಎಕ್ಸಿಬಿಟ್. ಅದಕ್ಕೆ ಎಕ್ಸಾಂಪಲ್ಸೇ ನಿಕೆಲ್ ಟೆಟ್ರಾ ಕಾರ್ಬನಿಲ್, ಐರನ್ pentacarbonyl kind of compounds. Let's move to the next statement. Statement A is correct. Statement B verify ಮಾಡ್ತಾ ಇದ್ದೀನಿ ನಾನು. The high energy to transform copper solid to copper 2 in aqueous states is not balanced by its hydration enthalpy. ಈ ಕಾಪರ್ಗೆ ಸಂಬಂಧಪಟ್ಟಂಥದ್ದು ವಿಷಯದಲ್ಲಿ E0 copper plus 2 E naught copper plus 2 copper is very high, and not only that, it is positive, where the rest of the elements are having that value negative. ಎದಕ್ಕೆ ಇದಕ್ಕೆ ಮಾತ್ರ ಹೈ ಪಾಸಿಟಿವ್ ಇದೆ ಅನ್ನೋದು ಇಲ್ಲಿ ಕ್ವೆಶ್ಚನ್. ಇದಕ್ಕೆ ಪಾಸಿಟಿವ್ ಇರಲಿಕ್ಕೆ ಕಾರಣ ಏನು ಅಂತಂದರೆ, ಮುಂಚೆನೇ ಹೇಳಿದ್ದೀನಿ ನಾನು, ನಮಗೆ ಇ ನಾಟ್ ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನೋವು ಕಾಪರ್ ಸಾಲಿಡ್ ಕಾಪರ್ ಗ್ಯಾಸ್ ಆಗೋದು, ಅಂದರೆ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಆಟಮೈಸೇಷನ್ ಅಥವಾ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಸಬ್ಲಿಮೇಷನ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನನ್ನು ಡೊನೇಟ್ ಮಾಡಿದ್ದಾಗ ಅಂದರೆ ಲಾಸ್ ಆಗಿದ್ದಾಗ ಫಸ್ಟ್ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನನ್ನು ತೆಗೆದಿದ್ದಾಗ ಸೆಕೆಂಡ್ ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಮತ್ತು ವಾಟರ್ನಲ್ಲಿ ಕರಗಿಸಿದಾಗ ಕಾಪರ್ ಪ್ಲಸ್ 2 ಏಕ್ವಿಯಸ್ ಸ್ಟೇಟ್ನಲ್ಲಿ ಬರುತ್ತೆ. ಇದರಲ್ಲಿ ಹೈಡ್ರೇಷನ್ ಎಂಥಾಲ್ಪಿ ಇನ್ವಾಲ್ವ್ ಆಗುತ್ತೆ. ಆದರೆ ಕಾಪರಿನ ಹೈಡ್ರೇಷನ್ ಎಂಥಾಲ್ಪಿ ತುಂಬ ಚಿಕ್ಕದು, ನೆಗೆಟಿವ್, ವೆನ್ ಕಂಪೇರ್ಡ್ ಟು ಆಲ್ ಆಫ್ ದೀಸ್ 3 ಎಂಥಾಲ್ಪೀಸ್. ಈ 3 ಎಂಥಾಲ್ಪೀಸನ್ನು ಸಮ್ಮಕ್ಕೆ ಕಂಪೇರ್ ಮಾಡಿದರೆ ಇದು ಕಮ್ಮಿ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ಓವರ್ ಆಲ್ ವ್ಯಾಲ್ಯೂ ಹೈಲಿ ಪಾಸಿಟಿವ್ ಇದೆ ಅಂತ ಹೇಳಬೇಕಾಗತ್ತೆ. ಸೊ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದ ಸ್ಟೇಟ್ಮೆಂಟ್, ದ ಹೈ ಎನರ್ಜಿ ಟು ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ copper solid to copper 2 in aqueous state is not balanced by hydration enthalpy. ಅದಕ್ಕೆ ಅದು ಪಾಸಿಟಿವ್ ಇದೆ. ಇದು ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಥರ್ಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಹೋಗೋಣ. ಹೈಡ್ರೇಷನ್ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಕಾಪರ್ 1 ಈಸ್ ಮೋರ್ ನೆಗೆಟಿವ್ ದ್ಯಾನ್ ದಟ್ ಆಫ್ ಕಾಪರ್ ಪ್ಲಸ್ 2. ಇದನ್ನೇ ಕಾಪರ್ ಪ್ಲಸ್ 1 ಮತ್ತು ಕಾಪರ್ ಪ್ಲಸ್ 2ಗಳ ನಾನೀಗ ಜಸ್ಟ್ ಹೇಳಿದ್ದೀನಿ, ಕಾಪರ್ ಪ್ಲಸ್ 1ಗೆ ಲೋ ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಹೈಡ್ರೇಷನ್ ಎಂಥಾಲ್ಪಿ ಇದ್ದರೆ ಕಾಪರ್ ಪ್ಲಸ್ 2ಗೆ ಹೈ ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಹೈಡ್ರೇಷನ್ ಎಂಥಾಲ್ಪಿ ಇದೆ. ಆ ಕಾರಣದಿಂದ ನಾವು ಈ ಸ್ಟೇಟ್ಮೆಂಟನ್ನು ತಪ್ಪು ಅಂತ ಹೇಳಬೇಕು. ಕಾರಣ ಏನಂದರೆ ಕಾಪರ್ ಪ್ಲಸ್ 1 ಈಸ್ ಲಾರ್ಜರ್ ಇನ್ ಸೈಜ್, ಕಾಪರ್ ಪ್ಲಸ್ 2 is smaller in size. Larger ions cannot attract more water compared to smaller ions. The smaller ions can easily attract water. ಹಾಗಾಗಿ ಇಲ್ಲಿ ಮೋರ್ ಹೈಡ್ರೇಷನ್, ಇಲ್ಲಿ ಲೆಸ್ ಹೈಡ್ರೇಷನ್ ಇರುತ್ತೆ. ಸೊ ಆ ಸ್ಟೇಟ್ಮೆಂಟ್ ತಪ್ಪಾಗುತ್ತೆ. ಸಿ ಈಸ್ ಫಾಲ್ಸ್. ನೆಕ್ಸ್ಟ್ ಒನ್, ಡಿ, VF5 ಈಸ್ ಮೋರ್ ಕೋವಲೆಂಟ್ ದ್ಯಾನ್ COF3. ದಟ್ ಈಸ್ ಟ್ರೂ. ಯಾಕಂದರೆ ವನಾಡಿಯಮ್ ಕಂಪೇರ್ ಮಾಡಿದಾಗ +5 ಚಾರ್ಜ್ ಇದೆ, ಕೊಬಾಲ್ಟ್ ಕಂಪೇರ್ ಮಾಡಿದಾಗ CO+3 ಚಾರ್ಜ್ ಇದೆ. ಹಾಗಾಗಿ ನಾವು ಹೈಯರ್ ಇಸ್ ದ ಚಾರ್ಜ್, higher is the covalent character ಅನ್ನುವ ಬೇಸಿಸ್ ಮೇಲೆ covalent character is directly proportional to charge on cation. Of course anion ಕೂಡ. ಸೊ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್, ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ಚಾರ್ಜ್ ಎಲ್ಲಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಅಲ್ಲಿ ಕೋವಲೆಂಟ್ ಕ್ಯಾರೆಕ್ಟರ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಒನ್, ಇ, higher is the hydration enthalpy, lower is the stability of cation. ಇದು ತಪ್ಪಾಗುತ್ತೆ. ಎಷ್ಟು ಹೈಡ್ರೇಷನ್ ಎಂಥಾಲ್ಪಿ ಬಂದಿದರೆ ಅಷ್ಟು ಅಟ್ರಾಕ್ಷನ್ ಟುವರ್ಡ್ಸ್ ವಾಟರ್ ಅಂತ ಅರ್ಥ. ಎಷ್ಟು ಅಟ್ರಾಕ್ಷನ್ ಟುವರ್ಡ್ಸ್ ವಾಟರ್ ಇದ್ದರೆ ಅಷ್ಟು ಸ್ಟೇಬಲ್ ಅಂತ ಅರ್ಥ. ಯಾಕಂದರೆ ಇಲ್ಲಿರುವ ಪಾಸಿಟಿವ್ ಚಾರ್ಜನ್ನು ಸುತ್ತ ವಾಟರ್ ಸೇರಿ ತನ್ನ ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ದ್ವಾರ ಸ್ಟೆಬಿಲೈಸ್ ಮಾಡ್ತಾ ಇದೆ. ಆ ತರಹ ಸ್ಟೆಬಿಲೈಸ್ ಮಾಡೋದು ಎಷ್ಟು ಜಾಸ್ತಿ ಆದರೆ ಅಷ್ಟು ಸ್ಟೆಬಿಲಿಟಿ. ಸೊ ಹೈಯರ್ ಇಸ್ ದ ಹೈಡ್ರೇಷನ್ ಎಂಥಾಲ್ಪಿ ವಿತ್ ನೆಗೆಟಿವ್ ಸೈನ್, ಹೈಯರ್ ಇಸ್ ದ ಸ್ಟೆಬಿಲಿಟಿ. ಸೊ ಸ್ಟೇಟ್ಮೆಂಟ್ ಇ ಈಸ್ ಅ ಫಾಲ್ಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಸೊ ದಿ ಕರೆಕ್ಟ್ ಆನ್ಸರ್ ಇಸ್ ಎ ಈಸ್ ಟ್ರೂ, ಬಿ ಈಸ್ ಟ್ರೂ, ಡಿ ಈಸ್ ಟ್ರೂ. Therefore A, B and D is the correct answer for this. Let's go to the next question. The next question is 49. Identify the pair of ions with same spin only magnetic moment. When we consider this, identify this pair of spin only ions with spin only magnetic moment. ಸ್ಪಿನ್ ಓನ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ ಇರುವಂತಹ ಸೇಮ್ ಸ್ಪಿನ್ ಇರೋದು ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಸೊ ಲೆಟ್ಸ್ ವರ್ಕ್ ಆನ್ ಇಟ್. ಐ ಹ್ಯಾವ್ ಅ ಫ್ಯೂ ಅಯಾನ್ಸ್ ಗಿವನ್ ಹಿಯರ್. ಟೈಟಾನಿಯಂ +3, ಟೈಟಾನಿಯಂ +2. ನೀವು ನೋಡಿ, ಸೇಮ್ ಸ್ಪಿನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ ಇರಬೇಕಂದ್ರೆ ಸೇಮ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರಬೇಕಲ್ವಾ ಫಸ್ಟು. ನಂಬರ್ ಆಫ್ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಸೇಮ್ ಇದ್ದರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ ಕೂಡ ಸೇಮ್ ಇರುತ್ತೆ. ಟೈಟಾನಿಯಂ +3 ಟೈಟಾನಿಯಂ +2ನಲ್ಲಿ ಒಂದು ಚಾರ್ಜ್ ಮಾತ್ರ ಹೈಯರ್ ಇದೆ, ಆವಾಗ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ನಲ್ಲಿ ಡಿಫರೆನ್ಸ್ ಬರುತ್ತೆ. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ ಸೇಮ್ ಹೆಂಗಿರುತ್ತೆ ಅದರಲ್ಲಿ? ಅದಾಗಲಿಕ್ಕಿಲ್ಲ. ಅಂದರೆ ಒಂದೇ ಎಲಿಮೆಂಟಿಗೆ ಸಂಬಂಧಪಟ್ಟಂಥ ಎರಡು ಅಯಾನ್ಸ್ನಲ್ಲಿ ಸೇಮ್ ಸ್ಪಿನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ ಬರೋದು ತುಂಬ ಕಷ್ಟ, ಇದು ಪಾಸಿಬಲ್ ಆಗಲ್ಲ. ಸೊ ಈ ಕೇಸ್ ತಪ್ಪು. ಎರಡನೇ ಕೇಸ್, ಕ್ರೋಮಿಯಂ +2 Mn+2 ಕೊಟ್ಟಿದ್ದಾರೆ. ಕ್ರೋಮಿಯಂ +2 Mn+2ದಲ್ಲಿ ಕೂಡ ಆಗಲ್ಲ. ಯಾಕಂದರೆ ಕ್ರೋಮಿಯಂ +2 ಅಂದರೆ ಕಾನ್ಫಿಗರೇಷನ್ ಬಂದುಬಿಟ್ಟು ನಮಗೆ 3D4 ಬರ್ತಾ ಇದೆ, Mn+2 ಅಂದರೆ 3D5. ನಂಬರ್ ಆಫ್ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬೇರೆ ಬೇರೆ ಅದಾವೆ, ಸೊ ಸೇಮ್ ಸ್ಪಿನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ಗೆ ಅವಕಾಶ ಇಲ್ಲ. ನೆಕ್ಸ್ಟ್, ವೆನಡಿಯಂ +2 ಕೋಬಾಲ್ಟ್ +2 ಕೊಟ್ಟಿದ್ದಾರೆ. ನೋಡೋಣ ಇದರಲ್ಲಿ ಪಾಸಿಬಲ್ ಆಗುತ್ತೇನೋ. ಇದು 3D3 ಕಾನ್ಫಿಗರೇಷನ್, ಇದು 3D7 ಕಾನ್ಫಿಗರೇಷನ್. ಇಲ್ಲಿ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ 3, ಇಲ್ಲಿ ಕೂಡ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ 3. ಹಾಗಾದರೆ ಇದು ಇದರಲ್ಲಿ ಪಾಸಿಬಿಲಿಟಿ ಇದೆ. ಸೊ ವಿ ಕ್ಯಾನ್ ಡೆಫಿನೆಟ್ಲಿ ಟೆಲ್ ದ್ಯಾಟ್ vanadium +2 and cobalt +2 have definite number of unpaired electrons being same. Definitely as a result there will be same magnetic moment, spin magnetic moment. So option 3 is correct answer. Next question. The value of magnetic moment in board magneton for a transition metal of 3D series is 4.89. Its electronic configuration is. ಯಾವುದೋ ಒಂದು ಎಲಿಮೆಂಟ್ಗೆ ಬೋರ್ ಮ್ಯಾಗ್ನೆಟಾನ್ಸ್ನಲ್ಲಿ ಅದರ ಸ್ಪಿನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ 4.89 ಬೋರ್ ಮ್ಯಾಗ್ನೆಟಾನ್ ಇದೆ. ಅಂದರೆ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ 4 ಇರಬೇಕು. ಈ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಮುಂಚೆ ಎಷ್ಟು ಯಾವ ಡಿಜಿಟ್ ಇರುತ್ತೆ ಆ ಡಿಜಿಟ್ ಅಷ್ಟು ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರ್ತವೆ ಅದರಲ್ಲಿ. ಸೊ 4.89 ಇದೆ ಅಂದರೆ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಈಸ್ 4 ಅಂತ ಅರ್ಥ. ಈಗ ಅದರ ಪ್ರಕಾರ ಕಾನ್ಫಿಗರೇಷನ್ಸನ್ನು ನೋಡಿದರೆ ಫಸ್ಟ್ ಕೊಟ್ಟಿದ್ದು 3D5 4s, ಎರಡನೇದು 3D6 4s, ಮೂರನೇದು 3D5 4s1, ನಾಲ್ಕನೇದು 3D1 4s. ಈಗ ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾಗಿದ ವಿಷಯ ಏನು ಅಂತ ಅಂದರೆ, ಈ 3D ಸೀರೀಸ್ನಲ್ಲಿ 4.89 ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದಾಗ 4 ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬರೋದು 3D6ನಲ್ಲಿ. ದೇರ್ಫೋರ್ ಆಪ್ಷನ್ ನಂಬರ್ 2 is correct answer. Let's move to the next one. Mixed oxides among the following are. ಮಿಕ್ಸ್ಡ್ ಆಕ್ಸೈಡ್ಸ್ ಅಂದರೆ ಏನೇನು ಬರ್ತವೆ? ಫಸ್ಟ್ ಆಪ್ಷನ್ Mn2O7, ನೆಕ್ಸ್ಟ್ ಆಪ್ಷನ್ Mn3O4, ನೆಕ್ಸ್ಟ್ ಆಪ್ಷನ್ Fe3O4. And then which one is correct? Mn2O7 is not a mixed oxide, it is a single oxide with this kind of structure. Whereas Mn3O4 is a mixed oxide, a combination of MnO and Mn2O3, FeO and Fe2O3 ಈ ಕಾಂಬಿನೇಷನ್ಸ್ ಇರೋದ್ರಿಂದ. ಹಾಗೆ CO3O4 ಕೂಡ COO ಪ್ಲಸ್ CO2O3 ಈ ಮೂರು ಕಾಂಬಿನೇಷನ್ಸ್ ಕೂಡ ಮಿಕ್ಸ್ಡ್ ಆಕ್ಸೈಡ್ಸ್ ಆಗ್ತವೆ ಡ್ಯೂ ಟು ದ ಫಾರ್ಮೇಷನ್ ಆಫ್ ದೋಸ್ ಆಕ್ಸೈಡ್ಸ್ ಫ್ರಮ್ 2 ಡಿಫ್ರೆಂಟ್ ಆಕ್ಸೈಡ್ಸ್. ಮತ್ತೆ ನೆಕ್ಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ನೋಡ್ತಾ ಇದ್ವಿ. ಈ ತರಹ ಇವಾಗ ಸ್ಟೇಟ್ಮೆಂಟ್ ಯಾವುದು ಕರೆಕ್ಟ್? 52nd ಕ್ವೆಶ್ಚನ್. ಯಾವ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕರೆಕ್ಟ್ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಇವಾಗ ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾಗಿದ್ದು ನೋಡಿ, ಕಂಪೌಂಡ್ಸ್ ಆಫ್ ಫಸ್ಟ್ ಟ್ರಾನ್ಸಿಷನ್ ಸೀರೀಸ್ ಹ್ಯಾವ್ ಬೋತ್ ಆರ್ಬಿಟಾಲ್ ಆ್ಯಂಡ್ ಸ್ಪಿನ್ ಆಂಗ್ಯುಲರ್ ಮೊಮೆಂಟ್ಸ್ ಟು ಕನ್ಸಿಡರಬಲ್ ಎಕ್ಸ್ಟೆಂಟ್. ಕಂಪೌಂಡ್ಸ್ ಆಫ್ ಫಸ್ಟ್ ಟ್ರಾನ್ಸಿಷನ್ ಸೀರೀಸ್ have both orbital and spin magnetic moments. So what I am trying to tell you is 3D transition series ನಲ್ಲಿರುವ ಕಂಪೌಂಡ್ಸ್ ಏನಿರ್ತವೆ, ಈ ಕಂಪೌಂಡ್ಸ್ನಲ್ಲಿ ಆರ್ಬಿಟಲ್ ಆಂಗ್ಯುಲರ್ ಮೊಮೆಂಟಮ್ ಮತ್ತು ಸ್ಪಿನ್ ಆಂಗ್ಯುಲರ್ ಮೊಮೆಂಟಮ್ ಎರಡು ಕನ್ಸಿಡರ್ ಮಾಡಿದರೆ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ಗೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಬರೋದು ಎದಕ್ಕಂದರೆ ಅದರ ಮೂವ್ಮೆಂಟ್ ದ್ವಾರ ಬರ್ತಾ ಇದೆ. ನ್ಯೂಕ್ಲಿಯಸ್ ಸುತ್ತ ಅದು ಅಡ್ಡಾಡ್ತಾ ಆರ್ಬಿಟಲ್ ಆಂಗ್ಯುಲರ್ ಮೊಮೆಂಟನ್ನು ಕ್ರಿಯೇಟ್ ಮಾಡುತ್ತೆ, ಅದರಿಂದ ಆರ್ಬಿಟಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ ಬರುತ್ತೆ. ತನ್ನ ಸುತ್ತ ತಾನೇ ತಿರುಗ್ತಾ ಸ್ಪಿನ್ ಆಂಗ್ಯುಲರ್ ಮೊಮೆಂಟನ್ನು ಕ್ರಿಯೇಟ್ ಮಾಡಿಕೊಳ್ಳುತ್ತೆ, ಅದರಿಂದ ಸ್ಪಿನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ ಬರುತ್ತೆ. ಆದರೆ 3D ಸೀರೀಸ್ ಎಲಿಮೆಂಟ್ಸಿನ ಕಂಪೌಂಡ್ಸ್ನಲ್ಲಿ ಲಿಗ್ಯಾಂಡ್ಸ್ನ ಇನ್ಫ್ಲೂಯೆನ್ಸ್ ಇರೋದರಿಂದ ಈ ಆರ್ಬಿಟಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ ಅನ್ನೋದು ಕ್ವೆಂಚ್ ಆಗಿ, ಅಂದರೆ ಕಮ್ಮಿ ಆಗಿ ನೆಗ್ಲಿಜಿಬಲ್ ಆಗುತ್ತೆ, ಅದನ್ನು ಇಗ್ನೋರ್ ಮಾಡ್ತೀವಿ. ಈಗ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕಾಗಿದ್ದು ಕೇವಲ ಇದು, ಅಂದರೆ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಈಸ್ ರಾಂಗ್ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್. Compounds of first transition series have both orbital and spin angular moments to considerable extent ಅನ್ನೋದು ತಪ್ಪು ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಗುತ್ತೆ. ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್, spin only magnetic moment is directly proportional to number of unpaired electrons. Of course it is. ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ದರೆ ಅಷ್ಟು ಸ್ಪಿನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ ಬರುತ್ತೆ. Fe+2 is a stronger reducing agent than Cr+2 ಅನ್ನೋದು ಸ್ಟೇಟ್ಮೆಂಟ್. Fe+2 Cr+2ಗಳನ್ನು ನಾವು ಕಂಪೇರ್ ಮಾಡಿದ್ದಾಗ Fe+2 loses electron to become Fe+3, whereas Cr+2 loses electron to become Cr+3. When those lose electron like that, they act as strong reducing agents. But when we consider between these two, which one is stronger, the answer is Cr+3 but not Fe+3. ಎದಕ್ಕಂತಂದರೆ ಇದು ಸ್ಟ್ರಾಂಗಾ ಅಂತ ಅನ್ನೋದು ಆ ಬಂದಿದ ಅಯಾನ್ಸಿನ ಸ್ಟೆಬಿಲಿಟಿ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. ಆ ಸ್ಟೆಬಿಲಿಟೀಸ್ ಕಂಪೇರ್ ಮಾಡಿದಾಗ ಇದು ಎಕ್ವಿಯಸ್, ಇದು 3D5, ಇದು 3D3, ಈ ಥರ ಇದ್ದಾಗ ನಮಗೇನು ಅನಿಸುತ್ತೆ, 3D5 is half filled, so ಇದು more stable. 3D3 is only partially filled, so is less stable ಅನಿಸುತ್ತೆ. ಅದು ತಪ್ಪು ಒಪಿನಿಯನ್. Fe+3ನಲ್ಲಿ 3D5 ಇದ್ದರೂ ಕೂಡ ಈ Cr+3ದಲ್ಲಿರುವ 3D3ನೇ ಮೋರ್ ಸ್ಟೇಬಲ್. ಕಾರಣ ಎಕ್ವಿಯಸ್ ಮೀಡಿಯಂನಲ್ಲಿ ನಮಗೆ ಇದು T2G ಮತ್ತು EG ಅಂತ ಸ್ಪ್ಲಿಟ್ ಆದಾಗ ಈ T2G ಅನ್ನೋದು ಹಾಫ್ ಫಿಲ್ಡ್ ಆಗತ್ತೆ. ಇದರ ಸ್ಟೆಬಿಲಿಟಿ ಇದರಲ್ಲಿರುವ ಎರಡು ಹಾಫ್ ಫಿಲ್ಡ್ಗಿಂತ ಇದು ಕೂಡ ಸ್ಪ್ಲಿಟ್ ಆಗತ್ತೆ, ಇದರಲ್ಲಿ ಕೂಡ ಹಾಫ್ ಫಿಲ್ಡ್ ಇದೆ, ಎರಡು ಹಾಫ್ ಫಿಲ್ಡ್ ಅದಾವೆ, ಆದರೂ ಇದರ ಸ್ಟೆಬಿಲಿಟಿಗಿಂತ ಇದರ ಸ್ಟೆಬಿಲಿಟಿನೇ ಜಾಸ್ತಿ. ಕಾರಣ ಏನು ಅಂತ ಅಂದರೆ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಗ್ಯಾಪನ್ನು CFSC ವ್ಯಾಲ್ಯೂ ಅಂತ ಹೇಳ್ತೀವಿ, ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಗ್ಯಾಪನ್ನು CFSC ವ್ಯಾಲ್ಯೂ ಅಂತ ಹೇಳ್ತೀವಿ. ಇಲ್ಲಿ CFSC ಗ್ಯಾಪ್ ಮೋರ್, ಅದಕ್ಕೆ ಮೋರ್ ಸ್ಟೆಬಿಲಿಟಿ. ಇಲ್ಲಿ CFSC ವ್ಯಾಲ್ಯೂ ಕಮ್ಮಿ, ಅದಕ್ಕೆ ಇಲ್ಲಿ ಲೆಸ್ ಸ್ಟೆಬಿಲಿಟಿ ಬರುತ್ತೆ. ಸೊ 3D5 ನೋಡಿ ಮೋಸ ಆಗಬಾರ್ದು. ಇಲ್ಲಿ 3D3 ಇದು ಹಾಫ್ ಫಿಲ್ಡ್ ಬರುತ್ತೆ, ಅದು T2G ಹಾಫ್ ಫಿಲ್ಡ್ ಬರುತ್ತೆ. ಆದರೆ ಇಲ್ಲಿ CFSC ಜಾಸ್ತಿ ಬರ್ತಾ ಇರೋದ್ರಿಂದ ನಮಗದು ಮೋರ್ ಸ್ಟೇಬಲ್ ಆಗುತ್ತೆ ವೆನ್ ಕಂಪೇರ್ಡ್ ಟು ದಿಸ್ ಒನ್. ಸೊ ಬಿಕಾಸ್ Cr+3 ಇಸ್ ಮೋರ್ ಸ್ಟೇಬಲ್, Cr+2 ಇಸ್ ಅ ಸ್ಟ್ರಾಂಗರ್ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಅಂತ ತಿಳ್ಕೋಬೇಕು. ಮೂವಿಂಗ್ ಆನ್ ಟು ದ ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾರ್ಟ್. ಇನ್ನೊಂದು ಸ್ಟೇಟ್ಮೆಂಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ, Zinc+2 and Copper+2 both are diamagnetic is a false statement. Zinc+2 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, ಅದು ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್, ಯಾಕಂದರೆ ಅದರಲ್ಲಿ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸೇ ಇಲ್ಲ. Copper+2 ಬಗ್ಗೆ ಹೇಳಿದ್ದಾರೆ, ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದಾಗ when we take it, it is actually having an unpaired electron. ಸೊ 3D9 ಕಾನ್ಫಿಗರೇಷನ್ ಇದೆ ಅದರಲ್ಲಿ. ಇದು ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾಗಿದ್ದ ವಿಷಯ. ಲೆಟ್ಸ್ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟ್. ವಿಚ್ ಒನ್ ಆಫ್ ದ ಫಾಲೋವಿಂಗ್ ಡಸ್ ನಾಟ್, ಇನ್ನೊಂದು ಕ್ವೆಶ್ಚನ್ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ನಾನು. ಸೊ ವಿಚ್ ಒನ್ ಆಫ್ ದ ಫಾಲೋವಿಂಗ್ ಡಸ್ ನಾಟ್ ಕರೆಕ್ಟ್ಲಿ ರಿಪ್ರೆಸೆಂಟ್ ದಿ ಆರ್ಡರ್ ಆಫ್ ದ ಪ್ರಾಪರ್ಟಿ ಇಂಡಿಕೇಟೆಡ್ ಅನ್ನೋದು ಸ್ಟಡಿ ಮಾಡೋಣ. ಆ ಕ್ವೆಶ್ಚನ್ ಇವಾಗ ಕೊಟ್ಟಿದ್ದ ಕ್ವೆಶ್ಚನ್ಸ್ನಲ್ಲಿ ಟೈಟಾನಿಯಂ, ವ್ಯಾನಡಿಯಂ, ಕ್ರೋಮಿಯಂ, ಮ್ಯಾಂಗನೀಸ್ ಈ ಆರ್ಡರ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇದಕ್ಕೆ ಇನ್ಕ್ರೀಸಿಂಗ್ ನಂಬರ್ ಆಫ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸ್ ಅನ್ನೋದು ಕೊಟ್ಟಿದ್ದಾರೆ. ಇವು ಈ ಆರ್ಡರ್ನಲ್ಲಿ ಇರ್ತಾವ ಇರಲ್ವಾ ಅನ್ನೋದು ವೆರಿಫೈ ಮಾಡಬೇಕು. ಇದರ ಕಾನ್ಫಿಗರೇಷನ್ 4s2 3d2, ಇದು 4s2 3d3, 4s1 3d5, 4s2 3d5. ಟೈಟಾನಿಯಂ +2 +3 +4, ವ್ಯಾನಡಿಯಂ plus 2 plus 3 plus 4 plus 5. 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 7. Number of unpaired electrons increase ಆಗ್ತಾ ಇರುವುದರಿಂದ ನಮಗೆ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸ್ ಕೂಡ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಿದ್ದಾವೆ. ದೇರ್ಫೋರ್ ಎಸ್, ದ ಫಸ್ಟ್ ಆರ್ಡರ್ ಈಸ್ ಕರೆಕ್ಟ್. ಈಗ ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ವೆರಿಫೈ ಮಾಡೋಣ. ಟೈಟಾನಿಯಂ ಪ್ಲಸ್ 3, ವ್ಯಾನೇಡಿಯಂ ಪ್ಲಸ್ 3, ಕ್ರೋಮಿಯಂ ಪ್ಲಸ್ 3, Mn ಪ್ಲಸ್ 3. ಇದು ಇನ್ಕ್ರೀಸಿಂಗ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ ಹೇಳ್ತಿದ್ದಾರೆ. ಇನ್ಕ್ರೀಸಿಂಗ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟನ್ನು ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದರೆ ಇದರಲ್ಲಿ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಷ್ಟು ಬರ್ತವೆ? 4s2 3d2 ಅಲ್ವಾ, ಅಂದರೆ 3d1. ವ್ಯಾನೇಡಿಯಂ ಪ್ಲಸ್ 3 ಅಂದರೆ 3d2. ಕ್ರೋಮಿಯಂ ಪ್ಲಸ್ 3 3d3, 3d4. You can see that the number of unpaired electrons is increasing from 1, 2, 3, 4. So magnetic moment also increases. Third, titanium, vanadium, chromium and manganese ಗಳಲ್ಲಿ increasing melting points. ಇನ್ಕ್ರೀಸಿಂಗ್ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ಸ್ ಈ ಆರ್ಡರ್ನಲ್ಲಿ ಇರ್ತಾವ ಅಂತ ನೋಡಿದರೆ ಗ್ರಾಫ್ ಆ ಥರ ಹೇಳ್ತಾ ಇಲ್ಲ. ಟೈಟಾನಿಯಂ, ವ್ಯಾನೇಡಿಯಂ, ಕ್ರೋಮಿಯಂಗಳಿಗೆ ಇನ್ಕ್ರೀಸ್ ಆಗಿ ಮ್ಯಾಂಗನೀಸ್ಗೆ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಸೊ ಈ ಆರ್ಡರ್ ತಪ್ಪು. ನೆಕ್ಸ್ಟ್, ಮ್ಯಾಂಗನೀಸ್, ಕ್ರೋಮಿಯಂ, ಟೈಟಾನಿಯಂ, ವ್ಯಾನೇಡಿಯಂ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಆಟಮೈಸೇಷನ್. ಮ್ಯಾಂಗನೀಸ್, ಕ್ರೋಮಿಯಂ, ಟೈಟಾನಿಯಂ, ವ್ಯಾನೇಡಿಯಂ ಇದು ಕರೆಕ್ಟ್ ಆರ್ಡರ್ of enthalpy of atomization. So that is fine. Let's go with the next important part. 54th question discuss madona. When we consider 54th question, we have statement 1 to be discussed. Ferromagnetism is an extreme case of paramagnetism. ಸೊ ಫೆರೋಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಇಸ್ ಅನ್ ಎಕ್ಸ್ಟ್ರೀಮ್ ಕೇಸ್ ಆಫ್ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಸಮ್. ಅಂದರೆ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಸಮಿನ ಸ್ಟ್ರೆಂಗ್ತ್ ಜಾಸ್ತಿ ಆದರೆ then it obviously becomes ferromagnetism. So statement 1 is correct answer. Next one, for the compounds of transition metals, spin angular momentum is effectively quenched is a wrong statement. Compounds of 3D transition elements ke spin angular moment alla quench agodu orbital angular momentum. So statement 1 is correct and statement 2 is false. It actually first statement bandbittu namige I think 2 years ago a NEET exam nalli kottida statement. Let's go ahead with the next part. Next question is 55. The correct set of elements that shows a great deviation between calculated and observed magnetic moments is ಯಾವ set of elements ಗೆ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್ ಮತ್ತು ಅಬ್ಸರ್ವ್ಡ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ಸ್ ಮಧ್ಯದಲ್ಲಿ ಒಂದು ಟ್ಯಾಬ್ಯುಲರ್ ಫಾರ್ಮನ್ನು ಕೊಟ್ಟಿರ್ತಾರೆ. ಅದರಲ್ಲಿ ಯಾವುದಕ್ಕೆ ಜಾಸ್ತಿ ಡಿವಿಯೇಷನ್ ಇದೆ ಅಂದರೆ ಡಿವಿಯೇಷನ್ ಕಾಣ್ತಾ ಇದೆ ಅಂತ ಗಮನಿಸಿದರೆ ಅದು ಐರನ್ದಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಐರನ್, ಕೋಬಾಲ್ಟ್, ನಿಕೆಲ್. ಐರನ್, ಕೋಬಾಲ್ಟ್, ನಿಕೆಲ್ಗಳಿಗೆ ಕಾಪರ್ ಕೂಡ ಈ ಚೇಂಜ್ ಅನ್ನೋದು ನಾವು ತುಂಬ ಜಾಸ್ತಿನೇ ಇರುತ್ತೆ. ಡಿವಿಯೇಷನ್ ಬಿಟ್ವೀನ್ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್ ಆ್ಯಂಡ್ ಅಬ್ಸರ್ವ್ಡ್ ಸ್ಪಿನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ಸ್ ಅದನ್ನು ಗಮನಿಸಬೇಕು. ಅದರಲ್ಲಿ ನಾವು ಪೇರ್ಸನ್ನು ತೊಗೊಂಡಿದ್ದಾಗ ಫಸ್ಟ್ ಆಪ್ಷನ್ ಟೈಟಾನಿಯಂ, ಕ್ರೋಮಿಯಂ ಎರಡಕ್ಕೂ ಇರಲ್ಲ. ನಿಕೆಲ್, ಕೋಬಾಲ್ಟ್ ಇರುತ್ತೆ. ಕ್ರೋಮಿಯಂ ಪ್ಲಸ್ 2, ಮ್ಯಾಂಗನೀಸ್ ಪ್ಲಸ್ 2 ಎರಡಕ್ಕೂ ಇರಲ್ಲ. ಐರನ್, ವ್ಯಾನೇಡಿಯಂ ಐರನ್ಗಿರುತ್ತೆ, ವ್ಯಾನೇಡಿಯಮ್ಗಿರಲ್ಲ. ಸೊ ಆಪ್ಷನ್ 2 ಇಸ್ ಕರೆಕ್ಟ್ ಆನ್ಸರ್. ರಿಮೆಂಬರ್, ಐರನ್, ಕೋಬಾಲ್ಟ್, ನಿಕೆಲ್, ಕಾಪರ್ ಈ 4 ಎಲಿಮೆಂಟ್ಸ್ಗೆ ಆ ಥರ ಇರುತ್ತೆ. 56th question. Spin only magnetic moment is higher than of niobium plus 3 is higher than that of osmium plus 3 ಅನ್ನೋ ಸ್ಟೇಟ್ಮೆಂಟನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. ಈ 2 ಅನ್ನೋದು ಸ್ಟೇಟ್ಮೆಂಟ್, ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕರೆಕ್ಟ್ ಆಗುತ್ತಾ ಇಲ್ಲ ಅನ್ನೋದು ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕು. ಇದರಿಗೋಸ್ಕರ ನೀವು ಎಲಿಮೆಂಟ್ಸಿನ ಪೊಸಿಷನ್ನ ನೆನಪು ಮಾಡಿಕೋಬೇಕು. ಎಲಿಮೆಂಟ್ಸಿನ ಪೊಸಿಷನ್ನ ನೆನಪು ಮಾಡಿಕೊಂಡ್ರೆ ನಮಗೆ ಸೆಕೆಂಡ್ ಸೀರೀಸ್ನಲ್ಲಿ ನಿಯೋಬಿಯಂ ಬರುತ್ತೆ, ಇಟ್ರಿಯಂ, ಜಿರ್ಕೋನಿಯಂ, ನಿಯೋಬಿಯಂ, ಇದು ಆರ್ಡರ್, ಇಟ್ರಿಯಂ, ಜಿರ್ಕೋನಿಯಂ, ನಿಯೋಬಿಯಂ. ಅದೇ ಥರ್ಡ್ ಸೀರೀಸ್ನಲ್ಲಿ ಆಸ್ಮಿಯಂ ಬರುತ್ತೆ. ಥರ್ಡ್ ಸೀರೀಸ್ನಲ್ಲಿ ಲ್ಯಾಂಥನಮ್, ಹಾಫ್ನಿಯಂ, ಟ್ಯಾಂಟಲಮ್, ಟಂಗ್ಸ್ಟನ್, ರೇನಿಯಂ, ಆಸ್ಮಿಯಂ. ನೀವೊಂದ್ಸಲ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಎರಡಕ್ಕೂ +3 ಸ್ಟೇಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇಲ್ಲಿಗೆ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಜಾಸ್ತಿ ಬರಲ್ಲ, ಇಲ್ಲಿಗೆ ಬರ್ತವೆ ಹೈ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಅಂದರೆ ಮೋರ್ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಸ್ಮಿಯಂನಲ್ಲಿ ಇರ್ತವೆ. ಸ್ಪಿನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ ಇಲ್ಲಿ ಜಾಸ್ತಿ ಇರಬೇಕು, ಇಲ್ಲಿ ಅಲ್ಲ. Therefore, first statement is a wrong statement. Second statement nodi. Many of transition metals ions are ferromagnetic. No, they are paramagnetic. ಬಹಳ ಕೆಲವು ಮಾತ್ರ ಫೆರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಸ್ಟೇಟ್ನಲ್ಲಿ ಬರ್ತವೆ, ಅದು ಕೂಡ ಮೆಟಲ್ ಸ್ಟೇಟ್ನಲ್ಲಿ ಅದಾವ, ಅಯಾನಿಕ್ ಸ್ಟೇಟ್ನಲ್ಲಿ ಅಲ್ಲ. ಐರನ್, ಕೊಬಾಲ್ಟ್, ನಿಕೆಲ್ ಈ 3 ಕೂಡ ಫೆರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಇನ್ ನೇಚರ್, ಓನ್ಲಿ ಇನ್ ಮೆಟಾಲಿಕ್ ಸ್ಟೇಟ್ ಬಟ್ ನಾಟ್ ಇನ್ ಅಯಾನಿಕ್ ಸ್ಟೇಟ್. ಅಟಾಮಿಕ್ ಸ್ಟೇಟ್ನಲ್ಲಿ ಮಾತ್ರ ಆ ಥರ ಅದಾವೆ. ದೇರ್ಫೋರ್ ವಿ ನೀಡ್ ಟು ಸೇ ಸ್ಟೇಟ್ಮೆಂಟ್ 1 ಇಸ್ ಫಾಲ್ಸ್, ಸ್ಟೇಟ್ಮೆಂಟ್ 2 ಇಸ್ ಫಾಲ್ಸ್. ನೆಕ್ಸ್ಟ್ ಒನ್, ಇದರಲ್ಲಿ ಮ್ಯಾಚ್ ದ ಫಾಲೋವಿಂಗ್ನಲ್ಲಿ E0 ವ್ಯಾಲ್ಯೂಸನ್ನು ಮ್ಯಾಚ್ ಮಾಡಬೇಕು. ನಮಗೆ E0 ವ್ಯಾಲ್ಯೂಸ್ ನೆನಪಿಟ್ಕೋಬೇಕಂತ ಈ ಕ್ವೆಶ್ಚನ್ ಹೇಳ್ತಾ ಇಲ್ಲ, ಬಟ್ ಜಸ್ಟ್ ಓವರ್ ಆಲ್ ಕಂಪ್ಯಾರಿಸನ್ ಯಾವ ತರಹ ಇದೆ ಅಂತ ಮ್ಯಾಚ್ ಮಾಡಬೇಕು. ಎದು ಕಾಪರ್, ಬಿ ಟೈಟಾನಿಯಂ, ಸಿ ಜಿಂಕ್, ಡಿ ಮ್ಯಾಂಗನೀಸ್. -0.761, 2 -1.63, 3 -1.18 ಪ್ಲಸ್ 0.34. ಕಾಪರ್ದು ಪಾಸಿಟಿವ್ ಅನ್ನೋ ವಿಷಯ ಎಲ್ಲರಿಗೂ ಗೊತ್ತಿದೆ, ಜಿಂಕ್ಗೆ -0.76 ಅನ್ನೋ ವಿಷಯ ಕೂಡ ಎಲ್ಲರಿಗೂ ಗೊತ್ತಿದೆ. ಸೊ ವಾಟ್ ವಿ ಗೆಟ್ ಇಸ್ A4C1. ಆ್ಯಂಡ್ ಇನ್ ಕೇಸ್ ಆಫ್ ಟೈಟಾನಿಯಮ್ ಆ್ಯಂಡ್ ಮ್ಯಾಂಗನೀಸ್ ಬಂದಾಗ, ಮ್ಯಾಂಗನೀಸ್ಗೆ ಸೆಕೆಂಡ್ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ, ಫಸ್ಟ್ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿಗಳಲ್ಲಿ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಚೇಂಜ್ ಬರುತ್ತೆ. ಹಾಗಾಗಿ ನಾವು ಟೈಟಾನಿಯಮ್ಗೆ -1.63, ಮ್ಯಾಂಗನೀಸ್ಗೆ -1.18 ಅನ್ನು, ಅಂದರೆ ಮ್ಯಾಂಗನೀಸ್ಗೆ ಸ್ವಲ್ಪ ಲೋವರ್ ವ್ಯಾಲ್ಯೂವನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ಬೋದು. ಸೊ ವಿ ಕ್ಯಾನ್ ಕನೆಕ್ಟ್ ಇಟ್ ದ್ಯಾಟ್ ವೇ ವೆನ್ ಕಂಪೇರ್ಡ್ ಟು ಟೈಟಾನಿಯಮ್. ಲೆಟ್ಸ್ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. The next question, when we consider, it is question number 58. The ability of fluorine and oxygen to stabilize higher oxidation states of transition metals is due to what? ಈ ಫ್ಲೋರಿನ್ ಆ್ಯಂಡ್ ಆಕ್ಸಿಜನ್ಗಳನ್ನು ಸ್ಟೆಬಿಲೈಸ್ ಮಾಡಿ, ಆ ಫ್ಲೋರಿನ್ ಆ್ಯಂಡ್ ಆಕ್ಸಿಜನ್ ಮೆಟಲ್ಸಿನ ಹೈಯರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸನ್ನು ಬಹಳ ಸ್ಟೆಬಿಲೈಸ್ ಮಾಡ್ತವೆ. ಇದು ಯಾವ ಥರ ಆಗ್ತಾ ಇದೆ ಅನ್ನೋದು ನೋಡ್ತಾ ಇದ್ವಿ. COF3 is stabilized due to higher bond dissociation enthalpy is the first statement. Actually, lower oxidation state ಇರೋದ್ರಿಂದ COF3 is an ionic compound. Ionic compounds ನಲ್ಲಿ bond dissociation enthalpy ಬರಲ್ಲ, lattice enthalpy ಬರುತ್ತೆ. So it is stable due to high lattice enthalpy, not due to high bond dissociation enthalpy. ಇದು ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್, CrF6 is stabilized due to higher lattice enthalpy. +6 ಸ್ಟೇಟ್ನಲ್ಲಿ CrF6ನಲ್ಲಿ ಕೋವಲೆಂಟ್ ಬರುತ್ತೆ. ಕೋವಲೆಂಟ್ ನೇಚರ್ನಲ್ಲಿ ಬಾಂಡ್ ಡಿಸೋಸಿಯೇಷನ್ ಎಂಥಾಲ್ಪಿ ಹೈ ಇರುತ್ತೆ ಬಿಟ್ಟು ಲ್ಯಾಟಿಸ್ ಎಂಥಾಲ್ಪಿ ಅನ್ನುವ ಪ್ರಶ್ನೆನೇ ಬರಲ್ಲ. ಥರ್ಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್, ದಿ ಎಬಿಲಿಟಿ ಆಫ್ ಆಕ್ಸಿಜನ್ ಟು ಫಾರ್ಮ್ ಮಲ್ಟಿಪಲ್ ಬಾಂಡ್ಸ್ ವಿತ್ ಮೆಟಲ್ಸ್ ಎಕ್ಸ್ಪ್ಲೈನ್ಸ್ ಇಟ್ಸ್ ಸುಪೀರಿಯಾರಿಟಿ ಅಂತ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇದು ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್, ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಯಾಕಂದರೆ ಆಕ್ಸಿಜನ್ ಫ್ಲೋರಿನ್ಗಿಂತ ಕೂಡ ತುಂಬ ಚೆನ್ನಾಗಿ ಸ್ಟೆಬಿಲೈಸ್ ಮಾಡುತ್ತೆ. ಕಾರಣ, ಆಕ್ಸಿಜನ್ ಕ್ಯಾನ್ ಫಾರ್ಮ್ ಡಬಲ್ ಬಾಂಡ್ಸ್ whereas fluorine can only form single bonds. Fourth statement, VF5 is stable due to high lattice enthalpy. VF5 ನಲ್ಲಿ ಕೂಡ +5 ಸ್ಟೇಟ್ ಇದೆ, ಅಂದರೆ ಇದು ಕೋವಲೆಂಟ್ ಬಾಂಡ್. ಹೈಯರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸ್ ಇದ್ರೆ ಕೋವಲೆಂಟ್ ಬಾಂಡ್. ಕೋವಲೆಂಟ್ ಬಾಂಡ್ ಅಂದರೆ ಬಾಂಡ್ ಡಿಸೋಸಿಯೇಷನ್ ಎಂಥಾಲ್ಪಿ ಹೈ ಇರುತ್ತೆ, ನಾಟ್ ದ ಲ್ಯಾಟಿಸ್ ಎಂಥಾಲ್ಪಿ. Therefore option number 3 is the correct statement. 49. Question number 49. The pair of ions that act as oxidizing agents is, Yava pair of ions acts as oxidizing agent. Namige +2 state nalli titanium +2, vanadium +2, chromium +2, Fe +2 ಇವೆಲ್ಲ reducing agents ಆದರೆ CO +2 Mn +2ಗಳು ಮಾತ್ರ, ಐ ಮೀನ್ CO +3 Mn +3ಗಳು ಮಾತ್ರ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ಸ್ ಆಗಿ ಆ್ಯಕ್ಟ್ ಆಗ್ತವೆ. ಸೊ ಆಪ್ಷನ್ ನಂಬರ್ 4 is correct answer. The wrong statement is, 60th question, the wrong statement is copper +1 undergoes disproportionation. Copper +1, yes, in aqueous medium undergoes disproportionation to form copper solid and copper +2 aqueous. Yes, that is a correct statement, but they are asking about the wrong statement or the incorrect statement. Cu +2 oxidizes I-2 I2. Cu +2 oxidizes I-2 I2, ಅದು ಕೂಡ ಕರೆಕ್ಟೇ, ಆ್ಯಂಡ್ ಇದು Cu2 I2 ಆಗುತ್ತೆ, ಇದು ಕೂಡ ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟೇ. FeO4 -2 decomposes readily to Fe2O3 and O2, ಇದು ಕೂಡ ಕರೆಕ್ಟೇ. FeO4 -2 ಏನಿದೆ, ಇಟ್ ಆ್ಯಕ್ಚುಲಿ ಬಿಕಮ್ಸ್ Fe2O3 and O2 on decomposition, ಇದು ಕೂಡ ಕರೆಕ್ಟೇ. ನೆಕ್ಸ್ಟ್ ಒನ್, fluorine stabilizes lower oxidation states better than it stabilizes higher oxidation states is a wrong statement. Fluorine actually stabilizes the higher oxidation states better compared to the lower oxidation states. Therefore, option 4 is a wrong statement. 61st question. ಈ ಕ್ವೆಶ್ಚನಲ್ಲಿ ಒಂದು ಗ್ರಾಫನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. ಈ ಗ್ರಾಫ್ಗೆ ವ್ಯಾಲ್ಯೂಸ್ ಅಂದರೆ ಗ್ರಾಫ್ ಯಾವ ಥರ ಬಂದಿದೆ, ಈ ಥರ ಬಂದಿದೆ. ಆದರೆ ಇಲ್ಲೇನಾಯಿತು, ಈ ಟೋಟಲ್ ವ್ಯಾಲ್ಯೂಸ್ನಲ್ಲಿ ಎರಡು ವ್ಯಾಲ್ಯೂಸ್ ಬ್ಲೂ ಆ್ಯಂಡ್ ಎರಡು ವ್ಯಾಲ್ಯೂಸ್ ನೀವು ನೋಡಿದರೆ ಕೆಳಗಿಂದು ಬೇರೆ ಮ್ಯಾಲಿಂದು ಬೇರೆ. ಕೆಳಗಿನವರೆಗೂ ಕೂಡ ಇಲ್ಲಿವರೆಗೂ ಕೂಡ ಎರಡು ಪ್ಯಾರಲಲ್ ಹೋಗ್ತಿದ್ದಾವೆ, ಒಂದು ಅಬ್ಸರ್ವ್ಡ್ ಒಂದು ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್. ಬಟ್ ಇಲ್ಲಿಗೆ ಬರೋ ತನಕ ಅಬ್ಸರ್ವ್ಡ್ ಬೇರೆ ಆಗಿದೆ, ಆಮೇಲೆ ಇದು ಬೇರೆ ಆಗಿದೆ, ಯಾವುದದು ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್. ಎರಡು ಕೂಡ ಬೇರೆ ಬೇರೆ ವ್ಯಾಲ್ಯೂಸ್ ಬಂದಿದ್ದಾವೆ. ಇವು ಯಾವ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಈ ಎಲಿಮೆಂಟ್ಸನ್ನು ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಂದ್ರೆ ದೇ ಆರ್ ಆ್ಯಕ್ಚುಲಿ ಯಾವ ಎಲಿಮೆಂಟ್ಸ್ಗೆ ಬೇರೆ ಬೇರೆ ಆಗ್ತವೆ. ಎಕ್ಸ್ ಯಾವುದು, ವೈ ಯಾವುದು, ಝೆಡ್ ಯಾವುದು, ಈ ಮೂರು ಎಲಿಮೆಂಟ್ಸನ್ನು ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ನೀವು ನೋಡ್ಬೋದು ಸ್ಕ್ಯಾಂಡಿಯಮ್, ಟೈಟಾನಿಯಂ, ವ್ಯಾನಡಿಯಂ, ಕ್ರೋಮಿಯಂ, ಮ್ಯಾಂಗನೀಸ್ ಕಮ್ಮಿ ಆಗಿದೆ. ಸೊ ಮ್ಯಾಂಗನೀಸ್ ಕಮ್ಮಿ ಆಗ್ಲಿಕ್ಕೆ ಕಾರಣ ಅದರ ಲೋವರ್ ಸೆಕೆಂಡ್ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಮೋರ್ ನೆಗೆಟಿವ್ ಅದಕ್ಕಿರುತ್ತೆ. ದೇರ್ ಫೋರ್ ವೆನ್ ವಿ ಕನ್ಸಿಡರ್ ದ್ಯಾಟ್ ಎಕ್ಸ್ ಶುಡ್ ಬಿ ಮ್ಯಾಂಗನೀಸ್, ದೆನ್ ಕಮ್ಸ್ ವೈ ಆ್ಯಂಡ್ ಝೆಡ್. ವೈ ಆ್ಯಂಡ್ ಝೆಡ್ ಪೊಸಿಷನ್ಸ್ನಲ್ಲಿ ಕೊಬಾಲ್ಟ್ ಆ್ಯಂಡ್ ನಿಕೆಲ್ ಇರಬೇಕು. ಅದರ ನೆಕ್ಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಆದ ಕಾಪರ್ಗೆ ತುಂಬ ಹೈಯರ್ ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೆ. ಸೊ ಈ ಎರಡು ಡಿವಿಯೇಷನ್ಸ್ ಕೂಡ ಕೊಬಾಲ್ಟ್ ಆ್ಯಂಡ್ ನಿಕೆಲ್ ಅಂತ ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕು. ಲೆಟ್ಸ್ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟ್. So it's option number 2 which is correct. Let's move to the next important question, and just excuse me before that. It is 62nd question we are talking about. Let's analyze that. Statement 1. D block elements do not follow the theory of valence is wrong. Like every other element, D block elements also follow theory of valence. Theory of valence means octet rule. Octet rule anna kandita follow agtave except in 1 or 2 cases. Therefore, we cannot say all D block elements do not follow theory of valence. Therefore, there is a clear statement given in the textbook that D block elements are not separately treated with respect to theory of valence. They come under the category of theory of valence valid compounds. So yes, that particular statement is a false statement. Metals with very high enthalpy of atomization tend to be noble in their reactivity. This is true. You have certain metals, for example, minus 0.76 volt dondige zinc ide, minus 0.44 volt dondige iron ide. Amele we have other elements like copper, gold, ivella kuda. ಈ ಎಲಿಮೆಂಟ್ಸ್ಗಿಂತ ಕೂಡ ಆ ಎಲಿಮೆಂಟ್ಸ್ಗೆ ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂಸ್ 0.34 1.4 ವೋಲ್ಟ್ ಈ ಥರ ಅದಾವೆ. ಈ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್ಸ್ ಜಾಸ್ತಿ ಆಗಲಿಕ್ಕೆ ಕಾರಣ ಆ ಎರಡು ಎಲಿಮೆಂಟ್ಸ್ನಲ್ಲಿ ಕೂಡ ಹೈ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಆಟಮೈಸೇಷನ್ ಇರೋದು. ಹೈ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಆಟಮೈಸೇಷನ್ ಇದ್ದರೆ ಮೋರ್ ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಇ ನಾಟ್ ಬರುತ್ತೆ. ಮೋರ್ ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಇ ನಾಟ್ ಬಂದರೆ ರಿಯಾಕ್ಟಿವಿಟಿ ಬಹಳ ಕಮ್ಮಿ ಆಗುತ್ತೆ. ನಿಮ್ಮೆಲ್ಲರಿಗೂ ಗೊತ್ತು, ಗೋಲ್ಡ್ ಈಸ್ ಲೆಸ್ ರಿಯಾಕ್ಟಿವ್ ಕಂಪೇರ್ಡ್ ಟು ದ ರೆಸ್ಟ್ ಆಫ್ ದ ಮೆಟಲ್ಸ್ ಗಿವನ್ ಹಿಯರ್. ಸೊ ರಿಯಾಕ್ಟಿವಿಟಿ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ಇ ನಾಟ್ ವ್ಯಾಲ್ಯೂಸ್. E naught values depend upon enthalpy of atomization. Higher is the enthalpy of atomization, higher is the E naught value. Higher is the E naught value, lower is the reactivity. Idu order. So I can write it as reactivity is inversely proportional to SRP value, which is further inversely proportional to enthalpy of atomization. That means SRP and enthalpy of atomization are directly proportional. Next statement. 63. Maximum oxidation states of reasonable stability correspond to sum of number of Ns electrons and N-1d electrons up to manganese. This is statement. Maximum oxidation state, scandium, titanium, vanadium, chromium, manganese vargu nodidare idaralli 4s2 3d3 3d1 4s2 3d3 3d2 4s2 3d3 4s1 3d5 4s2 3d5 configurations anna ivu hondidave. ಈಗ 2+1 maximum oxidation state, 2+2 maximum oxidation state ಈ ತರಹ ಅದಾವೆ. ಅವರೇನು ಹೇಳ್ತಿದ್ದಾರೆ, maximum oxidation state of reasonable stability corresponds to sum of number of Ns electrons plus N-1d electrons ಅಂತಿದ್ದಾರೆ. N-1d electrons up to manganese ಎಷ್ಟೆಷ್ಟು ಅದಾವೋ ಅವೆಲ್ಲ ಕೂಡ ಕರೆಕ್ಟೇ ತಾನೆ. 2+1 is +3, 2+2 is +4, 5, 6, 7 up to definitely manganese. This is true. Statement 2, CO is a pi acceptor ligand. Yes, CO is a pi acceptor ligand. That's also a correct statement. Next question. The correct statement. The observed and calculated spin only magnetic moments of CO plus 2 are same. Magnetic moments ke barovargu iron, cobalt, nickel, copper galige observed and calculated magnetic moments eniruttave, they are different. So they are not same. That's a wrong statement. V2O5 forms both vanadate and VO plus 2. When we consider that is a correct statement. V2O5 is amphoteric. V2O5 amphoteric ಆಗಿ ಇರುವುದರಿಂದ okay. So when we consider V2O5 vanadate ion ಅನ್ನು ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ, but in acidic condition it does not form VO2 plus, instead it forms VO2 plus ಈ ತರಹ. Therefore that statement is a false statement. Next one. Larger the ion is more negative, ಈಸ್ ಇಟ್ಸ್ ಹೈಡ್ರೇಷನ್ ಎಂಥಾಲ್ಪಿ. ಇದು ತಪ್ಪು ಸ್ಟೇಟ್ಮೆಂಟ್. ಎಷ್ಟು ಜಾಸ್ತಿ ದೊಡ್ಡದು ಅಯಾನ್ ಇದ್ದರೆ ಅಷ್ಟು ಕಮ್ಮಿ ಎಲೆಕ್ಟ್ರೋನೆಗೇಟಿವಿಟಿಯನ್ನು ಅಷ್ಟು ಕಮ್ಮಿ ಹೈಡ್ರೇಷನನ್ನು ಅದು ಹೊಂದಿರುತ್ತೆ. ಆಲ್ರೆಡಿ ನಾನು ಹೇಳಿದ್ದೀನಿ, ಲಾರ್ಜರ್ ಅಯಾನ್ಗೆ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಜಾಸ್ತಿ ಅಟ್ರಾಕ್ಟ್ ಆಗಲ್ಲ ಅನ್ನೋ ವಿಷಯವನ್ನು ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕು. ನೆಕ್ಸ್ಟ್ ಒನ್, higher the charge on both cation and anion, higher is the ionic character. Therefore, when we consider here, higher the charge on cation and anion, ಈಗ ಹೇಳಿದ್ದೀನಿ covalent character is directly proportional to charge on cation and anion. Therefore, we need to say that statement is also false statement. ನಾಲ್ಕು ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ನಲ್ಲಿ ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಯಾವುದಿರುತ್ತೆ ಅಂತಂದರೆ 4 ಕೂಡ ಫಾಲ್ಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್ಸೇ. ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್ನಲ್ಲಿ ಒಂದು ಕರೆಕ್ಷನ್ ಆಗಬೇಕು, ಅದು VO2+. ಅದಾದರೆ ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕರೆಕ್ಟ್ ಆನ್ಸರ್ ಆಗುತ್ತೆ. ಯಾಕಂದರೆ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ CO+2ಗೆ ಸ್ಪಿನ್ ಓನ್ಲಿ ಅಬ್ಸರ್ವ್ಡ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟ್ಸ್ ಅನ್ನೋವು ಈಕ್ವಲ್ ಆಗಲ್ಲ, ದೇ ಆರ್ ಡಿಫ್ರೆಂಟ್. ಆ್ಯಂಡ್ V2O5 VO+2 ಫಾರ್ಮ್ ಮಾಡಲ್ಲ, VO2+ ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ. ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಏನು ಚೇಂಜ್ ಆಗಲ್ಲ, ಇಟ್ ಶುಡ್ ಬಿ ದ ಸೇಮ್. And then larger the ion, more negative hydration enthalpy tappu. And then higher the charge on both cation and anion is, higher is the ionic character kuda tappagutte. 65th next question nodona. ಈ ಕ್ವೆಶ್ಚನ್ ನಲ್ಲಿ 2 ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಆ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಅನ್ನು ವೆರಿಫೈ ಮಾಡೋಣ. Mn+2 aqueous is more stable than Mn+7 aqueous. 100% ಇದು ಕರೆಕ್ಟ್. ಯಾಕಂದರೆ Mn+7 ಅನ್ನು ಸ್ಟೆಬಿಲೈಸ್ ಮಾಡೋದು ತುಂಬ ಕಷ್ಟ. Mn+2ನಲ್ಲಿ 3D5 ಕಾನ್ಫಿಗರೇಷನ್ ಇರೋದ್ರಿಂದ ಇದು ಸ್ಟೆಬಿಲೈಸ್ ಆಗತ್ತೆ ಈಸಿಲಿ ಬಿಕಾಸ್ ಆಫ್ ಸ್ಪ್ಲಿಟ್ಟಿಂಗ್. ಇದರಲ್ಲಿ 3D0 ಕಾನ್ಫಿಗರೇಷನ್ ಇರೋದ್ರಿಂದ ಸ್ಟೆಬಿಲಿಟಿ ಅನ್ನೋದು ಇರಲ್ಲ, ಬಿಕಾಸ್ ದೇರ್ ಇಸ್ ನೋ ಸ್ಪ್ಲಿಟ್ಟಿಂಗ್ ಇನ್ ಏಕ್ವಿಯಸ್ ಸ್ಟೇಟ್. ಇಲ್ಲಿ ಸ್ಪ್ಲಿಟ್ಟಿಂಗ್ ಇಲ್ಲ, CFSE ಇಲ್ಲ, ಇಲ್ಲಿ CFSE ಇದೆ, ಸ್ಟೇಬಲ್ ಆಗುತ್ತೆ. ಸೊ ದ್ಯಾಟ್ ಈಸ್ ಅ ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್. Cr+6 is more stable than Cr+3 aqueous. ಅದು ಕೂಡ ತಪ್ಪು ಸ್ಟೇಟ್ಮೆಂಟೇ. Cr+3ನಲ್ಲಿ ಕೂಡ ಇದು 3D0, ಇದು 3D3, ಆದರೆ ಇದರಲ್ಲಿ CFSE ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೆ. ಇದರಲ್ಲಿ 3D0 ಇರೋದ್ರಿಂದ CFSEಗೆ ಅವಕಾಶನೇ ಇಲ್ಲ. ಸೊ ಅದು ಕೂಡ ತಪ್ಪು ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಗತ್ತೆ, ಇದು ತಪ್ಪು ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಗತ್ತೆ. ಸೊ ಸ್ಟೇಟ್ಮೆಂಟ್ 1 is true, ಸ್ಟೇಟ್ಮೆಂಟ್ 2 is false. ಅದು ಕರೆಕ್ಟ್ ಆನ್ಸರ್. ಮೂವಿಂಗ್ ಆನ್, ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. The spin-only magnetic moment of in Bohr magnetons or Nickel+2 is, Nickel+2 consider ಮಾಡಿದಾಗ configuration Nickel+2 4s2 3d8 configuration, 3d8 ಉಳಿದಿರುತ್ತೆ. 3d8 ಉಳಿದಿದ್ರೆ 2 unpaired electrons ಬರ್ತವೆ. ಆವಾಗ mu equals root over n into n+2, ಅಂದರೆ mu equals root over 2 into 2+2, 2 4s are 8, 2 root 2, 2 into 1.414, which is 2.828 magnetic moment barutte. So this is what we get. So what we understand here is 2.84 is the correct answer, option number 1. ಈ ಕ್ವೆಶ್ಚನ್ ನಲ್ಲಿ ನಾವಿಷ್ಟು ಮಾಡುವ ಅವಶ್ಯಕತೆ ಕೂಡ ಇಲ್ಲ. ಇದರಲ್ಲಿ ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾಗಿದ್ದ ಪಾಯಿಂಟ್ ಏನು ಅಂತಂದರೆ, Nickel+2ನಲ್ಲಿ ಈ 2 ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬಂದಿದ್ದಾವಂದರೆ ಆನ್ಸರ್ ಖಂಡಿತ 2 ಪಾಯಿಂಟ್ ಸಮಥಿಂಗ್ ಆಗಿರುತ್ತೆ ಅಷ್ಟೇ. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್, 67th ಕ್ವೆಶ್ಚನ್ ನೋಡೋಣ. ಇದರಲ್ಲಿ Chromium+2 ಈಸ್ ರೆಡ್ಯೂಸಿಂಗ್, Mn+3 ಈಸ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ when both have D4 configuration ಅಂತ ಅಂದರು. ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕರೆಕ್ಟೇನಾ? Cr+2 ಖಂಡಿತ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟೇ. Mn+3 ಏನಿದೆ ಅದು ಖಂಡಿತ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟೇ. ಇದು ಕರೆಕ್ಟೇ. ಕಾರಣ ಏನಂದರೆ Cr+3ನಲ್ಲಿ 3D4 ಕಾನ್ಫಿಗರೇಷನ್ 3D3 ಆಗುತ್ತೆ, Mn+3ನಲ್ಲಿ 3D4 3D5 ಆಗುತ್ತೆ. ಕಾರಣ ಏನಂದರೆ Mn+3ಗೆ 3D5 ಮೋರ್ ಸ್ಟೇಬಲ್, 3D4 Cr+2ಗೆ 3D3 ಮೋರ್ ಸ್ಟೇಬಲ್. ಹಾಗಾಗಿ ದಟ್ಸ್ ಅ ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ದ ಲೋ E0 M+3 M+2 ಆಫ್ scandium reflects stability of scandium+3 which has a noble gas configuration. Correct answer. ಯಾಕಂದರೆ ಈ scandium+3 4s2 3D1 ಕಾನ್ಫಿಗರೇಷನ್ನಲ್ಲಿ ಸ್ಕ್ಯಾಂಡಿಯಮ್ +2 ಅಂದರೆ 4s1, ಆರ್ಗಾನ್ 4s1. ಆ ಒಂದು ಕಳ್ಕೊಂಡ್ರೆ ಅದಕ್ಕೆ ಆರ್ಗಾನ್ ಕಾನ್ಫಿಗರೇಷನ್ ಬರುತ್ತೆ, ಅಂದರೆ ಅದು ಸ್ಟೆಬಿಲಿಟಿಯನ್ನು ಪಡೆಯುತ್ತೆ. ದೇರ್ ಫೋರ್ ಅದು ಎಷ್ಟು ಆ ಥರ ಎಲೆಕ್ಟ್ರಾನ್ಸನ್ನು ಕಳ್ಕೊಳ್ಳುತ್ತೆ ಅಷ್ಟು ಸ್ಟೆಬಿಲಿಟಿ ಬರ್ತಾ ಇದೆ ಅಲ್ವಾ 3ನಲ್ಲಿ, ಅಂದರೆ +2 ರಿಂದ +3 ಟ್ರಾನ್ಸಿಷನ್ನಲ್ಲಿ ಇಟ್ ಈಸ್ ಗೈನಿಂಗ್ ಸ್ಟೆಬಿಲಿಟಿ. ದೇರ್ ಫೋರ್ ಇಟ್ ಲೂಸಸ್ ದಮ್ ರೆಡಿಲಿ. ಥರ್ಡ್ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಗೆಟ್ಸ್ ವೆರಿ ಮಚ್ ಲೋ. When third ionization enthalpy gets very much low, the scandium +3 to +2 value will be definitely lower than expected. This is what we need to understand. Let's move to the next question. The next question that we need to understand here is the low E0 m+3/m+2 of scandium. Adana discuss madidvi, so that's a correct statement. Therefore, first statement is actually correct statement. Second statement, reason is also correct, assertion is correct, reason is correct, but reason does not explain assertion. Last question nodana. Mn+2 is more stable than Cr+3 in aqueous solution. When we consider that, yes, Mn+2 3d5 is more stable compared to that of 3d3. That is correct. Cr+3 is more stable than Fe+3. Adu kuda correct statement ಆಗುತ್ತೆ. Cr+3 is definitely more stable than Fe+3. ಹೀಗೆ ಹೇಳಿದ್ದೀನಿ ನಾನು, ಯಾಕಂದರೆ Cr+3 3d3 ಇದ್ದರೂ Fe+3 ನಲ್ಲಿ 3d5 ಇದ್ದರೂ ಕೂಡ Cr+3 ನಲ್ಲಿ ಮೋರ್ CFSC ವ್ಯಾಲ್ಯೂ ಬಂದಿರೋದ್ರಿಂದ ಅದು ಸ್ಟೇಬಲ್. ಇದರಲ್ಲಿ ಮೋರ್ CFSC ವ್ಯಾಲ್ಯೂ ಇದರಲ್ಲಿರುತ್ತೆ, ಅದಕ್ಕಲ್ಲ. ಸೊ ಇದು ಮೋರ್ ಸ್ಟೇಬಲ್ ದ್ಯಾನ್ ದಟ್ ಒನ್, ಇದು ಮೋರ್ ಸ್ಟೇಬಲ್ ದ್ಯಾನ್ Fe+2. ನೆಕ್ಸ್ಟ್ ಒನ್, Vanadium+2 is less stable than Cr+3. ಅದು ಕೂಡ ಕರೆಕ್ಟೇ. Cr+3ಗೆ higher CFS ಇರುತ್ತೆ Vanadium+2ಗಿಂತ. Therefore, that is also a correct statement. So, if you write a proper stability order in aqueous state, Mn+2 is more stable compared to that of Cr+3, compared to that of Fe+2, and compared to that of, Fe+3 compared to that of Vanadium+2 ಅಂತ ನಾವು ಯೋಚನೆಯನ್ನು ಮಾಡಬೇಕು. This is correct an order of stability of these ions due to higher CFSC values, even though the configurations look almost the same for all of them. So here we shall stop for today and discuss the rest of the questions tomorrow.